Hello everyone. Do let me know if we are audible and visible, and especially the entire NEET English Warriors team. Are we seen? Are we audible? Yes, Gopika ma'am, Baswa sir, Diksha ma'am.
Hello students.
Hi everyone.
Students, let us know in the comment section if we are audible to everyone and visible.
I guess yes, we are.
We are live.
Oh
We are
my
live.
god. So
Okay.
how much time did you guys take to get ready, guys?
That's not a lot, sir. Not a lot.
So see guys, we are all decked up because this is a special day, not just Republic Day obviously, but also the beginning of our NCERT line by line, which is one of its kind, because we're going to do 2000 plus questions, and in every session we are going to do around 400 questions. Is that right, sir, ma'am?
Or even more, right?
Yeah, even more. Correct. So how did you guys celebrate the Republic Day? Because see, our Republic Day, you can see how we are celebrating. We were preparing the slides, we were making the content. That's how we celebrated the Republic Day. What about you guys? Just let us know in the comments. Okay, come on, start putting up. And who was your favorite person, yeah, in the shot?
Let us know in the comment section who was your favorite.
Diksha ma'am, you want to say something because I know you have another class. You want to say any
Yeah. So I just want to say Happy Republic Day, guys. I'm wishing you all the very best for your exams, and always remember, you guys are the future of our country. So work hard, work hard. We need doctors like you, right? So our country's future is in your hands. So work hard, prepare well, be an amazing doctor, and serve this nation. Always remember that. And I have another class right now, so I'll see you at when it's my turn at around 8 or 9 p.m. Okay, I'll see you back after that.
Cool.
And today we are going to do DNF block line by line series, and as you all know, inorganic, everything, all the questions from inorganic are from each line of your NCERT. Nothing after that. Okay, so I just want all of you to join this session and give the answers. Even if you're not able to give the answers, you will learn something surely. So do join the session, and see you all.
And do you guys see one thing? We are in the color code of the Indian flag. We have at least tried to. I don't know how many of you realize. So please take a picture of us and tag us on Instagram, guys. We'll just pose for a second. Click this picture. Yo. Great. Thank you so much, ma'am. Thank you so much.
Okay, guys. See you all.
Bye, Diksha.
Bye.
So Baswa sir is the Ashoka Chakra, and Gopika ma'am is the white color in the flag. That's what it is.
Yes.
Great. So all set, Gopika ma'am, Baswa sir, for the session.
Yes. Totally. So students, we will be doing the chapter
sexual reproduction in flowering plants and human reproduction. So both of us will be live today. We both will be doing both botany and zoology, because we know both botany and zoology.
And students
Wow.
will be coming live together. It's not going to be like Gopika ma'am will come first, then I will come. Both of us are going to be on the screen together, teaching you every line of NCERT, making you solve questions from every line of NCERT. That is the goal of today.
Yes.
Wow.
Yes.
This is going to be epic. Can't wait for it. So all the best, guys. I will be seeing you very soon. Say bye-bye
Yes.
to Gopika ma'am and Baswa sir. They'll be back very soon. Don't go anywhere. We'll start with physics now. Okay, so gear up. Thank you so much.
Once physics is over, Gopika ma'am
We both will be coming.
Wow, this is going to be
Yes.
deadly
So
combo.
students, do not leave in between. Stay throughout, because you will not have to study the chapter later once you're solving this paper with us, because you will know answers of every important verse. We'll also try maximum to give you at least one line explanation for each of it. So see you all for both botany and zoology.
Yes.
And let's have an amazing session on Republic Day, because we are the only ones in the office, to be frank.
Everyone is gone home doing something.
Yes.
So,
All right.
Okay, sir. See you. Bye.
Bye. Okay, so there we go. Let's just open up our session. Where is it? Right over here. Okay, so that was your amazing NEET English Warriors team. Let me just set up my chats properly. Just give me a second. And there we go. Yes, it's all set. Perfect. So let's begin with the NCERT line by line, complete NCERT. Every session will have around 400 plus questions from all the teachers together, and in the matter of just few sessions we'll be done with 2000 plus questions. And if you like, and if you comment on this video after the session ends, then we will probably make it even more, but that depends on you, not on me, not on anybody else. It depends completely on you. So my dear warriors, are you ready to make this session very popular? Do make this session the best of the best on the Vedantu NEET English channel. So it's all in your hands by smashing the like button. And some of you might have missed the announcement which I made yesterday. So 5 full length 5 part test series based on the latest syllabus and with the same difficulty as the NEET. Every Sunday there will be a test. This will happen on the platform, and this test is called as the victory test, and it's absolutely free of cost. It's absolutely free of cost. Keep this in mind. 1 second. Second. Yes, it's absolutely free of cost. The link is there in the description box below. Enroll in it now, because that test series is available for free of cost only till midnight today, and after that you will not be able to enroll for free of cost. It will be for 999 rupees. This is the schedule of the test. You can see every Sunday there is a test from 2 o'clock to 5 o'clock, right? So make sure you are checking this link out, and it's there in the description. Sign up and also register in case you have not made your Vedantu account yet. Thank you so much. Thank you so much. Happy Republic Day to all of you. Happy Republic Day to all of you, all my warriors, all the WPs, all the warrior Pandus. Whistle blowing for their amazing master teachers out here. Already enrolled. Very good, Avi. And so many of you have already started with your preparation. Great. So let's begin with this lecture. And your captain is live. After that, you will have biology, and after that, you will have chemistry. Here comes the first question on your screen now. It's filling the blanks, completely based out of NCERT, which will help you for NEET, obviously for boards also. Yes, you should know each and every line of NCERT, and I have chosen all the important lines, and it will be a real fun session when you start answering in the chat box. So spam in the chat box. You are completely allowed. Don't spam anything else, or else the admin will block you. So come on, start spamming. What the answer will be? The electric charge is quantized, which means the charge of any object is an integral multiple of the elementary charge denoted as E. The value of E. What is the value of E, my dear warriors? What is the value of E? The value of E. Yes, it is nothing but 1. Where did it go? Yes, it is 1.6 into 10 to the power minus 19 coulomb. 1.6 10 to the power minus 19 coulomb. Very good. Sometimes this value is also used for current calculations and all of that. So that's why you should know these particular values. Very good. Next question. According to the Coulomb's law, the force between 2 point charges is directly proportional to the product of the charges, inversely proportional to the square of the distance between them. What is the formula of the force given by? What is the formula of the electric force given by? Come on, my dear students, you should be able to get this very easily. Yes, directly proportional to the product of the charges, that means Q1, Q2, and inversely proportional to the square of the distance between them, that means 1 by r square. So hence, the answer for this particular question should be none other than F is equal to 1 by 4 pi epsilon naught. Here you will have Q1, Q2, and here you will have r square. Come on, my dear students, quickly think and tell me what is the value of this whole number. It is nothing but 9 into 10 to the power 9. 9 into 10 to the power 9, that is also called as your Coulomb constant. That is also called as your Coulomb constant. Is that right? Everybody with me? Very good. Yes, that's the Coulomb constant, 9 into 10 to the power 9. Epsilon naught is called as the permittivity of that vacuum. Permittivity of the vacuum. The SI unit of electric charge. What is the SI unit of electric charge, my dear warriors? Yep, it is coulomb. And how many of you knew this, CGS unit of electric charge? It is basically called as ESU, or sometimes also called as stat coulomb. ESU, keep this in mind. Sometimes a direct question might come in NEET or in boards, and 1 coulomb is 3 into 10 to the power 9 ESU. That is CGS unit. Write it down in your notes in case it was not there. Yes, in case it was not there, put it up in your notes. Okay, ESU, which is CGS unit, and 1 coulomb is 3 into 10 to the power 9 ESU. Keep this in mind. Next question. Electric field intensity at a point is defined as the force per unit dash acting on a dash charge placed at a point. What are the two blanks that are going to fill it up over here? Electric field intensity at a point is defined as the force per unit what? And acting on a dash charge, dash test charge. Okay, force per unit, what should it be? Charge. And acting on a positive test charge. Acting on a positive test charge. Very good. Always it is defined for positive charge. Keep this in mind. So this is how it goes. Electric field definition. Electric field definition is the force acting per unit test charge. That is how it is. This is in Newton per coulomb. Newtons per coulomb, right? Keep this in mind. Moving on to the next one. The direction of the electric field at a point is the direction of the dash experienced by a dash placed at the point. Is the direction of which quantity? Think the first filling the blank will have the same direction of the field, and the next filling the blank will be a thing which is experiencing this particular quantity, which is the filling the blank. Obviously electric field is in the same direction as the force acting on a positive test charge. Yes, it is the same as the direction of the force acting on a positive test charge. How many of you are writing it down? Come on, spam the answers. Yes, if you just wrote charge, it is not correct. Positive test charge is very important. Negative test charge will change the direction. It will make it opposite. Always take positive to test something. When your mom is cooking, or your dad is cooking, or your elder brother or sister is cooking, what do? Nicely, sambar is made like this. Salt is less, garam masala is less. MTR garam masala, we need to add little bit, or sambar powder we need to add. That's what they do, not they test it. So there they taste it, here we use the test. So very similar. So this is a positive test charge, not the tasty charge. Okay. Next one. For a system of point charges Q1, Q2, Q3, total electric field at a point is the dash sum of the electric field due to each charge. So if you have many charges, then what happens, my dear warriors? Come on, think about it. If you have many charges, then the electric field due to each one of them, will have to be added. But how? Vectorially. The net electric field will be added vectorially. E1 plus E2 plus E3, like that. These are all vectors. You will add them vectorially. Hence the answer will be vector sum. Very good. Very good, Vishnu, Sarath, very good, Avi, very good, Rojban, very good. And I just hope my screen does not give up on me. My screen is shaking like this, not because of earthquake, some software error. Nicely it is vibrating. So, okay, just please don't give up on me. Okay, the electric field due to a point charge Q at a distance is given by KQ by R square, where E is in what units? What is the unit of electric field? Tell me, there are 2 units. Let's see how many of you are able to put up both the units of electric field. How many of you are able to put up both the units of the electric field in the chat box right away, right now? Yes, what is the answer, my dear warriors? What is the answer, my dear warriors? Come on, what are both the units of the electric field? Yes, one is joules per coulomb, very good. And the other one is volts per meter. Both are the correct units of the electric field. The joules per coulomb. And sorry, 1 second. Electric field, volt per meter. Yes, yeah, perfect, no problem. This is not supposed to be joules per coulomb, my bad. This is supposed to be Newton per coulomb. I don't know why it is joules. This is supposed to be Newton per coulomb, not joules. That would be potential. This is Newton per coulomb or volt per meter. My bad. Yes. So it will be Newton per coulomb or volt per meter, not joules. Yes. Very nice. Let's move to the next one coming up on your screen. Okay. I will get it corrected later on. Don't worry. Next one. The dash of the dash in electric states that the total force on a charge is the vector sum of the forces exerted by all the charges. The dash of dash. Think about it. What is the right phrase or words which will fit in? That the total force by all the charges is the vector sum. Is the vector sum. Come on, think about it. Okay. Dr. Strange, it is called groom. Groom is for the guys, bride is for the girls. Okay, cool. What is the answer for this, my dear warriors? Come on, think about it. The dash of the dash in electrostatic states that the total electric force on a charge is the what? Yes, it's the principle of superposition. It's the principle of superposition. Very good, very good, very good. Yeah, the principle of superposition says that all the forces can be added up and you will get the net force. Correct. Moving on. The electric potential energy between 2 point charges is given by this, where U is measured in. What is this U? What is it measured in? What is the, think about it. What is the unit of it? Yep, this is the formula K Q1 Q2 by R. Not R square. K Q1 Q2 by R is the formula for potential energy. And any kind of energy is always measured in either joules or in ergs. Is measured in joules or in ergs. Correct. Correct. Very good. Very good. Very good. Moving on to the next question coming up on your screen. The electric V at a point is defined as the electric dash per unit dash at that point. Come on, answer the 10th question coming up on your screen. Already on to the 10th question. Come on, my dear warriors. Yes, some people who might be watching this session after a few more days or a month or so, imagine what they will be thinking. Maybe this teacher ran away from the marriage or something, or maybe after this he has to eagerly marry someone. Maybe he has to marry Champa or something, right? So that's why this sir is like this in this dress. So it's okay. Don't worry. Let's keep them in suspense. If they have skipped the first part, they wouldn't know. Hai na? Alright. So what is the answer for that? Electric potential is the electric potential energy per unit charge. Per unit test charge at that point. So my dear warriors, the formula goes like this. V is U, which is energy per charge. U by Q. So it is energy per unit charge. Correct. SI unit of electric field intensity. Electric field intensity is how much? Good evening, Vision. SI unit of electric field intensity is how much? Come on, my dear warriors. The SI unit of electric field intensity is, yes, electric field, volts per meter, Newton per coulomb. Why is it coming again joules per? This is wrong. Yes, this is going to be Newton per coulomb. Newton per coulomb or volts per meter. Electric field intensity, electric field strength, electric field, or force per unit charge, all these things mean the same thing. Lines of electric lines of force, electric field strength, electric field intensity, electric field, force per unit charge of electricity, all of them means electric field only. Next one coming up on your screen. The work done in moving a unit positive charge from infinity to a point in an electric field is known as the dash at that point. Is known at the dash at that point. Come on, my dear warriors. And as you are watching the session, make sure you are smashing the like button and also subscribing to the channel. Come on. What do you think? The work done in moving a unit positive charge from infinity to a point in a field is known as the what? It's the work per unit charge, joules per coulomb. That is nothing but potential. Electric potential at that point. Yes, very good. Electrical potential. That's the definition of it. From infinity you come to that point and the work done per charge, joules per coulomb, is the potential. Question number 13. Very good. Keep it going. Keep it going. I can see many of you are answering the questions correctly. And the more people answer these questions correctly, I'll feel very happy. Even if you copy the answers, it's okay. At least it is registering in your head. Even if you do not know this chapter, it is okay. At least something will go in your head. If you learn at least 10% from today's class, I would be very, very happy. Moving on. If two charges are separated by distance d in vacuum, charges are doubled, the electric force between them will be dash times the original force. Come on. If the two charges are separated by distance d and the charges are doubled, the electric force will be made 2 times, 4 times, 5 times, 6 times. How many times? 4 times, because what is the formula? What is the formula for the electric force? F is nothing but K Q1 Q2 divided by R square, right? Now just imagine this. This charge is made 2 times. This charge is also made 2 times. Totally you have made it 2 into 2, 4 times. So that means the force will also be made, LHS will be also made 4 times. RHS is made of 2 into 2. So our LHS is also made 2 into 2, which is 4 number of times. That's the answer. In a uniform electric field, the lines of force are dash and dash spaced. Something about the spacing and something else also. And that too, it is mentioned the field is uniform. What is so special about uniform field? In case of a uniform electric field, the electric field is constant and the spacing between the lines is same. It is equal. Yes, you will see that no matter how far you go, the electric field will be the same and the spacing is equal. Whatever distance is there between any two lines, it will be the same. That's what it is. Next question. Electric field inside a conductor in an electric equilibrium is always. Electric field inside a conductor, what is it? Come on, try to recollect. Electric field inside a inductor for electrical equilibrium. There is a standard thing for it. What is it? Yes, it is going to be 0. And that is a standard thing. Remember, electric field is always 0 inside a conductor, not insulator, inside a conductor like metals, copper, aluminium, iron. You will see electric field inside the conductor. Anywhere you go will be a big fat 0. Next one. A parallel plate capacitor is given by this particular formula where epsilon naught, oh come on, this is straightforward. Epsilon naught is nothing but, what is epsilon naught? Vision, don't worry if it is not opening. Later on you can try it, okay? And you can definitely get in touch with us through either Telegram or the Vedantu support team, vcare at vedantu.com. So just write a mail. I think the problem should be resolved. Yes, epsilon naught is always the permittivity of free space, and you should remember this formula. Capacitance of a parallel plate capacitor is epsilon naught A by D. Epsilon naught is permittivity, A is the area of the plate, and D is the distance between the two plates. Keep this in mind. Next one. The distance between two charges is half. The force between them will become how many times? The force between them will become how many times? Come on, the distance between the two charges is halved. The formula for electric force is K Q1 Q2 divided by R square. So now what we are doing is this distance I am making it half. So square it. So when I square half, it will become 1 by 4. It will become 1 by 4. But that 4 will go on the top in the numerator. That means the force should also become 4 times. The force should become 4 times because distance has been reduced. So force will increase. So hence the answer is 4 times. Very good. Next one. Gauss law states that the total electric flux through a closed surface is 1 by epsilon naught times the dash enclosed by the surface. If you remember what Gauss law is, I think it will be very, very straightforward. Gauss law says that the total electric flux in a closed surface is given by something by epsilon naught. What is that something? What is that something? It is always the net charge which is enclosed, the total charge which is enclosed. Exactly. So it is the net charge which is inside, not just charge, the total charge, the net charge. Okay, so the word used will be total charge, not just one of the charges, the sum of the charges, positive, negative, anything. Moving on to the next one coming up on your screen. Presence and the magnitude of an electric field are detected by the dash exerted on the charge. This is very straightforward. The presence and the magnitude of the field, electric field is there. How do I know it? How do I know there is electric field? I will take a charge. I will see that it experiences what? It will experience force. The moment it starts moving, it experiences force. I know, oh, there is electric field. If there is no electric field, the charge will not experience force. Okay, electric fields can only exert forces on charges. Next one, the potential difference between 2 points in an electric field is measured in. The potential difference, potential difference, same like displacement and change in position. Change in position is in meters, displacement is in meters, position is in meters. Same way, voltage is measured in volts, potential is measured in volts, potential difference is also measured in volts. So hence the answer will be big fat volts. Very good. Cash on the channel, Janani, awesomeness, Sharat, very good Rajan, very good Pavish, kudos. Next one, electric potential at a point due to a single point charge is dash of the charge. Electric potential, a little bit tricky one. Let's see how many of you can get this. Electric potential at a point due to a single point charge is dash of the charge. What might be the right phrases that can fit in? You can think of many things, but there will be few things which will fit together over here. Think about it. The electric field due to a single charge. Remember the formula, it is kq by r. kq by r. It is proportional to the charge and inversely proportional to the distance. And you will see, I think due to a single point charge is independent of the path taken by the charge. Yes, that can be also fit in over here. Yes, no problems. So if you try to find the electric potential at a point, then no matter how you bring the charge, from anywhere, it will be independent of it. It will be independent of it, and it will not be dependent on the manner in which you got it. It just depends on what is the charge and where are you placing it. That's all. It is not dependent on the path taken by the charge. In a non-uniform electric field, the electric field lines are non-uniform. Come on, think about it. Yes, come on, think about it. What will happen in a non-uniform electric field? That means the field lines are not going to be parallel. They are not going to be constant. So they will be either spreading or they will be curved. So one of these things, yes, they will not be parallel or they will be curved in nature. They will be not parallel to each other, definitely, because it is non-uniform. They will be like this or like this, and they will be curved maybe. So somewhere it is strong, somewhere it is weak. All these things can happen. Yes, spacing will be different. Yes, perfecto. Just random, correct. Very good. The energy, guys, by the way, let me tell you, don't get scared. Sir, I did not get the exact words. It's okay. If you are meaning or thinking the same thing, almost the words are similar, it is okay. You are understanding the concept. That is mainly important, because in the objective exam, obviously you will have options. This is just to provoke your thoughts, because when you have options, it's a very different thing. When you don't have options, you will start thinking, what can it be? What can be the best way? So that is what is the aim of these sessions. Energy stored in a capacitor is given by the formula where U is measured in joules. What's the formula, guys? Potential energy. There are many formulas of writing potential energy. One of them is half CV square. Very good. Very good. You can write it as half CV square. You can also write it as half QV. You can also write it as half Q square by C. All of them are the same thing only. All of them are the same thing. Either of them you can use one and the same thing. Is that okay? Very good. This is energy stored in a capacitor. The property of a material to become polarized. Polarized means one part becomes positive, one part becomes negative. That is called as being polarized. So that is a property of a material. In external field, is called as the property of a material. Property of a material to become polarized is, what is it called as? Come on, try to think. When you put some external field, then the charges redistribute themselves. A part of the solid becomes positive, part becomes negative. That is why it is being polarized. That is called as the dielectric. That is the dielectric property of the medium. That is how the concept of dielectric came. Di means two. There are two charges, positive, negative. So dielectric, exactly, polarization. Yes, perfect. Moving on to the next one. A line of force in an electric field originates from dash charge and terminates on dash charge. Very good. Many of you said polarization. Perfect, perfect. But it is dielectric polarization. Perfect. The word dielectric is also important. Come on. What is the answer for this particular question? A line of force in an electric field originates from dash and terminates on dash. Where does it start from? It always starts from positive. Where does it terminate? Always on a negative. Hence, positive and negative. Positive and negative. Very good, Avi. Very good. Very good, Janni. Very good, Samarpita, Partha. Very good, Shalini. Very good, Harita, Dr. Rangata. Very good, Hema, Rojban. Very good, very good. Perfect. 26th question. The process of transferring a charge from a charged object to earth is known as. When you transfer the charge from a charged object to the earth, the answer is there right over here. It is called as earthing, my dear warriors, or grounding. Earthing or grounding, both are the same thing. Yes, and the symbol for that, if you remember, the symbol for that is like this. Oops. It is basically like this. It is basically like this. This is called as grounding. So if you connect it to something which has some charge, then all that charge will flow inside the earth. All that charge will flow inside that earth. That is the basically concept of grounding or earthing. Very nice. Even if you wrote earthing or grounding, one and the same thing. Correct, correct, correct. Yes. Somebody has drawn that earth also. Thank you. Who was that? Sarath. Very good. The force between two parallel conductive plates with opposite charges is attractive, and it's an example of dash effect. It's an example of dash effect. It's a very simple answer, I believe. The force between two plates of opposite charges is attractive, and this is an example of nothing but the electrostatic force effect. That's it. Electrostatic force effect. Yes. That's just how, charges attract and repel each other, because of electrostatic force of attraction and repulsion. So it's an electrostatic force effect. Many people think, sir, can it be some Seebeck effect, that effect, thermal effect, that effect? No, it is a very simple effect, electrostatic force effect. Unit of electric fluxes. Unit of electric fluxes. Yes, that's the whole point, filling the blank type of questions, because this is NCERT underline. So I'm making you revise all the NCERT lines, the entire chapter via these questions. So one way is you read through the chapter, that might be boring for you. Instead, I make it into quiz and then ask you what is there in this line. That's it. You will never forget those lines. So you will get the PDF also later on. But main thing is, when you attend the sessions, and even if you're watching it recorded, watch it in the same flow. Don't just skip the question and watch the solution and then be like, okay, I've watched the lecture. No, don't do that. Yes, it is voltmeter or Newton meter square per coulomb. So in case you do not remember it, how do we do it? How do we do it? Well, see, flux is nothing but electric field into area, right? Electric field into area. Now there are multiple units of electric field. One is volt per meter, and this is meter square. So meter will cancel, it will become voltmeter. Another option is Newton per coulomb, and this is meter square. So it will become Newton meter square per coulomb. Newton per coulomb is also an option. So Newton meter square per coulomb, that is also correct. Understood? That's how you get it. Electric field due to a long plane sheet is. Long plane sheet is. Come on. No, don't use Weber. I saw somebody said Weber. Weber is the unit of magnetic flux, not electric flux. So Weber is not the unit of electric flux, it is a unit of magnetic flux. Don't get confused. It's in magnetism. All right. So what do you think? Electric field due to a charged infinite plane sheet. The formula is basically sigma by 2 epsilon naught. Remember? And it is constant. Yes, it is sigma by 2 epsilon naught also, and it is also constant. Remember this. So whenever you have a charged sheet like this, you will see that the electric field lines will go here and here, and the formula is sigma by 2 epsilon naught. Sigma by 2 epsilon naught, right? Do you remember this now? Perfect, perfect. If you wrote sigma by 2 epsilon naught or constant, okay, perfect, great. It is not dependent on the distance. Capacitance of a spherical capacitor with some inner radius and outer radius. Question is basically what is the formula of capacitance? Let's see how many of you are able to write it. Let's see how many of you are able to write that formula. What's the formula for a spherical capacitor? Inside and outside radius is given. Remember, 4 pi epsilon naught will come. Yes, it is 4 pi epsilon naught. If you can't remember this formula, it's okay. Remember it like this. It is 4 pi epsilon naught, and here you have 1 by A minus 1 by B. If you want, you can take LCM and get to this form. So when you take LCM, it will become B minus A upon AB, and this is what you get eventually. AB will go on the top, AB will go on the top. So 4 pi epsilon naught AB upon B minus A, right? Better to remember this formula. It is easy rather than that one. Okay, cool. So that is for spherical capacitor. In a capacitor, a thin layer of dash acts like a dielectric. A thin layer of dash acts like the dielectric. In an electrolytic capacitor, this is a direct NCERT line. If you know it, or else gone. Oh, somebody is saying 4 pi epsilon naught or Roslyn. Let me tell you, that formula which you are saying 4 pi epsilon naught or, that is only for a single spherical capacitor. Only one sphere is there, then it is 4 pi epsilon naught r. But there is one sphere and another sphere, inner radius, outer radius, then this is the formula. So single sphere, this one, multiple spheres, concentric, 2 ones, so then use this one. Okay, so don't get confused. Good, you put that up. Now you will not repeat the mistake. Yeah, so what is the answer for the 31st question? A thin layer of oxide. So oxide is that electrolyte basically which acts like a small dielectric. Okay, some of you might not remember this or not know this. It is there in NCERT. It might just come as options. Oxide, peroxide, I don't know, some random options might come and you will be like, where was this? Then when you open NCERT, you will be like, okay, it was there. Okay, a positive charge when moved along electric field, the potential energy will. A positive charge when moved along an electric field. So if you take a positive charge in the direction of the electric field, what will happen? The force is pushing it in the field. It is naturally going to go, its energy is going to reduce. Its energy is going to reduce. Potential energy is going to reduce because kinetic energy will increase. Think about it, my dear students. Think about it, my dear students. If this is electric field, this is a charge, what will happen after some time? This charge's speed will increase. The charge's speed will increase because the force will also be in the same direction. That means kinetic energy will also increase. That means potential energy must decrease. So the potential energy will decrease to conserve the energy. Exactly. Next one. Electric field line never forms a closed loop because electric field is a dash field. Magnetic field lines, you might have seen, they form closed loops. Electric fields, they start from positive, go to negative, but they never come back to the same point. Reason being, electric field is a conservative field. Yes, it is conserved. You will never ever see this. You will never ever see this, that the electric field line went and came back to the same point. Because if this happens, then what it means is, if I take a charge and go along this path, then the work done in the closed path will not be zero. But that is not the case with electricity. work done in a closed path must be 0. So that's why it always starts at a positive, ends at a negative. It starts at a positive, ends at a negative. The work done to go and come back totally will be always 0. Keep this in mind. Okay. When two capacitors are connected in series, their total capacitance dashed than the capacitance of either capacitor. Meaning capacitors are in series. Look at this. One capacitor. It becomes one single capacitor CS. This is C1, this is C2. So 1 by C1 plus 1 by C2 will be 1 by CS. Isn't that the formula? Isn't that the formula? When capacitors are in series and this CS is less than C1, it is also less than C2 always. It is less than C1 also, it is less than C2 also. Just like the resistors in parallel formula, you have resistors in parallel formula and the total resistance is smaller than each resistance. Same way, same formula, meaning the final capacitance is smaller than each capacitance. That's all. So CS is less than C1, CS is less than C2. So it is less than. Very good, very good, very good. Moving on to the next question on your screen. The field at the center of a uniformly charged ring of radius r is. You have a ring and you are at the center of the ring. What do you think? At the center of the ring, each charge will give a field. Each charge will give a field. Each charge will give a field. All these fields will cancel out each other. I think the answer should be a big fat 0. Yes, it is 0. Who said it? Very good, Sarath. Excellente. Just right, Krishna. Very good. Subhashni, Dia, Priyadarshini. Very good, Sanvi. Agalia. Awesome, Rosaline, Bhavya. Crazy dude. Excellente. Moving on to the next one. Here it comes on your screen. The electric field inside a non-conducting uniformly charged sphere varies dash with the distance from the center. If you know the formula, you can easily get the answer. For a uniformly charged sphere, my dear warriors, the formula for electric field is KQ small r divided by R cube. This is when you are inside. Whereas when you are outside, then it is KQ divided by small r square. So if you notice here, the question talks about inside. So it is directly proportional. It is directly proportional to r. It is directly proportional to the distance from the center. So it is linearly proportional or it is directly proportional. Yes, that's the answer. Yes, linear, direct. R and R, two different symbols, don't get confused. When you use this formula, KQ small r divided by R cube, understand what are these symbols. The radius of the sphere is capital R, whereas the distance from the center is small r. This is not going to change. This small r, the one in blue, that can change. Okay, so this is a variable. This is the radius of the sphere itself. Don't get confused between the two. Okay, next one. The process by which a charged object can induce a charge in somebody nearby without physical contact is known as. It is just like, once Pandu was attending a class. And then Champa sat beside Pandu. But they were not very close. In the next bench, she was sitting. And then suddenly, love developed between them. So without any contact, there was love between them. Similarly, when a body is close to another body, it can induce a charge. So Champa induced love in Pandu. Same way, another body can induce a charge without touching. That is called as induction. Very good. Very good. So Pandu got induced over there. Excellente. Let's move on to the next one. A material which has high dielectric strength is a good. What? Which has a high dielectric strength. It has a very, very good dielectric strength. It is. Yes, it is a good insulator. It has a high dielectric strength. It is nothing but a insulator. Everyone with me? Cool? Perfect? Yes, you should know that. K is very large, right? So it is going to be like an insulator. Perfect, perfect, perfect. Moving on to the next question coming up on your screen. The electric field strength at a point, the electric field, no, not conductor, insulator. So, the electric field strength at a point in space can be represented by the density of dash at that point. The electric field at a point, can be represented by the density of dash. Whose density? Electric field depends on the density of the field lines, my dear warriors. Yes, it should be field lines. Perfect, perfect. If the field lines are close, field is very strong. Field lines are far, then the electric field strength is very low. Is that clear? Perfect. The electrostatic potential is a scalar quantity and it is represented in units of. Electric potential, voltage, volts, obviously, volts, electric potential. It's a scalar, definitely. There is no direction associated with it. And it is expressed in volts. Perfect. Now there is a big filling the blank. The dash from infinity to a point in electric field is known as V at that point, is known as the potential at that point. 11th standard student might find it little difficult because this is 12th standard's first chapter. If you have seen this chapter, it will be easy. But if you remember the concepts from 10th standard, it will be very easy because most of these things you might have heard about in your 10th standard. It's not very difficult. The work done, yes, it's the work done, correct. So when you bring a charge from infinity to a point, how much work you do per unit positive charge, that is going to decide the electric potential at that point. Yes, very good. Flash, awesome Sanvi, awesome Green Queen, very good Santosh, Roseline. Yes, it was a work done per unit charge. Moving on to the next one. The potential difference between 2 points in an electric field is the work done per unit charge, I think. From 1 point. This is slightly different question. Yep. So the potential difference between 2 points in the field is the work done per unit charge in moving a charge from 1 point. Work done per unit charge in moving from 1 point to obviously the other point. Understand the difference between this question and the previous question. Lot of people do not know the difference. I'll explain this to you. Observe this. If I come from infinity and I came to that point, then whatever work I do upon that unit charge, that will give me the potential at that point. But let's say there is a point P1 here, there is another point P2 here, doesn't matter what path you take, but there is some work done in bringing that charge from point 1 to point 2. Then that work upon that charge does not give you voltage at any point. In fact, what it gives you is the voltage difference between point 1 and 2. It gives you the voltage difference between these 2 points. Understood? So, see the difference in the definition. From infinity to a point, potential. From 1 point to another point, potential difference. Is that clear? Everybody with me? Let's move on to the next one. A capacitor consists of 2 conductors separated by an insulating material called the, come on. Think about it. Separated by an insulating material called the, what do you think the correct answer for this should be? Capacitor consists of 2 conductors separated by insulating material. Yes, that insulating material is the dielectric. You add dielectric so that the capacitance increases. More the dielectric, more the capacitance. Understand that. More dielectric, more capacitance. You add those insulators like ceramic, wood, paper, glass, which increases the capacitance of a capacitor. For a parallel plate capacitor, the capacitance formula is given by where area of the plate, d is the distance. Everybody should be able to put it up in the chat box. I want the spam of this particular formula. Yes, the capacitance formula. Epsilon naught is there, A is also there, and D is also there. It's proportional to the area and inversely proportional to the distance. Perfect. Yes, epsilon naught A by D. Epsilon naught A by D. Perfect. So many of you have given the correct answer. Yeah, proud of you. Very good, Kirtika, Sanvi, Mohammed. Yep. Oh, it's not sigma by epsilon naught. Sanvi, be careful. I'm not asking you electric field. I'm asking you capacitance. So it's epsilon naught area by D. Okay. Cool. The unit of capacitance is dash, which is defined as 1 something. Something is there. What is that something going to be? What is that something? Capacitance, the unit is what? Farad. And it is nothing but, if you know the formula, you will get it, Coulomb per volt. How do I know this? This formula. Q is equal to CV. So C will be Q by V. So it is nothing but Coulomb per volts. Coulomb per volts. Capacitance is measured in farad. So 1 farad is 1 Coulomb per volt. Hence that's the answer. Hence that's the answer. Q is equal to CV. So C is Q by V. In the potential energy formula which is there for a capacitor which is charged, given by half CV square, here V represents, you might think you know the answer, but you might make a small mistake in this. It looks like a simple question, but you might make a small mistake while answering this. Come on. What do you think is the correct answer? Half CV square. Yes, C is capacitance, but what is V? Is it voltage? No, 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 no. It is voltage difference across the capacitor. It's not voltage, it's the voltage difference, meaning, example, if you have a capacitor like this point is at 20 volts, this point is at 25 volts, this capacitance is 3 farad, then when I find the potential energy, it will be nothing but half into capacitance into V. V will be this minus this, which is nothing but 5 square. That is the formula that you will use. That 5 happens to be the voltage difference. Neither will you take that, neither will you take this. You will take the difference of the voltages. Is that clear? Everybody? Everybody with me? Okay. So it's a voltage difference. In a series combination, the reciprocal of the total capacitance is the sum of the dash of the individual capacitances. This is also straightforward. Come on, my dear students. Yep. Is the reciprocal. I just told you, capacitors in series, 1 by CS is 1 by C1 plus 1 by C2 plus 1 by C3. That means inverse of the reciprocal of the sum of the individual capacitors. Correct. The capacitance is the sum of the reciprocal of the individual capacitance. Keep that in mind, because I just told you this formula, 1 by CS is the sum of what? Reciprocal of each of the capacitances. Reciprocal of the individual capacitances. Correct. Very good. If you answered it correctly, reciprocal of the capacitance. Yes, that should be the correct one. Yes, Madhumita will be doing all the chapters. Don't worry about it. Yes, that's the whole aim of Super 6, to cover every chapter in detail. In a parallel combination of capacitors, the total capacitance is the dash of the... Achha, I think this was there already. Oh, this is parallel. The earlier one was the series. This is parallel. A parallel combination of capacitors, the total capacitance is... So when you have capacitors in parallel, my dear warriors, when you have them in parallel like this, then what happens? You just add the capacitance C1 plus C2 like that. That will give you the total capacitance. It's just the addition. It's just the sum of all the capacitances. It's exactly opposite of resistors. Whatever is the formula for resistors, it is exactly opposite. Keep that in mind. That's how capacitors are. The electric potential due to a point charge at a distance r from the charge is given by the electric potential due to a charge at a distance r from the charge is given by, what is the formula? Kq by r. Kq by r, standard formula. K is Coulomb's constant, Q is charge, inversely proportional to the distance. Standard thing. Very good. Thank you, Krishna. All the warrior Pandus, thank you so much for being in the session. And when you attend these sessions, there are hardly going to be like maybe 6 sessions of this. And in these 6 sessions, we will be doing more than 2000 plus problems, 2000 plus NCERT lines, 2000 plus filling the blanks, 2000 plus questions for all of you, for your NEET preparation. Just imagine 6 days you can, 5 to 6 days, because each lecture will be around 400 questions at least. So you can imagine now. The energy density in the electric field is given by energy density, joules per meter cube, is half epsilon naught E square. Yes, correct. Remember, when I talk about energy density, I am talking about the joules which is there per meter cube. That is the unit of the energy density, and that is half epsilon naught, which is permittivity. This is electric field. This is your electric field. Very good. Next one. Dash relates the electric flux through a closed surface to the charge enclosed by the surface. Something is there which is relating the flux through a closed surface to the charge enclosed by the surface. I think there is something. Thank you, Srinath NEET. Yes, what is it? Yashwant will be taking it very soon. Don't worry. First, we are doing some backlog chapters of 11th like motion in 1D. And yes, on demand, popular demand, guys. Motion in 1D this Sunday, and before next Sunday there will be simple harmonic motion, which is basically oscillations. That was on demand chapter by all the students. So by the next week you will be seeing both these chapters will be taught to you from physics perspective, right? So don't worry about it. And then we'll do some more chapters. We'll be coming back to 12th standard portions also very soon. Don't worry. Yes, what is it? Gauss's law. Yes, Gauss's law relates the electric flux through a closed surface to the charge enclosed by the surface. Perfecto, perfecto, perfecto. Next one. The electric potential at a point due to a system of charges. Due to many charges, the electric potential at a point is the dash sum of the potential due to each charge. One charge is here, one charge is here, one charge is here. So the total potential at the point is the dash sum. What is that sum? What is that sum called? Come on, come on, come on, my dear warriors. Come on, come on, come on, my dear warriors. Yes, the algebraic sum, basically it will be just the, algebraic means some voltage might be positive, some might be negative. That's it. That's all that is to be counted. Maybe due to this charge, the voltage here is plus 2 volts. Maybe due to this charge, the voltage here is plus 5 volts. Maybe due to this charge over here, the voltage is minus 3 volts. So the total voltage will be nothing but 5 plus 2 minus 3. That's all. So what is this? This is algebraic sum of the voltages due to each charge. That's all. Electric potential inside a conductor in electric equilibrium is the electric potential inside a conductor. Conductor means, remember, field everywhere will be 0. Inside the field will be 0. So come on, my dear warriors, it must be what? So one of the important properties of a conductor, remember, the charges are only there on the surface. The charges are only there on the surface, nowhere else. And the electric field lines are there outside. Electric field lines are there outside. Electric field inside is 0. If there is no electric field, what can you tell about the potential? The potential is not 0, it is constant. Potential is constant. Keep that in mind. Why? Because remember, dV by dr dV by d with a negative sign is going to give me electric field. So if E is 0, that means the derivative is 0. That means the derivative is 0. And whose derivative is 0? Constant number's derivative is 0. That's the reason why voltage is constant. Keep that in mind. Okay, that's another way of looking at it. Yes, potential is same or it is constant. Next one, the potential difference across the plates of a parallel capacitor with air is proportional to the dash stored in the capacitor. Is proportional to the dash stored in the capacitor. What is it? Is that going to be energy, energy density, current, charge, voltage, dielectric constant? What is going to come in the filling the blank? Come on, think about it. Today we'll be doing this electrostatics chapter, electric potential, capacitance, these concepts we are doing. Next lecture we'll be doing current, electricity and magnetism, a part of it, and then we'll do remaining chapters also. So we'll try to cover as many chapters as possible. We'll try to in fact do all 12 standard chapters in these 2000 questions. What say, guys? Are you up for the game? Are you up for it? And if you enjoy that, then we'll bring this for 11th standard also. But first let's do the 12th standard portions, what say, on priority basis, and then let's also come back to the 11th standard portions also. Don't worry. Yes, the answer is the charge. The charge stored in the capacitor. Perfecto. Perfecto. Yes, not the energy. It is proportional to the charge, the potential difference. The formula is Q is CV. Q is CV. So charge and voltage are proportional. Keep that in mind. Van de Graaff generator actually has not been included in the syllabus, but still I've just kept a question on it. Is a device used to produce a very, I mean, the name only is scary, no? Van de Graaff generator. The name itself is scary. So that generator is used to produce. It is scary. That means high voltages. That's all. High potential difference. So the name itself is scary. Okay, that's how you remember it. Very good. Thank you so much. You guys are up for it. Thank you, Krishna. Thank you, Saradhya. Very good. Next one, question number 56 on your screen. Here it is. The presence of a dielectric material in a capacitor dash the effective electric field between them. What does it do to the electric field? When you add a dielectric material in the capacitor, the dash will happen for the electric field. What will happen? The electric field will become weak. It will become less. It will become small. It reduces. Exactly. So whenever you add dielectric medium, it produces opposite field which will oppose the external field. So the net field will become smaller. Net field will become smaller. Exactly. It decreases, reduces, smaller, anything. Perfect. Moving on. Equipotential surface is a surface over which the electric potential is. An equipotential, the name itself has it. The name itself has it. Equipotential surface. A surface with equal potentials, meaning the potentials are same, are constant, whatever. Yes, the potential is constant. Perfect. And if you remember, for a point charge, you should know these diagrams, guys. If you take a positive charge, the electric field lines are going to be like this, whereas the equipotential lines are going to be concentric circles. These are your equipotential lines, V1, V2, V3. So all these points are at the same potential. All these points are at the same potential. Between them, there is a potential difference. That's all. Next, the process of connecting a body to earth to eliminate excess charge. I think we just did this, maybe just got repeated, but whatever. Yeah, it is called as earthing or grounding, standard thing. Yeah, it is called as earthing or grounding. Maybe this question just got repeated. Anyways, next one. Capacitance of a spherical capacitor is influenced by the dash of the sphere and the medium between the conductors. The capacitance of spherical capacitance. Capacitance of spherical capacitance, that means two spheres are there, is dependent on or influenced by the dash of the sphere and the medium. Yes, dielectric medium matters. What else does it depend on? Obviously, their sizes, meaning what? Their radius. Obviously, their sizes. how big or small that sphere is, that means the radius. Very good, very good, very good. Next question on your screen now. The potential difference across a capacitor is, the potential difference across a capacitor is, I don't know, many things can come over here. I mean, I can imagine many things that can fill up. So you can put up whatever things you are imagining. It's not necessary that you are wrong, but I'm just saying, okay, there can be many things that can be filled up over here. Yes, it is basically the formula Q by C. Q is CV. So V is Q by C. It is proportional to the charge, can also fill up the blank. It is inversely proportional to capacitance, can also fill up the blank. Or the formula can also just fill up the blank. Yes, very good. Awesomeness. Q by C. In a capacitor, the electric field is strongest. In a capacitor, the electric field is strongest at the dash of the plates. This is very tricky. Many people would ignore this line in NCERT. And if it comes in the NEET exam, lost. Marks will be lost. So today's session will help you with that. So if you remember, in a parallel plate capacitor, this is your parallel plate capacitor, something like this. Okay, the electric field lines will be like this, You can see it's almost parallel to each other. It's almost parallel to each other between the plates, except for the edge. At the edge, you will see there is this effect which happens. It's also called as the fringing effect. It's also called as the fringing effect. Number one. Number two, whenever you have an edge of a conductor which is basically sharp, here you will see the electric fields are strong. Electric fields are very, very strong whenever the edge is basically sharp. All sharp edges have, strong electric field. And at the edge, you will see the electric field is no longer parallel, but it goes out slightly. So that is what happens. So that's the reason why we take a large area of the plate, so that the fringing effect is very negligible as compared to the other part. So if you have a small area, then the field lines will look like this. But imagine this, if you have a large plate, then most of the plate will have uniform field. Only at the ends, you will have this fringing effect where the fields are little bit weird, but that can be ignored because most of the plate is uniform field. So that's why we take a large area of the plate. Is that okay? So it is at the edges. Sharp edges will always have strong electric field. Very good, very good, very good. No, not in between. In between the field is uniform. Only at the edge the fields are strong. That's why your hair will stand in lightning. You might have heard many people get killed every year during monsoons because of lightning. And you know how to detect when a lightning is going to occur and maybe you might get struck by it? Your hair will stand. In fact, there was a reel I saw, I think it was from China. All these things come from China only these days. So these tourists are there, in a nice mountain or a hill station, and they are clicking selfies and photos of each other, and their hair starts standing up. It looks like as if, somebody is pulling their hair. They get so fascinated, they are clicking more photos of each other. Actually, whenever that happens, you should immediately run, because the sharp edges of your hair are getting pulled by the electric force of the clouds. Sharp edges, strong field. That means a strong field has been generated there. Immediately run. Don't click selfies. Nobody is going to, you will not even get more than 1000 likes, or else it will be the last video that you will be making. So don't do that. Run for your life. Okay? Understood? Moving on. Ability of a capacitor to store charge is affected by the dash of the dash material used. This is straightforward. Is dash of the dash. Come on, guys. The ability of the capacitor to store the charge is affected by, that means the capacitance is affected by material. That means which word will come here? Dielectric. And dielectric has what? K. So K of the dielectric. The dielectric constant K. 2, 3, 5, 5.7, 2.3, whatever. So that K of the dielectric material used. Perfect. Let's move on to the next one. Right, ready for it? 100 questions of physics, guys, and then you'll have more questions coming up of biology, the entire zoo and botany part, and then chemistry too. This is one of the best sessions that you can probably find anywhere in general for NEET channels. NEET English, so forget it. This is the only best channel that you have in the country, and the biggest one too. Okay, the electrostatic force between 2-point charges is inversely proportional to the square of the dash between them. The electric force between 2-point charges is inversely proportional to the square of the what? Distance between them. Perfect. Perfect. Yes, perfect. Moving on to the next one. K Q1 Q2 by R square. Yes, so that's why inversely proportional to the square of the distance. Capacitance of a cylindrical capacitor depends on the dash and radius of the dash. If you answer this, I'll be very happy. If you answer this, I'll be very happy. Let's see who are those people who are going to make Shreyas sir, Captain Shreyas sir happy. Okay, Sneha, I'll give you some typing time too. No problem, Sneha, no problem. Chalo, take your time, type it out. The capacitance of a cylindrical capacitor depends on the dash and the radius of the, very good, yes, cylinder's height or the length will be there, and radius of, obviously radius of what? Circle? No, cylinder. Yes, so that should be the answer. Check it out. Length and the radius. No, not area, Sanvi. Radius, correct. Length, yes, correct. Distances between the cylinders, not completely correct. Actually, it is R1 and R2 because there is a formula, if you remember, 2 pi epsilon naught length upon log of outer radius by inner radius. So it depends on the radius and the length of the cylinder. Is that right? Okay. Electric potential at the surface of a charged sphere, is dash throughout the surface. What will be the right word? Not constant, constant, increases, decreases, perpendicular, parallel, whatever you think is going to come over here. You can put it up in the chat box. Whatever you think is going to put it up in the chat box. Come on. Yes, electric potential is going to be constant or same. Yes, electric potential, not field, potential is going to be same. It's an equipotential surface. Yep, it's a completely equipotential surface. Yes, so that's why the word will be same. Uniform, constant, same, all are same. Okay. In a capacitor, if dielectric strength exceeds, it leads to a phenomena. What is that phenomena called? If you have a capacitor, it has something called as whatever, that phenomena, and it leads to something. Come on. It's called as, it's the same thing which happens in lightning. When excess charge develops in the clouds, then that excess charge flows via air, which is usually not going to conduct electricity. So suddenly air becomes conductor. That is your electrical breakdown. Dielectrical breakdown. Yes. Perfect. Perfect. So when the field is very strong, then the charges can flow as if it is a conductor. So there is a breakdown which has occurred of the dielectric. Correct. The work done by an external force to move a charge in a field against the electric force is stored as the dash energy in the system. Come on, my dear warriors. Come on, my dear warriors. The work done by external force to move a charge in the field against the force is stored as which energy? If it's an electric charge, there will be electric force. So the energy stored will also be electric. So it will be electrical potential energy. Isn't that right? Yes, electrical potential energy. Perfect. It can't be kinetic. It can't be magnetic. It can't be spring. It can't be gravitational. It has to be electrical potential energy. Very good. Next one. Coming up on your screen, here it is. The capacitance of a capacitor is said to be 1 farad when a charge of 1 dash changes its potential by 1 dash. Very straightforward. In fact, it is the definition of the unit of farad. If you know the formula of capacitance, charge and voltage, you can get this very easily. Q is equal to CV. C is Q by V. Q is in coulombs, voltage is in volts. So coulombs and volts will give you farad. Coulombs and volts, coulombs per volt, right? So that's it. When a charge of 1 coulomb changes the voltage by 1 volt. Exactly, 1 coulomb, 1 volt. That is the answer. Very good. Malarkodi, Ragvi Priya. Excellente, excellente, excellente. Very good. Crazy Dude, Rojwan, Varsha, Priyadarshini, Krishna, Sarat, Mohammad. Awesome, Janendra. Awesome, Sneha. Very good. Done, done, Diya. Very good. Let's move on to the next question on your screen now. 69th question. If the distance between the plates of a capacitor is halved, capacitance will become. Remember the formula. Recollect the formula. Capacitance is epsilon naught A by D. If you make the distance half, this 2 will go in the top. So the capacitance will be made 2 times. So answer should be 2. The answer should be 2. Just check this out. Yes or no? Yes, it will be doubled. It will be made 2 times. Perfect, perfect, perfect. It will be doubled. Moving on to the next question. The electric field due to a long wire which is charged is proportional to the dash from the wire. Is proportional to the dash from the wire. Let's see. What do you think? If there is a wire which is charged like this, infinitely long like that, then if you are at a distance r, the electric field is given by k lambda, and here we have 2, and we have basically what? R over here, 2k lambda by r. So don't you see electric field is inversely proportional to r, proportional to the inverse of the distance, inverse of the distance from the wire. Yes, yes, not just distance, inverse of the distance. It's a wire, not a sheet, Mohammad Soed. So don't say independent. It is not, and the answer is not even just distance. It is 1 by r. Many people think the answer is 1 by r square. That is also wrong. It is 1 by r. That is the formula. Lambda was the charge density, charge per unit length. Charge per unit length. Correct. Okay. The potential at a point due to a negative charge. If you take a negative charge and you are around it, what happens? It's like asking, sir, there is one friend, he is always depressing, sir. He'll tell, so, see, I have studied this much. What you have studied? You have not studied anything only. See, I have bought these many books. See, I solved these many questions. So those are negative people. What will happen? They will also make you negative. If you're around positive people, hey, let's work together. Hey, you know what? I got this method. I'll teach you this. Hey, let's all not play, cricket or whatever video games today. Let's sit and study only after we complete these problems. Then we'll play a game. These are positive mindset people. So accordingly, the answer is negative. Accordingly, the answer is negative. Perfect. Next one. The ability of a capacitor to store and release energy is termed as. The ability of a capacitor to store and release the energy is termed as. What does a water tank do? Water tank stores water, and when you open the tap, it releases the water. It stores the water, releases the water. Same thing, a capacitor stores the charge and gives the charge when it is needed or whenever you charge it. So what does it have? It has capacitance. It has capacitance. Correcto. Perfecto. Moving on. Next one. In a dielectric medium, the electric force between two charges is reduced by a factor of. In a dielectric medium, electric force between the two charges. What happens? You have two charges. Force is 1 by 4 pi epsilon naught q1 q2 by r square. When that medium is there, it will become 1 by k times of that. It will become 1 by k times of that by the factor of k. So the answer is k times. It will reduce by k times. Correcto, cash for Flash Rider. No, it's not 2, it's k. Excellente. Next one. The unit of electrical dipole moment. Come on, try and recollect. Electrical dipole moment. What do you think it will be? Electrical dipole moment. P is QL. QL. Perfecto. So it will be nothing but coulombs into meter. Coulombs into meter. Very good, Kirtika. Excelente. Excelente. That is the correct answer. Crazy dude. Very good. Very good. Next one. The electric field inside a charged shell is 0. This is a result of or consequence of whose law? Some law makes the electric field inside 0. What do you think it is? What do you think it is? Come on, my dear warriors. Yes, GRD cooking, it will be done. Don't worry. Yes, very good, Diya, Flash Rider. The previous one was correct. Come on. Yes, there is only one law, and that is Gauss's law, my dear warriors. Perfecto. So, Gauss law says that net field's flux is enclosed charge by epsilon naught. Inside a conductor, there is no field. If there is no field, there is no charge. So, it is a consequence of Gauss's law. Correct. A point charge causes electric field that diminishes the strength with the dash of the distance from the charge. A point charge causes an electric field that diminishes the strength with what? Come on, with the dash of the distance from the charge. Something related to the distance. If you remember the formula, you will get the answer. Yes, the answer is the square of the distance. Remember, electric field is kq by r square. So, if the distance is increased, the field will reduce, and the field will reduce square times inversely proportional to the distance. So, it will be reduced with square times as that of the distance. Yes, perfect. Very good. Very good. Yep. Awesome. Some of you are saying increase. Well, I was not talking about that. Yeah, you can say that if the point charge goes away, the field goes down. That means the distance has increased. Yes, that can also be filled in the blank. No problem. Many of you wrote increase. No problem. Don't get scared. So the answer is wrong. Kya? No, that is also correct, because these are filling the blanks. It's up to your thought and imagination what you can think over there. With the square of the distance, or you can say with the increase in the distance also. Yes, with the increase in the distance also. Correct. Both are correct. Don't get scared. In a parallel plate capacitor, area is doubled, the capacitance is. Area is doubled, then the capacitance is. Capacitance is epsilon naught A by D. Area doubles, capacitance doubles. Perfect. That's the answer. Very good. The electric potential at a point is at a distance r from the charge conducting sphere of radius r is same as if all the charges were, where were they? Come on. Electric potential at a point at a distance r is, this is r, this is small r. The formula is kq by r. It's as if all the charge is over here and you are at a distance r from it, as if it is at the center, as if all the charge were concentrated at the center. How many of you wrote it? No, not on the surface. Oops. See, understand the difference. I agree, the charge is on the surface. The charge is on the surface. I am not denying that. But how do these charges behave? These charges behave as if all of them are at the center. As if all of them are at the center when you are here outside. It feels all these charges are over here. And then you find out the field or the potential. That is the meaning. They are not asking where are the charges. They are asking how does it behave. It acts as if the charges were concentrated at the center. Understood? So you might make a mistake in these kind of questions. You might get negative marks. Be careful. The electric field is always dashed to the dash surface at every point. Come on, let's see if we can get this. Very, very nice question. Two filling the blanks together. The electric field is always dashed to the dash surface. Come on, come on, come on. KQ by R cube into R. That, Sneha, that is the formula for a, not a conductor, it is for an insulator. And that too, it is only when you are inside. So both the things are not a part of that previous question, okay? So KQR by R cube is for insulators, and that too only when you are inside, and that too it is for field. So three things are different. The question was on potential, the question was for a conductor, and that too when you are outside. So completely different thing, okay? Chalo. Electric field is always what? It is always perpendicular. Perfect. To whom? Equipotential surfaces. Perpendicular. If field is here, equipotential will be here. If field is here, equipotential will be perpendicular to it. That's how it is. Very, very good. And as you are watching these classes, yes, make sure you are also liking this video, sharing this, and talking about this channel in your school, in your coaching, in your house, in your housing complex, wherever you are, in your area, with your relatives, everyone. Everybody should know. This is a channel which we started specifically for South Indian students. But you know what the best part is? Because many students in South India do not get those privileges of, good quality teachers, or, are not able to understand the Hindi medium classes. Here we are, one of the first English channels. We started off with J English, then we started off with NEET English, many years back. It was almost 3 years back we started this channel, and here we are. Make sure you talk about this channel. Now it's no longer limited to South Indian students. Every part of the country, even outside the country, many students are watching this, and it's not because of English, it's because of the teachers, and that's the best part about it. Cool? So talk about this channel, guys. When a dielectric material is placed in an external field, when a dielectric material is placed in an electric field, in an external electric field, it gets what? What happens? A dielectric medium is placed, external field goes. One part becomes positive, one part becomes negative. What is that called? Think and answer quickly. I've just given you the hint. Yes, Sarath, that's the whole point. I'm glad to be doing this on the Republic Day. Yay! It is going to get polarized. It's going to get polarized. One polarity here, one polarity here. It gets polarized. Very good. The energy stored in a capacitor is also referred to as the dash energy. Inside a capacitor, charges are developed on the opposite plates. They create a field, they create a voltage, there is an energy stored. What is that energy? Obviously, it's because of electric field, electric charges, hence it will be electric energy. But I can't just call it electrical energy. It has ability to do work, because when I connect a capacitor to anything, it performs work. So it has potential energy. So hence I will call it as the electrical potential energy. So both the words will be there, electrical potential energy. Understood? Yes, it's not just potential, it's not just electric, it is electrical potential energy. Very good. Because potential energy can be of various types: gravitational, spring, elastic, magnetic, right? So that's the reason for that. Okay, a capacitor with vacuum in the plates has capacitance which depends only on the dash and dash of the plates. So whenever you talk about a parallel plate capacitor, what does the capacitance depend on? Specifically when I'm mentioning two filling the blanks with regards to the plates. What's the formula? What's the formula for the capacitance? If you remember it, you will get it. Capacitance is epsilon naught A by D. So it depends on the area of the plate and also distance between the plates. And the distance between the plates depends on the distance and the area. Perfect. A and D. Very good, Muhammad Ali Varsha. Jinendra. Awesome. Awesome. Good evening. Good evening, Dharni. Join in. Very good, Flash Rider. Very good, Cash Cow. Very good, Krishna. Very good, Samrita. Awesome, Ragvi Sarat. Awesome. The potential difference created by a charge Q at a distance R is inversely proportional to potential difference created by a charge at distance R is inversely proportional to, if you remember the formula, there is nothing great about it. So what is the formula? V is nothing but KQ by R. This is inversely proportional to what? R. Yes, it is distance. R is distance. Very good. Very good. Very good. Yes. You're watching my Zero to Superhero series. I also don't have those notes now. It must be lost somewhere in the old channel or PDFs of the old Telegram. I'm not so sure, bacha, if I can get those old Zero to Superhero PDFs. Even I don't have it. When capacitors are connected in series, the total voltage is the dash across each capacitor. Let's see what are you going to fill over here. There are multiple words which will fill in the blank. So I think that's why the blank is a little bit bigger. What do you think is going to fill up over there? Come on, come on, come on. Wake up all your friends. Call all your friends for today's celebration of Republic Day on the Vedantu NEET English channel, where we are doing or where we are starting off with the NCERT line by line, 2000 plus questions every session, around 400 plus questions. And in the matter of next 4 to 6 sessions, we'll be doing this and we'll be trying to cover as many important chapters of your 12th standard, and it will not just help you for your NEET but also for your boards. So what is the answer? Sum of the voltages. No, it is not same. Understand, whenever you have capacitors in series, the charge is same but voltages are not same. In fact, V1 plus V2 will be the total voltage. Voltages will add. So the sum of the voltages is going to be added. The total voltage will be the sum. When they are in parallel, then the voltages will be same. So if this word was not series, but let's say it was parallel, then the answer will be the total voltage is same across all the capacitors. Is same. That was for parallel. This is series, so it will be sum of the voltages. Okay. Alrighty. Somebody is saying, sir, look at the lights. Okay, thank goodness. Very good. Can we make it 500 plus? Yeah. Are you going to share this video? Let's make it 500 plus before the session ends or before all the teachers come. The next teacher is going to be for biology and next for your chemistry. So I want this to cross 500 plus, and not just for this session, each and every session. The work done in moving charge against electric field is stored as the dash in the electric field. What does it get stored as? When you do some work in moving a charge from one place to the other, it gets stored as what? Electrical potential energy. It gets stored as the electrical potential energy. Correcto? Everyone with me on this? Very good, Muhammad Ali. Awesomeness. Next one. Okay? I hope this is very, very clear. This was very straightforward. Gauss's law is useful for calculating the electric field of dash charge distribution. Is useful for calculating the electric field of dash kind of charge distribution. What do you think the answer will be? When do you use Gauss law? For spheres, for cylinders, for line charges, for sheets? What is so special about these things? They are all symmetrical, isn't it? So the answer will be symmetric. Yes, they are all symmetry. They are having some kind of equality. This side is same. Up and bottom is same. Some kind of symmetry or uniformity is there. Yes, you can say that uniformity comes because of symmetry. Yep, very good. Fields of symmetric charge distributions. In a sphere, it is distributed equally on all the sides that way. Capacitance of a cylindrical capacitor is given by, come on guys, you should know this formula. Capacitance of a cylindrical type of capacitor is given by 2 pi epsilon. It is not 4 pi or just epsilon, it is 2 pi. Length of the cylinder upon log of bigger radius by the smaller radius. This is to the base e. This is the formula. This is the formula, 2 pi epsilon length by log of big by small radius. That's the formula. Yes, 2 pi epsilon length by ln. Ln means log to the base e, b by a. Yes, perfecto. Perfecto. Moving on to the next one. The electric force between two charged particles is independent of. Ooh, what is it independent of? It could be many things, but what do you think is the best suitable phrase or set of words that will fit in over here? The electric force between two charged particles is independent of. What is it? It's like Pandu and Champa love each other. If some another laddu comes, their love is not affected, right? It should not happen ideally, right? So in a movie, hero, heroine love each other. Some another villain comes, their love is not affected. So that villain is another charge. So my dear warriors, presence of other charges. Correct? Very good. Very good. So it is independent of other charges. Even if other charges come, their force will not change. Yes, each charge might experience a newer force and newer force. That's a different story. But their mutual force will not change. Keep that in mind. Clear? Next one. Electrical potential energy of two charges is positive. The charges are of dash sign. Charges are of what sign? Charges are of what sign, my dear warriors? Come on. The electrical potential energy of two charges is positive. That means both charges are of same sign or opposite sign. Positive into positive, positive. Negative into negative, positive. Positive into negative, negative. So there should be of the same sign. Why have they put opposite sign? I'll get this corrected. Don't worry. So this is not supposed to be opposite, guys. It is supposed to be of the same sign. Very good. Yes, perfect, perfect. Moving on. Principle stating that the total charge of a system remains constant is known as the dash of dash. Some law is there. Some principle is there. Because it says the principle which says that the total charge remains as it is means conservation of charge. It should be conservation of charge. Think about it. Yes, it is conservation of charge. Perfect, perfect, perfect. Moving on to the next one. An insulator can be charged by the process of insulator like wood, rubber, plastic, paper. When you want to charge them, and you would have done this in school, you take a comb and rub it on somebody's head. And that person is like, what are you doing? And then you're like, see, I will show you magic. And then you take the comb and you lift bits and pieces of paper. Then that person is like, wow, you are like one crazy fellow. How are you doing this magic? Please teach me this trick. Little does that other person know that this is a game of rubbing the bodies, and that's when charges get transferred and they get charged. So that rubbing, basically friction is involved by a process of rubbing and friction. Correct. You can use the word rubbing, friction, whatever. Excelente. 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 Moving on. The electric field at the surface of a charged conductor perpendicular to the surface and is given by electric field on the surface of a conductor. Please understand, this is conductor. So understand the difference. When you have a sheet, this is a sheet. This is a sheet. Field will go both sides. Then it is sigma by 2 epsilon naught. Because half of the field goes here, half of the field goes here. But when we are talking about a conductor, the field is not inside, the field is only outside. The field is only outside, and that field is given by sigma by epsilon naught. So that 2 is there when it gets divided. But when it is not getting divided, it's just going outside. Remember, inside the field is 0, then it is just sigma by epsilon naught. Be careful about these two formulas. So hence the answer is sigma by epsilon naught. Perfecto. Some of you probably got confused over there whether it will be by 2 or just sigma by epsilon. The field at a point outside a uniformly charged shell is dash proportional to the dash from the center. Something from the center, think about it, it must be distance only, I guess. The electric field at a point outside a charged shell, outside, the moment you go outside, what will happen? The shell will behave like a point charge, So what should be the answer? The formula kq by r square, use that, is inversely proportional to the square of the distance. Inversely proportional to the square of the distance, kq by r square. Kq by r square. Is that right? Very good. When you are outside a shell, if you are inside the shell, the field will be 0. If you are outside the shell, it will be kq by r square. Kq by r square. Correct. The potential due to a dipole at a point on the axial line depends on the dash and the dash of the dipole. Depends on two things of the dipole. Depends on the two things of the dipole. What are those two things, my dear warriors? Think about it. You have a dipole and you are on the axis of the dipole. So how far you are from the dipole and what is the dash of the dipole? That means the strength of the dipole, I guess. Yes, the distance, how far you are, and the strength of the dipole. Yes, both these things decide how strong the electric potential is or the field is. Electric field lines never will intersect each other because the field at a point is, very good. Yes, P and R cube. Yes, P and R cube can also be told as the answer because the electric field formula on the axis is K, P, and then you have R cube over here. So it is dependent on the strength of the dipole. It is also dependent on the distance of the dipole. Perfect. Moving on. Next one. Electric field lines will never intersect because the field at any point has to be along the tangent and no two tangents can ever intersect. There should be always a unique direction. They cannot intersect and there should be unique in direction. Correct. That is the answer. Yes, tangential. Very good, very good. And it should be always unique. You cannot have two tangents. At a point, only one tangent can be there, one direction can be there. If two charges repel by 10 Newton force, if their distance is doubled from 5 centimeter, I make it 10 centimeter. What do you think will be the new force? What do you think will be the new force? Think. Force is K Q1 Q2 by R square. R square. Distance is 5. Now you make it 10. So the distance is doubled. So the square is 4 times. Distance is doubled. So the square is made 4 times. That means the denominator becomes 4 times. So the force will become 4 times less. So 10 by 4 should be the answer, which is 2.5 Newton. No, it is not 5. It will be 2.5, my dear warriors. Just try this out like this if you are not convinced. Like this, K Q1 Q2 by 5 square. Then F will be K Q1 Q2 by 10 square. If you want, divide both of them and try to do it, you will get the answer. So F by 10, this by this. When F is there, 10 square is below. And when 10 is there, then 5 square is below. So this will be 1 by 2 whole square, which is nothing but 1 by 4. So F will be 10 by 4, which is 2.5 of a Newton. 2.5 of a Newton. Yes, that's the answer. Cool. Moving on. Potential energy of a system of two charges is 0 when the charges are, come on. When you have two charges only, then their potential energy is 0 when obviously they must be very, very, very far away. Infinite separation, then they don't know who they are. That's it, their energy is 0. That's it. Next one. Surface over which electric potential is same everywhere is called as, in fact we did the reverse of this some time back. Oh my god, Janendra, happens in a hurry. So this is what happens. Yep. What is the answer? It is a equipotential surface. Correct. Equipotential, equal potential. Potentials are same. Some time back, we did the inverse of this filling the blank. Correct. Electric field due to a point charge decreases as the dash from the charge dash. I think it will be some increase, decrease. Some increase, decrease might be there. The electric field due to a charge will go down. When will it go down? When you go far away from it. When will the field go down? When you go far away from it. Isn't that right? So the electric field will decrease as the distance from the charge will increase as you go far away from the charges. So the distance is increasing, so the field will reduce. Perfect. The final question coming up on your screen. Are you ready? Because now biology is going to start. Baswa sir and Gopika ma'am are waiting for this. I hope you are ready, Gopika ma'am and Baswa sir. Meanwhile, everybody else start answering this particular thing. I'll just message them. Yes. Oh, looks like they are. The work done to move a charge in electric field is the dash of the dash taken by the charge. Okay. How many of you have got the answer? How many of you have got the answer? Very good. Independent of the path taken by the charge. The work done when you move a charge from one place to the another, then it does not depend only on the path taken by the charge. Correct? Very good. It is independent of it. Yes, because it is conservative. Make sure you are a part of the Telegram because there are some amazing quizzes which are going to follow in the weeks to come. And these quizzes are completely academic on biology, physics, chemistry, all the 3 subjects. And it's a completely academic Telegram channel where you get the PDFs, quizzes, and all the important updates regarding to NEET. So make sure you join it and instead of following random things, be a part of our Vedantu NEET English Telegram channel. Thank you so much, guys. It was fun interacting and fun, solving these 100 questions. Now there will be more questions that we'll be doing in the days to come. So continue this session. Don't go anywhere. Now Gopika ma'am and Baswa sir are going to be right over here. And after the session is over, I want everybody to comment, day 1 is done. Day 1 is done of 2000 problems. Within no time, we will be doing 2000 problems. So if you miss these classes, then you will repent or regret later. So don't miss, no matter, even if you feel, sir, this question was easy only or this question was very out of the box. No, irrespective of that, attend it. That's the best way you can improve your problem solving. Bye bye. Captain Shreyas signing off.
Oh, one second, let me check in my phone. Didn't start?
Yes, we are live.
We're live. Amazing, amazing.
Hello.
Hello everyone.
Students, are we clearly audible and visible?
Are we visible and audible to each and every one of you? A quick thumbs up in the chat,
Yes.
which will let us know that if we are audible to all of you.
Okay, I think we are. Okay.
Right?
Let's start. Yes.
Can we? So students, we will be doing 2 chapters. One from botany and one from zoology. From botany side, we will be doing the first chapter in your class 12th, that is sexual reproduction of flowering plants. And from the zoology part, we will be doing
Human reproduction, which sir taught yesterday. So I thought this is the right time for us to, do the revision of it, because mock test also, again, it will help you more. But now it is going to be all NCERT, every single line, right? Yep. Yes. Students, the charts are not moving. What's happening? Are we there? Are we live?
I think, one second. I think there's a small glitch there.
Is it?
Yes. Here. Is it moving now?
Yes.
Nice.
Okay, thank you so much, Vishnu Priya.
Yes. First of all, happy Republic Day to all of you.
Happy Republic Day from all of us. It's such a proud day to be here, right? It's very historic to be here. So that's why we thought, okay, why not both of us come together? So before we start the section, welcome to Vedantu NEET English. We are your master teachers and we are also your biology teachers.
So let's not waste any time. Let's start the first question. So students, every single question today is a direct line from your NCERT. Right? So this is technically like your NCERT line by line also. And this is for both NEET aspirants as well as
board.
Exactly, for both, because board students, this is your syllabus. Your syllabus is your NCERT. For NEET students, you need to know the question format, so that to benefit both NEET as well as board students, we are solving
this. So students, what's the benefit of this? Like, now you would have understood the pattern with Shreyas. Now here also same thing is going to happen, and bio is very direct. There's no explanation as such needed. Once you know the chapter, it is very easy. Okay, so it is just direct. So we will just be doing it direct, and you people have to answer very quickly. Today it's like, you know, the Karopati, fastest finger wins.
And it's also like rapid fire. Think of it as a rapid fire.
Yes,
Let's do that.
Yes. Okay, thank you so much for all of the compliments in the chat box. Thank you so much, students. Okay, let's start.
So we'll be doing rapid fire, and I want everyone to answer the question very quickly, and it's only one word.
Yeah.
It's one word answer, maximum 2 words, right? Maximum 2 words or one word answer. Can we start?
Yes.
Let me know in the chat. Let's show some energy, show some blue hearts, green hearts, red hearts, everything in the chat, and we will start the first question for today.
Okay, so students, I'm sure all of you know about what we are doing. 2000 questions, right?
1 second. Can you go up? No.
Yes.
Yes, I'll just do that.
Yes, students. Okay. Yes, students. So all of you know this is what is going to happen in our victory mock test, which will be ending tonight, right? Today it will be ending. Yeah, today is the last. So if not today, then you will have to pay around 999 to get this mock test paper. So sir, can you tell how many parts are there?
There are totally 5 length, and they are divided into 5 different parts, and it is completely based on your latest syllabus, not your old syllabus, completely based on new syllabus. And this is going to be a mock test which you need to start right now. Do not wait until the last moment. You'll be like, sir, I'll be starting my mock test after like 1 month before the exam. No. Then schedule is every Sunday, time is 2 p.m. to 5:30 p.m. Complete paper solution, that is post test. Also you'll be getting the ranks.
All India rank you will get, and also you'll get a complete 360 analysis of your paper. Okay?
Okay.
So yes, okay, again I have to
You have to click on this, I guess. Okay.
Yes. Students, okay, this is your timetable which we have already posted on our telegrams as well as on Vedantu NEET English. So join us on our telegram and join our family. Okay, yes, shall we start with the first question? Are you all ready?
Ready?
Yes.
Yes, you can get the PDF copy. Everything will be given on the telegram channel. Don't worry.
Yes, students, no problem, right? No problem with the live?
Is there any problem?
Please let us know now, because we are not able to. Yes, we are there.
We are there, no?
Yes, totally. We are there. Okay, students, let's start the first question. Sir, we start sexual reproduction in flowering plants. Okay.
A flowers are not just for human enjoyment. Yes, flowers are not just for human enjoyment, but exist primarily for dash reproduction.
So it is basically for sexual reproduction, right? So I'm writing the answer here. It is also for sexual reproduction, not just for our enjoyment, right? It is continuing the generation after generation. Yes. Okay.
Next question.
Are we all ready? Yes. Can we see a lot of answers?
Can we see the answers? Yes, the live is going on. Are you able to see, right? Or some of you are not able to watch. Sexual reproduction.
Just refresh. Yes, very good. Lot of answers.
Next question, fast mom.
Yes.
The male.
Okay, the male and the female reproductive structures in flowers are dash and dash respectively. That means you have to tell male part
and the female part.
So what's the answer?
Andrecium and gynoecium, ma'am. They'll take their own time and then.
Okay, so the male part is called the andrecium, where you have stamen, there is anther and filament. Then you have gynoecium, which has pistil or carpel. Again, what is that? Stigma style ovary. Right? Yes.
I think I'm going to name it the next question, but
okay. They want us to tell after they tell.
Okay. Yes. After you tell, we will tell the answer. Okay, next question.
The
decision that a plant is going to flower. So plant has to decide that it is gonna go flowering. Is preceded by several dash and dash changes. So what are the changes which a plant needs to make sure before flowering?
Yeah.
Just like before you go to write your exam, you will have to do certain preparations, right? You have to give a lot of mock tests, you have to read a lot of assignments, read out entire cover syllabus. But what does plant has to do?
Yes, so let us know what are the 2 factors or what are the 2 changes that the plant has to undergo. Okay, the answers has to be quick. I think the chats are moving there slow, so we will look on our phones. Okay.
I think the
yes, very good, Sanvi, very good. Yes.
YT, YST. What's the name?
YS. Okay, Devika.
Devika, man. Amazing, Devika.
Okay.
Yes.
Students, lot of you have answered. Very good. It is what? hormonal and
as well.
structural changes.
Exactly.
Yes?
Hormonal.
Physiological also we can tell?
Yes,
right?
physiological changes.
Okay.
That is, the plant releases a lot of hormones, and these hormones are extremely important for the development of the flower, right?
So don't you think it's the same for humans also?
Exactly.
You told?
Exactly.
NH,
Even for the humans
FSH.
also, there are certain hormones such as your ovarian hormones as well as pituitary hormones.
Yes, they're also. I spoke the same thing in our again endocrine. Everything is
related.
continued. Okay, can we move to the next question? Yes, very good. Hormonal. You can use the word physiological. You can use the word structural. Okay.
But this NCERT says structural, so we are mentioning structural here.
Yes. Sticking to NCERT. NCERT is Bible. NCERT is encyclopedia.
Yeah.
Okay.
Next
Shall we
question.
go to the next question? Okay. The differentiation and development of the floral primordium lead to the formation of dash, then the flowers. A little twisted question, sir.
Yes.
Can you break it down? So okay, go on.
So the differentiation development of the floral primordium, that is the initial development of the flower. So there are certain events which need to happen before the actual development of the flower. That is nothing but, anyone in the chat who can tell me?
Yeah, let's wait for this answer because it's a little tricky. Only if you read NCERT you'll be able to answer this
question.
I'm waiting. Quickly put it in the answer. Students, you only focus on typing the answer. You do not have to answer as yes ma'am, no ma'am.
Ma'am, nothing. Just
Okay?
answers. Just
Just-
keep on rolling the answers.
Yes. Fastest finger? Fastest. Okay.
A lot of them are saying bud. But
Okay.
students, remember the bud is the structure which technically gives to the flower. But if a flower needs to develop, there is something called as inflorescence. So inflorescence is the structure which forms before the flower. So if you open your NCERT right now and check, it is inflorescence before the flower.
Wow, Veena told it first. Veena and Veda. And then all of them many also told. Students, inflorescence is the answer. So we know racemose, cymose, inflorescence, right? Type of inflorescence. Older people will come up, younger people will come, right? I've told them in such a way that, there are some
tricks, right?
Yeah.
So what I used to tell is, if it is racemose,
Huh.
right? Who will win the race? Young person will win the race or old person?
Young person.
Young person. So young at the top, old at the bottom.
No, I told it this way where, there are some older people in our home, no? They'll be like, I'm not old, don't call me old and all that. And they will come to the top, like the cymose people. And they'll push the younger ones down, telling, you're old, you cannot do. Okay, simple example. Our parents at the age of 50 can climb on the roof also and clean. But can we?
We cannot do it.
So that is cymose. Okay. Yes. Next question, students.
The two parts of a typical stamen are dash and the dash. This is a class 8th or class 9th level question. All of you will be able to answer this very well. Yes?
See, diagram we have done. Okay?
Yeah.
Easiest question. I don't think I have to wait for this question, students, because this is a stamen, typical stamen.
And stamen has two parts. That is your...
stamen has two parts. That is anther
and filament.
Yes, correct?
Easy question.
Yeah,
Easy
I think students have answered. Sir, check the chats.
Filament and the answer. Yes, everyone is answering filament and the answer. Students,
Very good.
this is actually a line of NCERT. We are not making any extra questions here. All we are doing is taking a line of NCERT, creating a gap, and you have to fill the gap. Clear?
Yes. Easy
Next
peasy
question?
and all they're telling.
Easy peasy. Yeah, okay. Let the questions come now.
Okay. A typical angiosperm anther is dash with each lobe having two thecas. Hence, they are described as. Oh my God, what are they saying? Wait, I will break it down. A typical anther has how many lobes? And how many thecas do they have? Each lobe will have how many thecas? I've broken down the question in the easiest way possible. I think we have to wait for the answer, right?
Okay. I just wrote, I gave a hint on that board.
Oh, really? Oh,
Yes.
oh, no.
Okay, I just write the first one.
Oh, no. The answers came already. They are very fast.
Very
Sharad,
fast.
Subhashni, look at the speed. Hi, students. Hello. Those who joined late, hello. Welcome to Vedantu NEET English. Do not forget to subscribe to our channel because you have an amazing, energetic, enthusiastic teachers with you. And today we are all dressed up for you. And it's also Republic Day. So I am the middle portion of the flag.
I'm the Ashoka Chakra here.
Okay.
Now quickly tell me in the chat how many chakra, how many spokes are there, right?
Yeah.
Let's see who can tell in the chat in Ashoka Chakra how
Very
many
good.
spokes are there. Fast.
Okay, by the way, next answer they already told, okay? Dielectrics also, bilobed also, right? Very good,
question?
students. Yes. Okay.
The dash tissue is present in the center of each microsporangium. Dash structure is present in the center of your microsporangium. Almost told the answer. The dash tissue is present in the center of each sporangium when the anther is young. Look at this statement here.
Look at them, 24. They know the answer.
Everyone knows the answer.
Good GK knowledge, students. We are proud of it. Okay, now tell us. Now let's see biology knowledge. Every day should be Republic Day. I know.
So we can dress up and come every single day.
Shreyas said every day we will be like, oh,
every answers are already coming here.
Yes, very good.
It is your sporogenous tissue. So sporogenous tissue is usually found in the center of the microsporangium.
Only when the anther is young. Okay, when
Clear.
the anther is young, the sporogenous tissue development you will see. Very good. I love the power. It's amazing. The
Next
energy
question,
is
ma'am?
increasing actually. Yes, definitely.
The process by which
Okay. Yes, go on.
The process by which microspores are formed from a pollen mother cell is known as. Simple?
Yes, I think in your textbook, in bracket PMC is written.
Yes.
Okay. And it is a ditto line of NCERT. Okay.
And this can also be asked as a question.
Thank you so much, Shivakumar. Thank you so much, Vijayan. Thank you so much, Devika. Yes. Students, hit the like button. Let me see how many are bunking. They do lot bunking, yaar. This young age only they start bunking. Students, bunking is invalid. Not invalid, no? Crime, huh?
Crime.
Students, hit the like button. Come on. Let's
Tell me
make it
fast.
4 and hit. Very good. Microsporogenesis. I know. We have to keep moving.
If you keep moving one here and there, so it is microsporogenesis, the process by which the microspores are formed from the pollen
Mother cell or PMC.
C.
Okay.
Clear?
Yes, they are faster than us.
Yes,
now we became slow.
Okay, we have to fast up now, ma'am. Next question, ma'am.
The 4 wall layers surrounding a typical microsporangium are epidermis, endothelium, middle layer, and
dash. Which is the...
No, don't say.
Okay. Okay, no more clues for all of you. You need to remember the structure for this. Just remember the structure, you'll be able to answer this question.
Butterfly. Remember butterfly structure. Like this, it's given in your NCERT. Yes, and then they have...
Nice diagram.
Nice, no?
Nice diagram.
Thank you. And then they have enlarged this diagram in your NCERT.
Yes,
oh
the
my
answers
God.
are here.
Very good. Tapetum, right? Tapetum. I will not tell the function of it because the question might pop up. Right? So we'll not tell. But what are the layers?
Let us recap. That is the outermost layer is the epidermis, then endothelium, middle layer, and finally the innermost layer is the tapetum. Clear?
Yes.
Now quickly tell the function also.
Yeah. Okay. Next question. Okay.
Dash layer performs the function of nourishing the developing pollen grain. Which is it? Come on, tell me fast.
Oh, finger art and all. They gave me name and all. Okay. Students, I'm not waiting. You know tapetum is the layer which nourishes the pollen grains, right? So I'm writing the answer. Tapetum.
So students, you need to know the innermost layer is tapetum, and also tapetum is a structure which provides nutrition to the growing pollen grains.
Very good. Look at the answer. My God, I love this speech.
Everyone is like on fire today.
Thank you so much.
Vijay is
Full fan.
Okay, next question. Microspores are arranged in a cluster. Right? Microspores are arranged in a cluster of 4 cells known as.
Okay,
4 is the keyword.
Just convert the 4 word. Okay.
4 into scientific word.
Yes. Come on. The 4 microspores are arranged, right, in a cluster of 4 cells.
That is
called as yes, very
tetrad.
good.
Exactly.
What is it?
Tetrad.
Microspore.
Tetrad.
Very good. Sir, they are faster than us, no?
I know, they are very fast today because students, this is a basic chapter. Your class 12th first chapter. So in order to understand this chapter in a much more detailed manner, you need to understand the anatomy and morphology in class 11th.
Yeah.
Because this chapter is complete foundation is in your class 11th.
Yeah.
Right?
Students, I will take this chapter, do not worry. I promise that I'll take one botany chapter. I'll steal one botany chapter.
So yesterday I took ma'am's human reproduction. I taught you human reproduction yesterday. So ma'am is going to take sexual reproduction of flowering plants from me.
Yes, we just exchange plants and animals.
So don't worry students, we'll be doing this quite often. Because there are some students who would want to see us teaching different botany and zoology. So it's good, right?
Yeah,
We
yeah.
exchange sometimes.
Yeah. And you know that very well that you have seen my botany classes, you
You've
have seen
my
sirs.
zoology classes.
So it's no different, students, just that we have our own way of teaching, but it's definitely content is to the point, right?
Exactly.
Yes. Okay, next question. They are faster than us. Okay. Pollen grains are formed through the dehiscence of the dash.
Very easy question. Ma'am already almost answered the question. Remember the diagram. Remember the diagram. What is this?
That is jet. Rocket. With the helmet, students. Still not better than mine. Students, let's see whose diagram is better.
Now you'll take your own sweet time and you'll do it.
Thank you. Students, answer. Very good.
Exactly.
Yes.
It's the anther.
Anther. Okay, stay there, sir. I don't move. Anther. Dehiscence of the anther. Students, diagram 1 or diagram 2 is better. Please tell in the chat box. We need
All of you should know that diagram 2 is mine. Now you're doing some extra lines and beautifying it.
Students,
Okay,
diagram.
students, remember this dehiscence can happen longitudinally. So the anther can open longitudinally and dehiscence can take place. In some cases, it can happen even in multiple different layers. Okay.
Okay, next question. The exine layer of the pollen grain is made up of dash, which can withstand high temperature and strong acids. Okay, sir, you check for the answers. By then, I'll draw my finger art.
So this is a chemical which helps in withstanding the pollen grain under extreme conditions. That is why it is very difficult to destroy the pollen grain.
Yeah.
First, let's see how many of you can answer this question. Very easy question.
What is this made up of?
What is the ornamentation? Do you see the ma'am's ornamentation there? The exine has the ornamentation, right? Oh, everyone is. So it's the sporopollenin. Yes.
Sporopollenin is the exine layer, then there is an intine layer, right? So that is the reason even if the pollen is being transferred by any means, it does not get damaged. It does its job. So you also have to be that, you should be made up of
Sporopollenin.
Okay, whatever happens in your NEET journey, be strong, stay strong, trust the process, and you will definitely be in your dream college. Okay, students? Yes.
Can we go to the next question now?
Yes, sure. Okay. No, this question, right?
Oh wait, okay. The dash is the inner wall of the pollen grain consisting of the thin layer of dash.
Okay.
Now we know the outer layer is the exine, which is made up of sporopollenin. Now what is the inner layer and what is inner layer made up of? Tell me in the chat quickly.
Come on. I think I'm going to write the inner layer because I already told. Intine
is the inner layer.
I will just wait for them to tell the material.
Now quickly tell me in the chat, what is inner line of the pollen grain made up of? Come on.
Oh.
Already I see. Veena, right? Yes, Veena is the first finger first.
Sharath.
I think Veena was the first person to answer.
Yes. Definitely.
Yes, the inner intine is made up of.
Students, all of you hit the like button. There is 121 students live watching, but the live likes are very less. Conjuice, always conjuice. Even on Republic Day, when all this India
is celebrating and all, still like a no.
I don't want to say history. I'm very bad at history. Okay, what is it, students?
Cellulose and pectin.
Right? Pectin also is given in NCERT.
Yes, pectin is also mentioned in your NCERT. Cellulose and pectin. Now quickly tell me in the chat, your cellulose is it homopolymer and or heteropolymer? Quickly tell me in the chat. If you know the biomolecules chapter,
you'll be showing off his biomolecules chapter, students. Okay?
Students, tell me in the chat, how was the biomolecules chapter? Didn't you learn every line of NCERT? Didn't we decode every line of NCERT of biomolecules? We know cellulose is your homopolymer. Okay. All of you should love biomolecules. It's one of the amazing chapters where you tend to learn chemistry and biology both.
Students, same chemical coordination, integration. Okay? Okay, next question. Okay. A mature pollen grain contains the dash cell and the dash cell. Okay, only 2 cells they're asking. Easy question. Yes.
There are 2 types of cells in the mature pollen grains.
Oh, they're answering.
See that I told you students know the answer. It's very easy.
Whatever.
So quickly tell me in the chat.
Yes. Next question.
Tell me, I'm looking for the answer. First person to answer. The first person to answer.
What they're telling you can ignore.
Yeah.
Amazing class and all.
Amazing. It was amazing. Yes, exactly.
Very good, Sharath. Very good.
Yes, it's vegetative and generative cell.
Yeah, Veena, Sharath, Rupa. Oh, Rupa, Subhashni. Hello. Why yes? Okay, sorry. Malar. Okay, all of our students are here. Very nice. Lakshmi. Yes, Sai Divya. Gautam, hi. Crazy dude, hi. Okay, all of you are here. Very
Exactly, the vegetative cell and generative cell.
happy. Yes.
Next question, ma'am.
Yes, sure.
Easy question.
Yes, very easy. The vegetative cell is bigger. Okay, very important word. Vegetative cell is bigger and contains an abundant dash resource and a large dash. Again, same NCERT line. What is it more? Like, what is more in this cell? We know that vegetative cell is larger, generative cell is smaller.
Yes.
So, what is more in this? Come on. Yes, very good. Crazy dude. Food. First one, food.
First one is food. What is the next one?
Come on, next one.
Reserve food reserve as well as large.
It has something inside. Every cell has a brain, right? I call that as a brain.
Brain.
That brain has some shape or some size or whatever it is. Come on, who is telling the answer first? Very good. Nucleus is correct, but let me know the shape of the nucleus. Is it large, regular, irregular? Come on. Okay, all of them have told nucleus. I think they forgot the word irregularly large.
Yes,
okay?
it's irregularly large nucleus.
Yes, I think Priyadashini got it first. Very good. Okay, yes. Students, next question. Students, you people are typing so fast. They type, yeah.
They are used to texting so much. That's why.
If I have to type hi, I am here, it will take 2 hours.
Mom, I don't even send message. I send voice notes now. I'm so lazy to type. Even I just send voice notes.
No, by the time I tell hi, I am here, they would have already reached the destination. Okay.
Pollen grains are rich in dash, and their use in the form of tablets, syrups has become a fashion for.
Yes. We all are taking it also sometimes, for our hair, for our face.
Some of the athletes also take up the pollen grains. Yes.
Celebrities.
Exactly.
And there's a lot of ads also nowadays coming, right?
Because
very good. Nutrients, the first word.
The first one is your nutrients.
So, can you read it with the answer first?
The pollen grains are rich in nutrients, and their use in the form of tablets, syrup has become a fashion for.
Very good. Food supplements.
Food supplements. Exactly.
Okay, even if you can write supplements also, it's fine. But it's good. Better if you write food supplements.
True.
Good job. Why?
Because we're writing so much.
No, it's okay. We keep moving. They'll understand. Yes, students, did you all hit the like button? Did you all subscribe? Why has the numbers dropped? Come on. Share it with your friends. Very good. We made it 400. Let's make it 500, 600 and
700.
keep going. Keep going to 1K. Okay, next question. Pollen grains retain viability for a variable period depending on dash and dash. That means they maintain their viability is like whatever they content, whatever their purpose is, they maintain that viability by maintaining what and what.
There are certain factors which are extremely crucial for the viability. Just
Same
like even
with sperm also.
even humans or anything.
Yeah.
Sperm also, it needs to be viable. It needs certain conditions, right?
Yes, okay.
Certain
Next
factors.
question. Come on.
Temperature and humidity. Exactly.
Very good. Hi,
Temperature
Shivakumar.
and humidity.
Yes, very good. Okay, next question. Pollen grains of cereals like rice and wheat lose viability within dash of their release. That means how much time?
And remember, students, this rice and wheat are your monocots. So usually in the case of monocots, they lose their viability in a comparatively less time.
Yeah.
So we need the right answer here, as in how many minutes?
Bang tang.
30 minutes. Exactly.
Okay, you can write 30 minutes.
30 minutes. 30 minutes of the release, they are viable. After that, they are not viable at all.
Very good. Okay. The dash represents the female reproductive part of the flower and may consist of a single or multiple pistil known as dash and dash respectively. Sir lied to us that there is only 2 dash, there's 3 dash. Okay. The dash represents the female reproductive part. I think I can write that. Gynoecium.
Gynoecium is the female reproductive part. Androecium is the male. So that is easy. Now next part. The gynoecium represents the female reproductive part of the flower and may consist of single or many pistils.
Okay, single. Let's focus the word single. So single is
known
the first
as
one. Yes. Very good. Monocarpellary.
What about multiple? If there is multiple, it's called as multicarpellary. Simple. Yes, monocarpellary and simple multicarpellary.
Yes, we will.
I think all these are very easy questions for them at this point, right?
Yeah, we will catch them in human reproduction.
In human reproduction, we'll catch you with some nice questions there.
We're not going to lose.
Yeah. Let's see who wins.
Okay. The pistils have... come on. I will draw it.
I'll also draw. Okay, both of us are drawing this one. Okay, students, it's your job to tell us now whose diagram is better again. Okay.
Come on. I'm not taking time, so you should also take
time. Yeah, I'll not take time.
Come on, only this much, okay?
Okay.
You can't jump. You can't jump.
Why?
You can't erase. You can't erase.
Some there is weird thing is going on here.
Okay, students, come on, answer.
Okay, student, this is a very modification here in the stigma has a modification there.
Very good.
Yes, stigma, style and ovary. This is the receptive stigma, long, slender style as well as the ovary. Okay, sorry. Stigma, style and the ovary. Now I'll ask you one question, students.
If you heard Baswa sir scream, that is how actually Baswa sir is when he loses, okay? So all of you notice, right? Right?
Okay. See, they're saying 2 also. Oh my god, everybody is saying 2.
No, they are just feeling pity for you.
No.
Yeah, right, students?
See, genuinely, look, see, this is even open. What pollen tube should enter inside, that's
Some
why.
problem is there, yeah? Look at these people. Yes, exactly. Students, okay. Oh wait, did he draw all this?
That pollen tube is entering there, huh?
Cheating. This he drew, so I lose.
No.
Okay, you people also fell for it whatsoever.
Next
Okay,
question.
I'm sadly with.
The
The ovules are attached to the placenta by a means of stalk called as.
Yes. Starts. It's very easy question, ma'am.
Yes,
Funicle.
yes.
Funicle is the stalk which helps in attachment. Very easy question. Why did it go, ma'am? Did you press the button there?
Sorry. Tick. Yes.
Funicle. That's a very easy question. Let's go to the next question now. Okay.
Yes. Next question.
Okay. Next
The
question.
process of formation of megaspores from megaspore mother
mother
cell.
cell.
So give a slight explanation. By then I think answers will come.
This is a very, again, the process of formation of your megaspore. The answer is there in the question itself again.
Students, whenever the process of microspore comes, it's microsporogenesis. Whenever the words megaspore comes, it's megasporogenesis.
Someone is
it is
asking
not thalamus. I think instead of funicle, people don't thalamus.
Thalamus. What is syncarpillary? Syn means join, carpillary means fuse. The fusing of your carpels is called as syncarpillary. Clear? Any other question? Now you tell me what is apocarpus. Can anyone tell me in the chat what is the meaning of apocarpus?
Students, I have taught you. Come on, answer.
Fast. What is
Okay.
apocarpus?
Yes.
Next question.
Yes, please.
One of the megaspore develops into dash, which then forms the dash.
Okay. So one of the megaspores develops. So the megaspores, that means out of the 4 of them, the 3 degenerates.
One is
Continuing.
So
Okay?
one is functional there, 3 are degenerating. So that is called as.
Very good. Free carpels.
Exactly.
Apocarpellate.
Yes.
Yes, very good. Very good. What's the answer? Yes, very good. Functional megaspore.
Spore.
Right, which one becomes functional, the rest of them gets degenerated. So it becomes functional megaspore. Should I write
Write it off,
megaspore?
ma'am.
Yeah. Okay. Which then forms the embryo sac. Okay.
Clear.
Okay. Yes. Next one. Very good. Very
Amazing. Next question, ma'am.
good. Yes.
A typical female gametophyte or embryo sac. See, so there is another name for female gametophyte sac is female gametophyte. So students, question can be asked on either of the things. They can ask you what is embryo sac or female gametophyte. Now quickly tell me in the chat what is the male gametophyte. Quickly. The typical female gametophyte or embryo sac at maturity is 8 nucleated,
But how many cells?
But how many cells are there? Quickly tell me.
Oh, 7 cell.
Exactly. Oh, that's so quick. Oh my god.
Yeah, they're very quick. We are slow.
Yes.
Students, we are going to write now. Okay, we're now going to look at you people.
So it is 7 cells. So ma'am, can you explain them if you...
Yes. So students, what happens? There is synergids, right? The egg apparatus, antipodal cells, then there is polar nuclei. Now what happens? So 8 of them are there, but then these 2 will fuse. Who 2 will fuse?
The 2 polar nuclei.
will
The 2
fuse.
polar nuclei will form the central cell.
So that's how it becomes 7 cell and 8 nucleated. Okay? Yes. Fine. Very good. Next question, sir. They're faster than us. We have
Yeah,
to
the
go faster.
transfer of pollen grains from the anther to the stigma of the pistil is termed as...
Should we wait?
Fast, ma'am, right? It's a note. Pollination. This is an easy question.
We're trying to win you people.
Yeah, well, let's see who wins now. Next question.
Pollination.
The transfer of pollination.
The type of pollination.
The type of pollination where the pollen is transferred within the same flower is called as.
This we can wait for that. Yes,
Fast.
come on. Students, same flower. Okay?
It's called as. Let's see who said the. Yes, Bantang said it's autogamy.
Very
yes.
good. Autogamy. Auto, I always tell
Auto means
means
self.
save. Yeah, self. Like auto mode in your phone. It regulates the brightness, contrast, exposure, everything. Autogamy means save. Yes.
Automobile, like.
Yes, students, did you all hit the like button? Did we become 500? Come on. 30 more likes, we are 500. No, 450.
Next question.
Okay, I'll read. In dash, the flowers, anther and the stigma must synchronize for pollination to be successful. Okay?
What is the answer? Come on,
I
tell
think
me.
there's already answers there. Look at that.
No. They're answering the last question.
No, Krishna answered. See.
Answer. Okay, again it's same answer, different type of question. That's all.
Autogamy, very good. Autogamy, because if the same flowers, the stigma, the stamen and the pistil are not interacting with each other, how will it happen? Right? Self-pollination.
Exactly. Next question, ma'am.
Yes,
all
sure.
All of these are easy questions for them.
Yeah. Stored. Okay, you can read.
The stored pollen can be used as pollen banks, similar to the seed bank. Right? We have pollen bank just like the seed bank, and it is done by storing the pollen grains in.
Okay, come on. Let's see the answers. So if we have like blood bank, all that, no, like that we have pollen bank
banks.
and seed bank from where agriculture people who are doing farming nowadays they buy. Yeah. So nowadays
all
they buy.
GMOs
Yes,
now.
very good. Bang. I think we should shout out for Bang Tang because he's very fast.
Exactly.
Okay, even
Now,
Sharat, Rupa, they're all very fast.
They're taking
Okay?
the temperature also very 196 degrees Celsius,
Very
minus
good.
196.
Liquid nitrogen in minus 196 degree Celsius. Yes, very good.
Very easy question.
Yes,
Next question.
Okay, the small opening at the tip of the ovule through which the pollen tube enters is called. We had an argument for this, okay?
So, students, I'll draw the diagram again, this time better. So, this is stigma, style, and the ovary, right? The pollen grain is landing here. It is absorbing the water. It is expanding. When it expands, the pollen tube is developing. Yes?
Yes.
And the pollen tube enters, right? Through
Toward
which
the end.
pore?
Yes, very good. Micropylar
Micropylar
end or micropyle. Okay, I think we can write micropylar end.
Yes, micropylar end or micropyle.
Okay.
But the answer is micropyle here.
Okay,
Because it's the
micropyle.
micropylar end here, this is the...
Micropyle.
Okay, I should not say
Okay.
chalazal end because that's the one more...
Chalazal end, some of you are telling no students, it's the micropyle.
Micropylar end.
Okay, because where the egg apparatus is there, that is where it has to enter.
Enter.
What is the use of entering to the antipodals? Nothing is going to happen, no?
But students, it's not in your syllabus right now, but sometimes what happens, ma'am? The pollen tube enters here. But sometimes when the pollen tube enters from here also. But entering into the ovule can happen through chalazal region. Then it'll go round again, then it'll enter the embryo sac through micropylar region.
Like some of our students, instead of
They're eating like this, now they'll eat like this.
we tell, come students, we'll learn NCERT Line by, no ma'am, I will watch full theory, I'll watch extra information, I'll watch an MBBS student teaching the chapter. Yes?
Huh.
Okay, next question. The
dash is the part of the ovule opposite to the micropylar end and represents the base of the ovule. Very easy. Chalazal end, ma'am.
Yes.
This we already discussed already.
Yes, very good.
Chalazogamy. Yes, it's called chalazogamy.
Very good. My God, yeah, students,
They know.
I am so proud to be your biology teacher. Look at my students. Like the energy that you're giving us is insane. And we cannot tell you how nice we feel when the chats are moving so fast. You can see it on our face.
Because everyone knows the answer and it feels that, whatever we have thought is understood by you people.
Yes, so happy.
Next question, ma'am.
Yes, sure. The mass of cells within the ovule that has abundant reserve food materials is called it. That means more food materials or that abundant food material that provides whatever nourishment is required, right? That is, who is doing that? Yes, very good. Yeah,
Yes.
this Bang Tang has fully hacked the questions and all. He knows that.
I think he knows the questions also at this point. So quick. I think he has a fast internet. So he's getting the questions a little early and he's typing so fast.
Very good. Crazy Dude also is trying really hard. Is in very good speed. So many of them.
Students, if this is the case, do you also want to play quiz with us sometime?
Yeah, why not? No.
Like
So much
we
fun.
are... Now we know some of you are answering, some of you not be answering. But do you want to compete with each other? Let us know in the comment section if you want to compete with each other. And
Because we keep competing with
each other.
We
So,
just don't know.
so
Cheese.
if you are okay with it, and if you want to compete with other NEET students, let's bring quiz sometimes, like the Menti quiz or the V quiz type.
Yeah, I
for
think by
them.
the time let them read this question also. Yes, students, we both can do a botany versus zoology or a human physiology versus plant physiology. But once I finished plant physiology, I mean human physiology.
Bangtang is she.
Oh. Sorry. Okay, students, next question. The large cell within the female gametophyte that does not divide but fuses with the sperm to form the zygote. That means it does not undergo division, but it helps in the formation of the zygote. What is the answer? Come on. Yes, we will do V-quiz.
If this is the female gametophyte, here, right? Female gametophyte that does not divide.
They told the answer.
They told all the answer.
They're too fast, yeah.
Too fast, huh?
Very good. Students, let's make it 500 likes. Come on.
It's the central cell. Central cell fused to, that is the polar nuclei fused together to form the central cell. Wait, I did not see if you want to solve, if you need the Menti quiz or anything. I didn't see the answers for that. Students, do you want the Menti quiz? Do you want the V quiz where you can compete with other students? Let us know in the comment section today's video if you want to solve the questions in a quiz manner. Okay?
Yes, next question. Okay, the cell apparatus at the micropilar end of the female gametophyte consisting of 2 synergids and 1 egg.
Cell.
What is it? Okay. No, you don't have to
This is a female gametophyte. Such a perfect. Can you see the perfect bow?
Yeah. Please give them
3
explanation.
antipodal cells that side. And we have the
Egg.
2 synergids with filiform apparatus as well as the central egg cell.
Polar nuclei.
And 2 polar nuclei.
Yes.
So entire thing is called as egg apparatus. Yes,
polar.
it's called as egg apparatus.
Very good.
All of them are very smart. Like they just keep on.
Yeah, our students are very smart.
Exactly, very smart.
My students, zoology students. Okay, next question. Plants. Okay, he'll read.
Plants such as viola, oxalis, and commonelia produce 2 types of flowers, which are dash and dash flowers.
So you have to tell us what kind of flowers are they. Okay, what kind of flowers are they? Yes?
I can't.
Okay, I can't read it. Yes, very good.
Chasmogamus.
Students, what is chasmogamus?
No, let them not tell because we have a questions for that also.
Yeah.
Yeah,
Okay,
yeah.
but don't you think we made something to remember for them? But it was very.
Oh yes. Okay. When the question comes, we'll tell them how do we remember chasmo and Cleistogamus. Chasmogamus and Cleistogamus flowers.
Yes. Next question.
Next question. So in Cleistogamus flower, there is no chance of dash landing on the stigma.
Very sad story. The male does not have any chance in Cleistogamus plant.
How will you remember, ma'am? Cleisto means close.
Close.
If the flower is closed here, right? If the flower is closed here, will the self-pollination happen? Yes.
Yeah.
But will the cross-pollination happen?
Outside, people are not allowed to come in.
Exactly.
Okay. So
In Cleistogamus flower,
I want to tell chasmo also so they can understand the difference.
Yeah.
Students, chasmogamus or chasemogamus, if you say, if you want to chase someone, you have to go out, right? You have to expose yourself as a CBI, police or whatsoever. So this means they will have exposed anther, exposed exposed stigma so that the pollen grains can fall, right? Chas.
it's pollen inside. Pollen landing on the stigma.
Yes, very good.
There is no chance of cross. Next one.
Okay. Gaetnogamy is functionally dash pollination. Okay. Gaetnogamy, other word. Okay. This gaetnogamy, all these complex words came before the simple words which we studied in 8th standard and all. So tell me the
First
word.
we simple in nature we had
No.
self-pollination, cross-pollination.
Yes.
Now we know self-pollination is your autogamy. What is cross-pollination known as?
Thank you, Laharika. Thank you, Nandini. Thank you, Subhashini. They're telling, wow, ma'am, what a trick.
Because we were actually sitting up before the class and we were like, okay, what trick should we make for them?
Exactly. Cross-pollination, no?
Yes.
Students, actually there was no trick, okay? We were just thinking, can we make chas into chase, clear into clingy and all that? But
we were just making tricks.
Went.
What went, ma'am?
No, we are brain
Oh, went.
sense. Okay, next question.
Okay. Xenogamy. Again, xenogamy involves the transfer of pollen grains from one plant to the stigma of
Dash plant. That
same
means-
plant or different plant.
That's all.
Now
Simple.
students, see,
Same,
you know,
different.
so in autogamy, it is a self-pollination. It is a transfer of pollen grains from the anther to the stigma of a same flower. In neatogamy, you learned about cross-pollination, where the transfer of pollen grains happen from the anther to the stigma of different flower, but same plant. But in xenogamy, it involves the transfer of pollen grains from the anther to the stigma of different plant altogether.
Who is that one person who has not liked, because of which I'm not becoming 450? I had kept bet with sir that by 7:30, 40, I will become 450 likes. Okay, come on.
It was 500, no, ma'am. Ma'am is cheating now. It was 500.
No, at 8:40 it will become 500. Come on.
Ah.
Okay. Next question.
Next question.
Okay, go on.
The agents of pollination can be divided into two types. Dash, that is your wind and water is dash type of pollinating agents, and dash like animals are what type of pollinating agent.
Come on, students.
Basically, you should tell me water and wind is living or non-living.
This one is
Animal is living or non-living.
Yeah, but in the scientific term, you cannot tell ma'am living, non-living. Okay.
Again, 8th class answer.
Yeah. Yes. Students, what is it? Abiotic? Biotic. Actually, IGCE students, no, they those people studied by 4th standard.
Fourth standard only.
Yeah, biotech.
So next
Yes,
question.
very good. Okay. Water pollinated. No, I'm reading.
Yes,
Water
sir.
pollinated plants are mostly dash and include the genera such as dash and dash. Oh my god. What is it, students? Water pollinated plants are mostly what? Dicot or monocot. I will give you option dicot or monocot and give to me 2 examples. I'm favoring my students.
I
Are you
know.
feeling that?
So water pollinated plants are mostly your. Let's see.
Let's see. Yes, Shivakumar, your every Friday we'll
Bang
be
is
doing
also
this,
correct.
no?
It's monocot. So it's mostly seen in the case of your monocots and includes genera like plants.
Example. Any examples?
Example. Fast.
You can think of some examples directly from your NCERT, or else you can also, if you're very like.
No. Only NCERT examples. Otherwise, because if you in the examination, in the NEET examination, you will only get your NCERT examples, nothing outside of it. So only NCERT examples. Right? Fast, tell me in the chat. Before
Come on,
I write,
write,
I didn't
wrote,
see any.
See, Vallis
No one wrote Valsinaria, ma'am. No, yeah,
Yes, see.
she banged thanks. She wrote it, I think.
Subhashni wrote it. See, Vallisneria, Sharat wrote. So
I
many
am blind
wrote.
now. Valsinaria and one more.
Vallisneria, see, YS has wrote.
Algae.
Lahara
No. We're talking about monocot. Why will algae come here, monocot?
Yes, Varalakshmi.
Varalakshmi told. Haidullah.
Shravan? Students can't see students.
Old age.
Old age. Okay, very good. Good job. Next question. Sir, next question. Okay. In Vallisneria, the female flower reaches the surface of the water by a long what? Simple. Something has to reach above
If the
something.
flower has to undergo pollination, something has to grow, right?
Exactly. What's the answer? Very good. Now they're telling hydrilla.
Yeah. Now they'll tell. Stalk.
Very
exactly.
good. Okay.
I know at this point, I think some of them have the NCERT open and they're looking at NCERT lines and then.
No, they're just smart students.
Very smart.
Okay, yes, very good. Stalk. Use the word stalk.
Stalk.
Do not use the word stem. Use the word stalk. Okay? Yes. The male gametes of some water pollinated plants are carried by water currents to the simple.
Female
Yes,
flower.
yes. Or female gamete.
Yes.
Or you want me to write female flower only?
Because they go to the flower and they just go on the stigma and then.
Yeah. So students, if something has to travel, right, by water, in the sense water pollinated plants, they will definitely go by water currents, right? Very
So
good.
they're not cheating. Okay. I will believe them.
I know students. See, I already told.
Okay.
Yes. Next question. Wind and water pollinated flowers do not produce dash and are not very dash.
So students, recently if you are joined the Telegram channel, you might have seen a small video that when Gopika ma'am and I were walking on the road, I saw this beautiful flower. And then I
I
pulled
think we posted it on our Telegram.
our Telegram.
By
And then
by Gopika and Baswaraj
sir.
sir.
I think
Okay.
I should change something. So I pulled Gopika ma'am and I was like, ma'am, look at this beautiful bougainvillea flower. But then there was a twist there. Do you see the bougainvillea flower, right? The pink color flower. That is actually not a flower. That is the Bract. And if you open the bracts, inside you can see the
white color
flowers.
Which is very pretty. If it was a big flower, I think the attraction wouldn't have come because the pink modification, yellow modification, white and all
so
that.
if there's a bright color there, the insects will be attract to the color.
Yeah.
So, but what about wind and water pollinated?
Yes,
do they need color,
good.
ma'am?
No,
Do they need color?
No.
Do they need nectar?
Not really.
Exactly.
So it's do not produce nectar and are not very colorful. Okay, so you can write both because they already wrote.
Yeah, they wrote.
Yes, hello, PKL prediction. He's writing such a long hello that it reaches the next state also. Like from
from Karnataka to Tamil Nadu, it's going already.
Okay, next question. Wind pollinated flowers often have dash-like structure to trap pollen grains. That is the thing, no, because the wind is at high speed. If they do not have something, the stigma structure is not proper, then the pollen grains cannot be trapped.
So they have
feathery.
Ma'am, don't let them answer. They didn't answer.
They answered. No,
no one answered still.
Sorry. 1 mark, grace mark. 4 marks, grace. Students, come on, speed up. We have human reproduction also. Then we have Diksha ma'am also. Ma'am will sleep off.
Exactly. We need more and more energy in the chat because after this we'll be doing human reproduction. Both the reproduction chapters are over today. Okay.
Yes. Feathery.
No. Next question, ma'am.
Yes, please.
The pollen grains of water pollinated plants are long and dash to be easily carried by water.
It is not a very, what to tell?
The pollen grains have a ribbon-like structure here which can help them into move in the water current.
Students, I think this should be more of a characteristic. Like, when you study the characteristic, this word ribbon-like word has to catch you. Otherwise, it's fine. Okay, otherwise it will not be a PYQ as such, but instead just for board students, important. Okay, yes.
Next question. Bees,
butterflies, moths, birds such as sunbirds and hummingbirds and bats are common dash pollinators.
I think I can write this one, ma'am. It's very easy.
Yes.
They are putting emoji of ribbon, ma'am.
So that's a bow made up of a ribbon. No, that's a bow. Could be also made up of cloth.
Bow is a structure, right?
Yeah.
Bow is called a structure. The cloth is the ribbon.
It could be ribbon. It could be cloth also. Okay, why are we fighting?
Why are we fighting over that? Everything.
Yes, very good. Biotic.
Exactly.
Very good.
Next question.
Students, we are going to speed up a little. Okay, because we also have human reproduction and you know that Diksha ma'am also has to come in like a little speed, not a lot.
So let's quick up now.
Yeah, because the questions are very light. Only those questions will speed.
We have actually more than 150 questions.
Okay. The majority of insect pollinated flowers are dash and rich in dash. Okay.
Very easy question.
Yes.
It is the complete opposite of the water and wind pollinator. I already told you in the case of your flowers, which needs to be large and it needs to be colorful and should have nectar in it.
Large. And what it should be rich in nectar.
Yes. And it should be colorful also. Very and bright color.
Yes.
Next one, ma'am.
Yes, very good. Yes. Okay, next question. Flower pollinated by flies and beetles secrete dash odor to attract these animals. I think I will write, you should give this explanation definitely. Yes.
So students, we know usually the flowers, normal flower has nectar. It has normal sweet scent to it. Yes, we know we love, sniffing the flowers. They are jasmine flower exactly. Jasmine flower is very pleasant to smell. Even the rose flower. But that will attract the butterflies. But there are plants like the biggest plant, the biggest flower. Rafflesia. That has actually a dead meat smell. Because we know whenever there's dead meat, right, the flies will be attracted, not the butterflies. So certain plants like your Rafflesia, they have the very foul odor, right? So that it can attract the flies and everything.
Yeah, you already know, no? Flies feed on dead, decayed,
matter,
contaminated food and all that, no? Fecal matter. So yes. Next question, sir.
Next question. To sustain the
animal visits, flowers have to provide rewards such as, that is your reward mechanism. If an insect has to come, I have to give some reward, right? Yes. Oh, foul. They're giving emojis also. Yeah, look at that expression. God. My God. So expressive students are. Students, shall I write the answer?
Yes, easy question again, ma'am. Nectar?
Yes. Nectar. And what? Rewards such as nectar. Yes, next. After nectar.
What
pollen,
is the
very good.
Exactly, pollen.
Pollen grains. This is our reward mechanism. See, even we want reward. What's our reward? Your like in comment and let us know how our Duo session
Duos.
was students. Yes.
So
session
students,
was.
I have always told you, right? The more you like the video, the more YouTube will promote the video. It's the.
I think teachers like us should be told to many people, no?
So the reason we are asking you to like the video so that many people can also benefit from the sessions.
Yes. Okay. Insect pollinated flowers that are small and often clustered
It's
into.
easy, ma'am.
Okay, dash to make them.
Conspicuous. See,
One
students.
second, no, I think the chats are okay. Yeah.
Students, if there are small flowers, will the butterfly will be able to see it? No. If the small flowers, if they form a complete bunch, will the butterfly will be able to see it? Yes. So small flowers join together to form an inflorescence where butterfly can easily see them. Clear? Easy question?
Yes, that makes them conspicuous. That means it will look attractive. It will be like, okay, there's a bunch of flowers, now I'm attracted, right? It's like
Exactly.
that. Okay.
Next question.
So,
The flower providing a safe space to lay eggs, like the tall flower of dash or the plant dash, and they're associated with the moths and the examples of mutualism.
that means moths cannot live without them. They cannot live
no
without
one's-
the moth. So you will tell the first answer. Okay, it's an exact NCERT line, right? A is the clue. Come on.
I think they wrote, but they didn't tell, ma'am.
No. Yeah, they don't. Oh my god.
This is direct. It's actually a PYQ, ma'am. This
Yeah.
actually is a PYQ that amorphophilus will, the tall plant will.
No, you should have written it there.
Oh,
Here, Yucca will come.
They should come here.
Then
They should come here.
And then Yucca
Yucca
will come here. Okay.
I didn't see this. I just wrote.
Yucca will come here. Yucca
Has an association with the moth.
moth. Mutualism.
Mutualism.
Okay.
Where both the parties are benefited. Clear?
Yes. Okay. In some species, pollen releases and the stigma receptivity are not dashed, which helps the prevalence of autogamy. What is that? Come on. I think it's a grammatical question more than a question, no?
Yeah, this
it's just a grammar word.
Grammar.
Come on. All of you. Yes. Compatible, synchronized.
So if the synchronizity is not there, the pollen release and stigma will not become receptive. That is, they do not form an association. It's easy question, ma'am.
Okay. Yes.
Next one.
One device to prevent self-pollination is the production of dash flowers. Yes, very good. Students, if we have to avoid autogamy, right, self-pollination, then what are we supposed to do?
So just
Separate
like if
male
you
and female.
Male separate exactly. So keep the male in one room, keep the female in one room.
Yes, andar jao.
And then we have only unisexual flowers.
Yes.
If there are unisexual flowers, will there be any pollination, self-pollination? No. If there is unisexual flowers, it has to only and only undergo cross-pollination.
Right, this is to get variation. That is why we don't accept, marriages which happen inside the family also.
Which
Okay?
leads to inbreeding depression
Yeah,
sometimes.
inbreeding depression, also some genetic disorders
Which gets
we
carried
carry
out.
away. Yes, sir.
Pollination does not guarantee the transfer of right type of pollen from the same species as the dash often
Intervenes. That means what are they trying to say? They're trying to say that self-pollination, see, sometimes pollination does not happen because someone rejects someone. Okay, so you have to tell that someone else.
There are two people here, and if are they compatible or incompatible?
Yeah, they just reject. Like, how now we humans also, right? We don't find something pleasing, we reject it, or we avoid it. Same way, someone rejects. Yes, self-incompatibility, or more appropriate word is pistil
and ovule
interaction.
Yes.
That is your compatibility, right? Pistil ovule incompatibility.
Add of space.
I think you can write pistil stigma interaction also.
Yeah,
Okay?
yeah.
Yes. Yes, very good.
Incompatibility.
Did you say? Okay.
Continued self-pollination can result in dash depression.
Students, see, plants also have depression, and you people tell them, ma'am, I have depression. Give me solution for depression.
See, even though plants are so depressed sometimes, they're smiling with amazing flowers are coming out. They're still, so happy. They're doing the pollination, everything. Photosynthesis they're doing.
They're waking up every day to get the sunlight. Do you get your sunlight? Do you get your vitamins? No, right? And they tell, ma'am, what am I supposed to do? I have depression.
Even the plant might have depression, it is still every day getting up, doing the photosynthesis, providing the food for you, right? Next question, ma'am.
They have stopped laughing also because they're scared. What if I cannot type it faster?
Yeah.
Okay, well, all our jokes are failed. Okay? Students, we'll give you 1 minute break to laugh. Come on. All if you can laugh for all the jokes we have been told from the starting.
They'll be like, what jokes, ma'am? I'm not finding it funny.
Floral visitors that do not bring about pollination but visit flowers for nectar or pollen without pollinating. My God, even they have these problems, yeah?
Exactly. Just not in human nature, even in the case of plants also have this problem. That is, they're providing the nectar. But that kalla, that one, this thing is no, that pollinator, it is just taking the nectar and it is going away.
It does not do pollination.
That is called as your...
Why has the flower beautifully grown and standing thinking that, oh yes, I will get pollinated. But then what is this person coming? I think, what is that? Carpenter bees?
Carpenter bees and bumblebees also sometimes.
Yeah, they come, they rob and go. Okay?
Yes, robbers.
That also they're laughing with so much conjuice, it's become just in their blood. Okay. After 8 nucleate stage in embryo, sac development, cell walls are laid down leading to the organization of a typical female dash. So in simple word, I'll break down the question for you. When an 8 nucleated stage is happening, right? The 7-celled 8 nucleated stage, what is it going to form? That entire structure is called what? Embryo sac. Simple, dimple, right?
You knew that?
Yeah.
You said that, yeah.
You actually copied
No. I saw this real long back. There was a song which was stuck in my head. Simple Dimple, some song.
Oh yeah, Simple Dimple.
So it was stuck in my head.
Okay, fine. I forgive you for copying. Okay.
Yeah, right.
Okay, 1 second. Yeah, this one. The adaptation in wind pollinated plant that aids in capturing pollen grains is the presence of dash, which wave in the wind to trap pollen grains. What is it, students?
Again,
they're just trying to say.
The same question has been repeated, ma'am, but in a different format now.
Yeah. So students understand this is how the questions will be asked. One way direct it will be asked, another way it will be twisted. Okay, twisted. Right? What is the answer? Feathery stigma. Sir is faster than.
Let's
Okay.
Let's see who are
yes,
fast now.
Very good. Raja, very good. Okay. Yes.
Okay, majority of the flowering plants use a range of animals as pollinating agents. Yes, range of pollinating agents with bees, butterflies, birds, and dash being the common pollinating agents.
I know that. They come at night. They're blind.
They gave COVID.
Oh. Nahi tha?
Huh.
No, they gave something else, no? Nipah virus.
Nipah virus also. COVID also, I don't know. COVID, some 8 in the...
something
Yeah.
like that.
They gave the COVID also.
Students, that is we both thinking. Braining. Brain is not braining. What is the answer? Come on. You lizard and all you people are telling.
NCERT is saying one small line.
Small word. Students, yes, very good. Super 6 series. Bats. Lizards.
Lizard.
Sharad told her lizard.
Where lizard doing pollination?
I don't know what lizard it is. He told some
commodity lizard.
Shena also is telling. Bats, garden lizard.
Garden lizards.
Students, that much technology you don't know, okay? Students, questions are not in order.
See, the questions are not in order. We have actually a lot of questions. There are questions are not in order.
Whichever repeated, we removed it. Whichever looked similar, we removed it because we want more questions to be answered than, repeated questions to go on.
Just like your NTA, how they removed the same syllabus, right?
Exactly.
We also removed some same questions.
Okay. The fusion of male gamete with the egg cells forms a diploid cell, the dash. Okay, dash. Come on. Students, do not care about the question numbers. Question numbers? How are you bothered about the question numbers? Look at the question.
Ma'am. The fusion of male gamete and female gamete
Raja told the
is the zygote.
Students, even if one student tells the answer, that means that much time is enough for you to type, right?
Yeah.
Yes.
The other male gamete moves towards the two polar nuclei located in the central cell. So one male gamete is fusing with the egg and making the zygote.
Yes.
The second male gamete is fusing with the two polar nuclei. And then to produce a triploid primary dash nucleus.
This is the clue. Pen. Very good. Endosperm.
Endosperm. Very easy question, no?
Yes. Okay?
Let's go to the next question, ma'am.
Yeah.
The fusion of 3 haploid nuclei in the central cell is termed as dash fusion. So 2 polar nuclei plus 1. 2
Okay.
plus 1 is
2 plus 1
is 3. So triple fusion.
Students, 2 plus 1 is 3, not 3.
Because what is it? Triple fusion, that's why. Smart, na? Smart.
Very smart, sir. I'm proud of you. Yes, very good.
Triple
Crazy
fusion.
good. Triple.
Next.
Yes.
Oh, this is a question.
Okay. Okay, ready? Yes, very good, very good. The zygote develops into and dash while the primary endosperm cell develops into endosperm.
Very easy. Zygote develops into the embryo. Easy question. I don't think this needs explanation. Next question.
Wait, this question. Okay. The most common type of endosperm development in the pen undergoes successive nuclear division to give rise to free nuclear endosperm known as dash. Okay, dash. Come on, let's wait for the answers. Come on, read the question quickly. Read the question quickly.
Dash endosperm, fast, tell me. Exactly, Raja. It's nuclear endosperm. Yeah, need some water.
Yes, very good. Nuclear. Okay? Nuclear. Students, question numbers are not in order. Question numbers are not in order. Do not say, ma'am, you missed 116. Repeated questions are removed. Okay? The endosperm may neither be completely consumed by the developing embryo or used up during seed germination as seen. Okay, the types. Remember? Types. Okay? So just give me...
In the case of your dicot, it's completely consumed. And that examples which is given in your NCERT...
You have to write.
My voice changed after drinking water.
Okay? They're complaining. Ma'am skips one question between two. They don't know that the numbers are not in. Okay, come on. What are the examples?
One is your pea, other one is your groundnut, and the last example is given in your NCERT is beans. The same example is also given in the case of your morphology of flowering plants chapter. Okay?
Correct? Beans, groundnuts, peas.
Arey, don't worry, the question is skipping because we have more questions. The questions are...
Students, repeated questions have been skipped. Relax. Okay, you will get the entire PDF.
The early stages of embryo development
known as dash
are similar in both monocot as well as dicot. It is called as your fast
Yes,
term.
students, I will teach next week. Okay, next week I'll teach this chapter. Sexual reproduction in flowering plants. Come on. What's the answer? Quick. B and beans. Sorry, beans and pea. Pea plant and beans. Okay. Tongue twister is happening. Robber. Groundnut. Students, they're still in nectar robber. Come on, move on. Very
exactly.
good. Embryogeny. Did we cover all the questions from this chapter? Yes?
Almost it's covered.
Yeah. Then we can go for human reproduction. The globular, heart-shaped and mature embryo stages results in the formation of a typical what?
Dicot embryo. I think they told her.
No. Wait. They're still telling embryogeny. Good job. Can speed up.
I think we're taking so much of their time, ma'am.
Sir wants to do human reproduction faster because Sir's chapter, no? Sir taught the chapter. That's why. Yes.
Apomixis one question. It'll come. It's come. Parthenocarpy, everything is coming. Wait.
Yes, dicotyledonous embryo.
I'll just dicot embryo.
Okay, yes, very good. Okay, the globular heart shape. Very good. Good job. Okay.
Next question.
The embryo consists of an embryonal axis and two dash
Dicot.
in the dicotyledons. That means simple. Dicot has what? Two of dash what?
Dicotyledons. Now quickly tell me in the chat what is the function of your dicotyledons. Tell me in the chat fast. What is the function of dicotyledons? And what is the requirement of dicotyledons to the plant? Let's see who can answer.
Cotyledons, they told, no? Yes.
They told, ma'am. They told.
Very good. Okay.
Now let's go to the next question, ma'am.
Oh, sorry. Yes. The cylindrical portion below the level of the cotyledons is dash, which terminates with the plumule or the stem tip. Okay?
It's called as.
What is it called as? What is it called as? Come on. Let's wait. Yes. Go on.
No one is answering still.
I think
Storage, yes.
Chats are a little slow.
No, they're typing slow now, ma'am.
Oops, sorry. Students, come on. Drink some coffee. Bring back the energy. Yes. Very good. I don't know.
Arun, yes.
Okay. Hypocortile. Okay. Very, very good. Yes. Okay.
Next question.
In monocotyledons, the embryonal axis has the dash that is situated towards one side. Okay, what is that?
The cotyledon is called, in the case of monocot, is called as scutellum. And it is the same scutellum which divides the embryo as well as the endosperm. So endosperm is on the top, scutellum is on the bottom, which completely covers it. Clear? Your endosperm, embryo, middle is the
Yes,
scutellum.
Students, I think all of us learned it in the monocot seed, right? Scutellum and all that,
Yeah.
right? Yes. So I think we should pick the questions from apomixis because these questions are,
easy, right?
yeah.
This is again easy, right?
Yes.
So,
Oh, is it? Wow.
ma'am?
Our network problem. Yes, actually. See, scutellum has come in. Yes. Students will keep the phone also. We'll check the phone. Sorry. Okay. Yes. Okay. So.
The embryonal axis above the level of the attachment of the scutellum is epicotyle.
Yes,
That is also an
correct.
answer. Okay. Which has a shoot apex and a few leaf primordia enclosed in a hollow follicular structure. The dash. I think it's incomplete, ma'am, here.
Okay. But I think you can think of two people.
Right.
C and C. Yeah. CSGO.
So there is a game called as CSGO, right? Counter-Strike game.
They
That's
got
how
it.
I remember it. That is coleptile.
They got it.
They
Okay.
got it,
Yeah.
okay.
Don't you tell, you continue.
Yeah,
There'll
it
be
is
some
easy.
students who
Coleptile is covering.
Yes.
Next question.
The
The final product of sexual reproduction in angiosperms is the dash.
Come on. Quick.
The final product of your entire reproduction is nothing but seed. I think it's easy again, Mohammed. Oh, see, the seeds
Yes,
are,
very good. They're
the
fast.
seeds have no residual endosperm as it is completely consumed during embryo development, and it is termed as zygote. No.
See, students.
Zygote is the initial product.
End
product. Exactly.
product. Don't learn the mid product.
Yeah.
Yes, correct. Come on.
Non-endosperm. Exact. Non-endospermic or
I think more appropriate word.
non-albuminous.
Non-albuminous or
exalbuminous.
Exalbuminous. Students, we'll see how much we can cover today because also at least by 8:30 we should start chemistry, otherwise it will become too
Too late.
long of a session and it won't be, you cannot stay also, right?
And
So that's
true.
the reason. We'll see how much we can cover today. Okay, but definitely you have already done a lot of questions from this chapter and every single topic also. All the questions we will do, but we'll see how much we can go. Otherwise, next Friday we will continue from there. Okay, do not worry. We are here to do it for 5-6 weeks that is going to come. So don't be like, oh no, ma'am
Every
didn't do
single-
that, ma'am didn't do this, sir didn't do this. Do not worry. We will do it. We'll continue it in the next class. Okay, in case we are not able to
The
finish.
residual persistent
Nucellus.
nucellus in
In
some
some
seeds
seeds.
such as the black pepper and beet is called as the residual, right? Persistent nucellus.
Very good, Raja. Very
It's called
good,
perisperm.
Sharad. They have understood.
This is actually a NEET previous year question, ma'am.
Yeah, perisperm, no?
Yes.
Okay, very important. Students, and you will also get a PDF on our Telegram, which is Vedantu NEET English. So
English.
quickly go join the Telegram and you will get the PDF. Okay, even if we have skipped some questions because it's repeated,
Repeated.
you can still go answer.
You will get the complete unedited file for it where
Yeah.
all the questions are given. Okay?
Yeah. More than 200, 300 questions. Okay. Yes. The transformation of ovules into seed and ovary into fruit proceeds simultaneously. So ovules into seeds, ovary into fruit. Okay. And the wall of the ovary develops into a wall of the fruit, or the fruit wall.
Fruit wall is called as.
Did I say the answer? No.
No, you didn't say the answer. ma'am. Pericarp. No, they're saying perisperms. Oops.
Okay, come on.
Crazy saying yes, pericarp.
Very good.
Exactly.
Crazy dude. Pericarp. Right? We have pericarp, mesocarp, endocarp. Right? Yes. Very good, Laharika. Very good. So many of you. Okay.
Yeah.
Dharani.
Now that's how we want the chat to move. Like a very
Yes.
quick movement of chat.
Yes.
A few flowering plants, as some species of Asteraceae and grasses, have evolved a special mechanism to produce seeds without fertilization is called as.
Sharat, answer.
Answer. Tell me this answer first now.
This
That
the
is
question
seed
for Sharat.
without fertilization.
Very good.
Apomixis, exactly.
Yes.
I think we're coming to the end of the chapter now, ma'am, right?
Yeah.
Next question, ma'am. The genetic nature of apomictic embryos could be called dash because they are genetically identical to the parent plant.
Okay.
Now, students, if there is no, fertilization, is there any mixing of genetic material? No. So it is technically a type of asexual reproduction, and we know the progeny obtained from asexual reproduction is always morphologically and genetically identical
Similar.
to the parents.
It's like taking a Xerox.
That is
Right?
called as clones.
Clones.
Exactly. I couldn't read only.
Yeah, I saw Gopika
Ma'am, I couldn't
went
read.
off. Students, we are old, okay? Until our vision,
Yeah, we take time to read because it's so far and then the chat
it's
is.
so fast and far. Oh, thank you, Dr. Lins. Okay, he has typed it in Malayalam. Okay?
Okay.
He's telling that I look good in white.
Okay, let's go to the next question.
Okay.
The
Yes.
seed is the basic unit of reproduction for angiosperms and is often described as fertilized dash which forms inside the fruit. Easy question, ma'am.
Easy question. Come on. Yes,
I think
very
we already
good.
told this, ma'am.
500 likes. Yes, we did. We reach
We
500
did.
likes.
I don't think so, ma'am.
We don't. Yes, we did. Ooh, very good.
505. Okay.
Yes. What is it called?
It's the ovule.
Ovule.
Okay. Ovule.
Yes. Good
Okay,
job.
next question, ma'am.
Yes.
Occurrence of more than one embryo in a seed is referred to as dash.
Occurrence of
Occurrence of more than one embryo. See,
anything more.
more is called as poly.
So if you add embryo,
It's
polyembryo. Okay.
Easy question.
Yes. Very good.
Very good. Polyembryo.
A typical anther is.
Okay, this is easy question, ma'am.
I think this is almost to the
Anther is
end
dash
of this
and dash.
chapter. Okay.
A
Yes.
typical anther is bilobed, it is dithecous, and it is tetrasporangiate. I think they know this, ma'am.
Yeah. Bilobed, dithecous, tetrasporangiate. Oh.
No. You got scared.
I thought it's not writing.
Huh.
Yes. Tetrasporangiate.
Clear? Next question, ma'am.
Yes. Sorry.
I'll just see the question. I'm getting some water.
Please. Thank you.
Apomixis is a form of dash and it mimics what? I told you already, apomixis is a type of asexual reproduction. Yes, and it actually mimics the sexual reproduction. Clear? Right? Apomixis is a form of your asexual reproduction. It is a type of asexual reproduction. And it mimics what? It mimics the sexual reproduction. That's why apomixis is a phenomena where your seed is developed without fertilization. Yes? Can we go to the next question? The next question is here. The next question is, the oldest seed is that of a simple question. The oldest seed, direct example question. I'll give you 5 seconds to answer the question. Let me count down. 5, 4, 3, 2, 1. The answer is date palm. It is a direct NCERT question, right? Direct NCERT question. Can we go to the next question now? The next question here is the dash and dash of mature seeds are crucial for storage of seeds which can be used for food throughout the year and also to raise crops in the next season.
So what is it? Dash and dash of mature seeds. Okay, so come on, date palm. What are they writing date palm for the previous question? No?
Question.
Okay. Come on, faster. We have to make chemistry. We have to do chemistry.
Phoenix. Why is someone writing Phoenix?
No. He might be. Don't know. I still don't know.
Why the Phoenix?
Okay, they're talking to each other. Hi, Phoenix. How are
Okay,
you?
they're talking to each other. Oops.
No, they're writing, yeah, Phoenix. Okay, they're giving other examples.
Phoenix.
Ma'am knows Telugu. Andariki namaskaram. That is only how much I know,
Yes.
students. Okay, I don't know the pronunciation of some words.
But ma'am can fluently speak Malayalam. I
Yeah,
can
yeah.
fluently speak Kannada. That's
That's our mother tongue. Very good. Dehydration and dormancy.
Here and there we can manage some Tamil also, right? Like here and there.
I'll tell you. What I know.
Tannikudu. That's what I remember from my undergrad. I had a friend who used to teach me Tannikudu means pass water.
Tannikudu.
Tannikudu.
Okay.
And then there was also Vanakam, right?
Thank you, Sharad. Okay, Vanakam I know. Epidi irikungo. Epidi, no.
No, I don't know. I don't know.
Tell
We
us
should
in
learn.
the chats if I'm correct. Okay, epidi irkinge. Gay.
Correct.
Epidi irkinge.
I don't remember.
Epidi irkinge.
Then
Yeah. I used to watch a lot of Vijay and Surya movies.
Mm.
But I didn't learn anything.
Next question.
Okay.
Being the products of sexual reproduction, they generate new genetic combination leading to the
I think this will not
genetic diversity. It won't come as a question?
Yeah,
Okay.
let's skip.
Banana is a dash fruit.
Yes, important. Banana is
Is
the
that-
Adipoli. Yeah, Adipoli I know. It's about it. Epidi irikungo. Irkinge.
Ga.
Ga. Manakam.
Yeah,
Manakam pasingula.
that even I know. Okay.
Come on, don't tell. Manakam pasingula.
Manikam pasingula. Okay.
എല്ലാവർക്കും നമസ്കാരം സുഖമായിരിക്കുന്നു എന്ന് വിചാരിക്കുന്നു.
Whoa! That was nice. It is a parthenocarpic fruit.
Parthenocarpic, yeah. Oh, students, sorry students.
No space.
No students praise for the fruits. Yes. Diksha taught me Punjabi also, I forgot. Very difficult words.
Okay, dash can be included through the application of growth and growth hormones. Such fruits are seedless. I think this is a typo here, ma'am. Seedless fruits can be induced through application of growth hormones. That's all. Seedless fruits. So right, seedless fruits can be induced by gibberellins as well as your auxin hormone.
Yes.
Right?
GA. Yes.
Immaculate flowers have to be covered with a bag of suitable size, generally made up of dash paper.
Circa reaction will become famous. Students, do not forget to tag us on Instagram. Take a screenshot of us and tag us on our Instagram. Mine is Gopika Biology, Baswaraj sir. Okay, and Captain Shreyas, Diksha Kaushal. So you can tag us on our Instagram and also follow us on Instagram. We will be putting our some other than our teaching life there. Okay, yes.
I think I should make
Please talk Kannada.
Kannada le ಮಾತಾಡಬೇಕಪ್ಪ ಈಗ.
ಏನಾದ್ರು ಮಾತಾಡಿ.
ಮಾತಾಡಿ.
Yes, butter paper.
Butter paper.
Students, we spoke all the languages.
Just today.
Okay?
I know.
All the languages. I mean, Punjabi though, I don't know. Yes,
In Malayalam also I learned few lines like etra samay baki aana and all full on.
Etra samay winter. We have to give Diksha ma'am in 10 minutes or Diksha ma'am will be so shocked.
Rocked.
Dash grows through the tissue of the stigma and style and reaches the ovary. Who grows?
The pollen tube grows. That is the chemotactic movement. Yes?
Yes, Shana, I'm a Malayali, sir is Kannadiga. Okay?
Yes.
And we can balance with little Tamil, little Telugu,
here and
little
there.
Hindi.
Because when you grow in a school, when you are in a school in South India, right? We have all our friends are basically from Tamil Nadu, from Kerala, as well as from your Andhra Pradesh and Telangana. So we tend to learn other languages. That is the beauty of South India,
Yes,
right?
yes, totally.
pollen tube?
Roshit is a student who used to follow me when I was doing Malayalam.
Oh.
So yeah, he's so happy that I spoke in my mother tongue after so long. Okay.
Okay.
Yes. Next question.
Next question. The generative cell divides and forms the dash. Easy question. Generative cell divides and it gives rise to your two male gametes. Out of the two male gametes, one male gamete fuses with the egg cell. The second male gamete fuses with the central cell.
Students, did you all subscribe to the channel? If you subscribe, put red heart. Okay? We will take a little rest with our throat.
Huh. I think we're taking too much of time, ma'am. Like, I think my reproduction will...
Yeah, but it's okay. We can take it next class. Always.
Exactly.
Students, the goal is not to complete lot of questions. The goal is to have a fun, a very refreshing class.
And also learning.
Okay, because you have completed this chapter and this chapter is definitely a big chapter. It is not a small chapter. It's not a small word like 1, 2, 3. No, long answers comes, right? So that's why. So do not worry. We will take from wherever we stop from next class. We will continue from there because we also need chemistry class to not go till like if we keep on going, no, we'll go till 10 o'clock.
Actually, if we teach the human reproduction now, it'll take 2 more hours. We'll go for 2 more hours.
Okay, so I hope all of you understand. We'll stop in sexual reproduction of flowering plants. Okay, again Diksha ma'am will do chemistry, so the live will continue and we will see till where this questions are. I think we have one more question.
1 or 2 more questions is there.
Yeah, okay, next question.
Someone is saying Namaskara Largo. Yeah, Namaskara Veda.
All of them subscribed. Whoever subscribed to the channel, put red hearts. If you haven't subscribed, don't cheat.
Just subscribe right now then.
I will find it out. Yes, Basaraj sir and ma'am's army. BG? GB.
Something.
Gib. GB.
GB.
No, that's not
Gigabyte.
Nah.
BGMI. That is PUBG.
No, what is that? All of them. Okay, Basaraj
Alright,
sir,
sir.
Gopika ma'am, Capto, Diksha ma'am.
Okay, they'll make a ma'am. We'll just finish this.
Okay, go on. Next one.
Okay, next question. If a flower parent produces unisexual flowers, there is no need for dash.
Come on.
This is in regarding with the artificial pollination, right?
Yes, good job. All of you subscribed.
Huh.
Yes, what is happening? If very good. Who
That is
that?
emasculation. Exactly. Emasculation.
Emasculation.
We have a habit, right? When we write around, we tend to pronounce it and write.
You know, when I write some words in capital letter, it never looks right. Now, example.
Huh?
Okay, this looks fine.
No. Exactly.
But this looks totally fine.
Yeah, that's a illusion. Some trick. Brain is some tricking.
Brain cells are like, oh,
Huh.
dancing. Come on, next question.
Dash is a regular mode of transport of male gametes among the lower plants, groups such as dash and dash.
Oh my god. I think we are going to write the answer for this because it's a very big question. Okay?
Students,
So what is this
if you have learned the chapter Plant Kingdom, there you learn about your algae, bryophytes and pteridophytes. And if you know, in the case of your bryophytes and pteridophytes, we have the male biflagellated anthrozoids which swim in water and reach the female, right? Female gametophyte. So water is an extreme requirement there. That is why we also call bryophytes as the amphibians of Plant Kingdom.
They told the answers.
They told, they're very smart.
Very good.
Next question, ma'am.
Yes.
This method of embryo sac formation from a single megaspore is termed as?
That means out of the 4?
Only one is
Yes.
functional. That is called as mono means one, so monosporic development.
Okay.
Yes, monosporic development. Someone is telling it Bago team, it seems.
That means
Why Bago? Why is O?
that they added extra. Bago. I think for D they took it as O.
Oh, it's D.
It's D. Diksha ma'am. We have to change ma'am's name. With O, we'll tell her.
Okay, ma'am.
We will ask her to change her name O. But students, Bago.
What is? They'll run away. What is this?
We want people to come, not run.
Away. Okay, next question, ma'am.
Yes. Humans are... No.
Oh, done. So that is the end of students.
Yes. So students...
That is actually the end of the chapter now. From here, actually, your human reproduction chapter starts. That is, humans are sexually reproducing and viviparous in nature.
Okay, so we are planning to do human reproduction next
class.
round. Okay, so today we have done lot of questions actually. I think we have done more than 100 questions.
Actually,
we have
more
done.
than 150 questions we have done now.
Yeah, because sexual reproduction in flowering plants had a lot of questions. It had around 200 questions. So we filtered out the best questions, and some questions we skipped when they are repeated or the same pattern. Okay.
True.
So yes.
As you can see here, 186, it was actually 200. Now, out of the 200 questions, we removed, filtered out, sat and removed it so that all of you can understand and practice the best questions there.
Yes, students.
But do not worry, in the next class, we have human reproduction. There are so many questions from
Beautiful questions. Beautiful questions.
Like,
our team has worked so hard in creating such a
amazing questions.
amazing questions. And you'll get all of this PDF for free, students, for free. We are not even charging you 1 rupee.
We'll bring them on the screen now.
Yeah. Come on. Let's bring them here. Students, let the chats move. How was the session? Let us know in the chat box. Wow, it looked like a Republic Day event, you know.
Where?
No, we both.
Yes, Laharika, the PDF will be available in the Telegram channel.
Yeah, Sharath is killing my name. Sharath, not allowed. Okay, students, let us know. Students, next class is on next Friday.
Ma'am, tomorrow you tell your class, no?
Oh,
Tell them.
sorry.
We'll go here. Students, first of all, you go here.
Subscribe.
Okay. Click on the.
showing.
It's not sure. Okay, click on subscribe. Okay. Then go here, Telegram channel. Victory mock test series. Click on this. You will get this particular page here. Yes. All you need to do is enroll now.
Students,
What is the price? The price is completely zero. Only until today's night. Only till midnight here.
Yes.
After that, it will become 99.
you remember when
999.
we used to be in college, there used to be a time called 11:59. You had to submit your assignment.
Oh my god, in Google Classroom.
Exactly.
You have to submit, and if you're late, marks will be deducted.
Exactly, 11:59. Before 11:59, enroll, get your mock series. Anyone who has a problem with any of the OTP issue,
choose.
because you know, like students, this is also like how you watch cricket or not, suddenly net shutdown will happen.
Server problem can happen.
Yeah, so it is going to be some server problems can happen. So we have sent you an email ID through which you can put what are the queries you have, and they will contact you if you give your phone number and email ID. They will directly connect with you and solve your issues. It's not like you have an issue and we will just let it go like that. We will make sure that you solve the issue and you all get the Victory mock test series. And I was sick yesterday, so I could not take body fluids and
We'll show them,
circulation.
we'll show them.
So yes,
If you go here right now and click on this
channel
and see
Live.
Victory series again and go to the live
here.
and check.
never mind. Students, look here, all of you, body fluids and circulation,
Pollination.
where I will be teaching about the heart. So do not break my heart. Be in the class tomorrow at 5 p.m.
Nice line. Oh my god.
I have
Love
been
it.
shocking Sir lot many times today. So it's the first time Sir is in my session for such a long time. So he keeps telling me that, ma'am, how do you keep cracking, jokes instantly? So it is in
Don't
my...
break my heart, it seems. Oh, wow.
So, yes,
I
I'm
am
going to...
flabbergasted here.
I'm going to teach you about heart. So don't break my heart. Be at 5 o'clock tomorrow.
Go here right now. First, like the video now. All of
Yes.
you. I see only 20.
Let's
So-
make it 200 likes. Then
Yes,
only I'll
I
come
was going to say
live.
2000, but.
Isn't that too much?
No, nothing. They can do it easily. So make it at 200 by today night itself. When Gopika ma'am is coming tomorrow live here,
Yes.
increase the like count here. See,
Students,
I also
otherwise live cancelled. Live cancelled.
How do I go back now?
They're telling may these 2 kids live long. Students, did you call us kids? Tharini. Okay, wow, the love is amazing. Students, let us know in the comments how did you feel our
Exactly.
both class. Okay, students, if there is no 200 likes before 11:59, your marks will be deducted. I'm the
Yes.
principal.
That will happen. Absolutely, that will happen.
Okay, yes. So go increase the like immediately. Oh, which is this video? Yeah, I thought already they made it 500 likes. I was so happy.
No.
Okay, students, body fluids and circulation, very very important chapter.
Yes, tomorrow.
I will draw the heart and I will explain it to you.
You just see this heart.
Yeah, this heart. Students, I cannot draw the other heart. Okay.
Uh.
So yes, did you all go like? I am from Alapi in Kerala. Okay. Yes, tomorrow.
That's what I said yesterday.
Yes.
So after 4 hours of class, our tongue starts to twist. So instead of saying tomorrow, I'm saying tomorrow.
Laharika caught it. Yeah, Laharika is very sharp.
Not only her, there were every other student was spamming in that tomorrow.
Yes.
No, that's because I called them dum. That's why. I called them dum. They're taking revenge on me.
Very good. Continue the revenge and join Body Fluids and Circulation. 11:59 sharp on Telegram. I'll put how many likes. If it's not 200, class cancel. I will never take Body Fluids and Circulation. I'll not take Human Physiology.
You will not take zoology.
Class.
Not take zoology.
I'll not take class. Okay. So yes, students. Rhinovirus have planned to, today afternoon also it was there, but somehow I took all the antibiotics possible on earth to be here. Okay. Yes. Thank you so much.
Thank you so much.
Diksha ma'am will come live.
Yeah, don't go anywhere. Diksha will come now. Ma'am will also do a similar type questions from your chemistry. So I'll see you on next week.
Yes.
Next week, which chapter should I teach them, ma'am? Next chapter. Okay, students, let us know in the comment section which chapter do you need next. It can be your class 11 chapter, class 12 chapter, anything. Let me know in the comment section which next chapter you need from my side. Okay?
And do not forget to comment how you felt about the session, because we are very excited to know, because students, we could not see a lot of live chats. Okay? That's why we are very depressed. So please put it in the comments how you felt it, and see you all. Do not go anywhere. Drink water, take coffee, eat dinner, and come.
Hi everyone, welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. How are you everyone? Firstly, happy Republic Day to all of you, and I wish you all the very best for your future. You are the future of our country, so do the hard work and prepare yourself and make us proud, make the nation proud, right? Okay, so how are you all? Firstly, how are you all? And I know that you are studying for last 3-4 hours. Firstly, you did physics, and after that bio. Now is the time for chemistry. So now today, bacha, we are going to do DNF block. As you know, inorganic is basically inorganic. I'm saying inorganic, not organic. In inorganic, everything is asked from your NCERT as it is, from line to line. That is why we have picked DNF block for this particular series. So firstly, we are going to complete inorganic by using NCERT line by line. Okay, because guys, as you all know, firstly let me give you a trailer of this. Guys, as you can see, I have also picked the snips of that question. I just want one thing from you. Just pick your NCERT book, chemistry book, and open the DNF block chapter. Okay, and start ticking all that. Okay, wherever you find these answers, just start clicking all that, because that is directly from line to line. Every single line that is important in your NCERT, that has come in the form of question, in the form of examples, in the form of fill in the blanks. Okay, so are you all ready? Everyone in the chat box, are you all ready? All guys, I want hearts in the chat. Let's have green hearts in the chat. Okay, let's have green and orange hearts in the chat. There should be orange heart, then white heart, then green heart. Okay, everyone, let's make our flag with that heart. Everyone in the chat box, I want all of you to make the hearts in the chat box by using that flag. Make a flag using the hearts, orange, white, and then green. Orange, white, and green. I want to see our nation's flag in comment section. Everyone in the chat box, yes, everyone. Starting study, yes, very nice, beautiful. Blue also, that tint of blue, right? That tint of blue. Yes, very nice. Okay, so let us, Captain is saying, okay, red. No, there should be orange, then white, then little bit of blue, then there should be green. Everyone in the chat box? Okay, perfect. So let us start without wasting any time. Let us start the session. Okay, guys. So firstly, every question you have to answer in the chat box. I'll see your answers in the chat box. Okay. So let us start. The DNF block. This is directly from the NCERT line. So let us start the session. The D block of the periodic table contains the elements of group. D block. How many elements? From which group? From the D block periodic table contains the elements from groups. Which are the groups that are involved here? From which group to which group? Everyone in the chat box, what are the groups that are involved in the D block? Everyone, the very nice. The answer here, very nice, very nice, very nice. So the answer is 3 to 12. 3 to 12, your first page of DNF block. First page you will find the answers to this basic questions. Next is the F block consists of elements from this to this orbitals are progressively filled. For F block, they are asking me in which the dash and dash orbitals, which orbitals are progressively filled here? Which are the orbitals that are progressive? Is there any lag here? Is there any lag here? Everyone, is there any lag? Okay, come on, very nice. Okay, so here the completely filled the orbitals that we are going to fill are 4f and 5f. These two makes different lanthanoids and actinoid series, right? Okay, so these are the additional orbitals that we are going to fill. Next we have elements with partially filled d orbitals are known as partially filled orbitals. Partially filled d orbitals, what are these called? Everybody in the chat box, what are partially filled d orbitals called as? Everybody, they are called as transition elements, right? There are few examples that are under D block but they are not transition elements, right? Like zinc, right? Okay, so now there are dash series of transition element known as dash and dash. Okay, so there are what series of transition? Let me just answer this for you. There are two series of transition elements known as lanthanoid and actinoid. Okay, so we will call it inner transition, not transition. We will call it inner transition element. Okay, right here, inner transition element. So these are the inner transition elements that are lanthanoids and actinoids. Okay guys, understood? Now next you have zinc, cadmium and mercury have a filled d orbitals in the ground state are not considered. Zinc, cadmium and mercury. Zinc, cadmium and mercury, what are they not called? They are under D block but they are not considered under what kind of elements? They are not considered under, very nice. What kind of elements they are not considered under? Everyone in the chat box, everyone. Yes, very good. They are very nice. They are not considered under transition elements. Okay, so what is the answer to that? Everybody, this is directly picked up from your NCERT snips. As you can see, zinc, cadmium and mercury of group 18, zinc, cadmium and mercury of group 18, group 14 have D10 configuration in their ground state as well as their common oxidation state and hence are not regarded as transition. Very, very important question. A very important question that can be asked in the exam. Okay. So guys, next is the electronic configuration of outer orbitals of D block is generally written as this. So now I'm saying except from PD. Again, a very important question. The exceptional configuration of PD. What is the reason behind that? What is the reason behind that? Very nice. The exceptional configuration of PD. What is the reason behind that? Let us see. Okay guys. So here you can see, here also we will find it here. In general, the electronic configuration, everybody, you can also open your chemistry book DNF. I want you to underline all these lines there. Okay, I want you to underline this. Okay, I have specially picked up all these snips for you so that you can actually correlate, right? So here we have in general electronic configuration of outermost, these elements are this much, except for where electronic configuration is 4D10 and 5s0. Okay, understood? This is exceptional. This is exceptional, and wherever in organic chemistry you see exceptions, there is a question. See exception, a question. Okay, questions are always asked from exceptional trends, exceptional electronic configurations, not general. So transition element display a variety of dash. They display a variety of what kind of states? What kind of states they display? Transition element display a variety of what? Oxidation states, right? They show variety of oxidation state. Again, the D block of transition. Okay, so now again guys, so let me pick the line for you. Okay, so in some respects ions are given this configuration, have similar magnetic electronic properties. Okay. Partly filled d orbitals exhibit certain characteristics, properties such as variety of oxidation state first, second is formation of colored compounds, third is entering into complex formation with variety of ligands. You will see in coordination chemistry, you see all the metals are transition metal elements because of the properties, because of their d orbitals, their electronic configuration. They can show variety of oxidation state. They are considered as they are because of dd transition. They show colored compounds. Because of that also they show complex coordination compounds also, right? Okay, next we have the 3D series of transitions start with this and ends with what? The 3D series, Saktiv, Karman, Fico, Nicojan. From there it starts, from where it starts, this starts from the 3D series of transition elements. Starts from which element and end to which element? Everybody in the chat box. Yes, everybody in the chat box. Yes, guys. Everybody in the chat box. It starts from what and ends to what? It starts from scandium and it ends to zinc, right? Saktiv, Karman. Okay, everybody. Saktiv, Karman, Fico, Nicojan. You should always remember this series. Most of the questions that will be asked are from 3D series, right? So next we have in D block, elements are arranged in 4 rows known as 3D, 4D, 5D and what? Very easy, very simple, very easy. They are arranged in what kind of series? 3D, 4D, 5D and 6D, right? Next we have greater similarities. Greater similarities exist within a row or within a dash row of transition element as opposed to dash group. Greater similarities, where you find the similarities opposed to dash group. Opposite to which group? Opposite to which group, guys? Opposite to which group, guys? So greater similarities exist in horizontal rows of the transition element as opposed to vertical. In horizontal, you will see greater similarities as compared to vertical, and also here lengthenoid contraction and actinoid contraction plays a very vital role here, very important role here. So the greater similarities in properties of this of horizontal row in contrast to non-transition elements. Some group similarities also exist. Okay. So everything is mentioned here. Next we have the silver atom has filled d orbitals in its ground state. Silver atom has filled d orbital in its ground state, in its orbitals of dash in its ground state. So what is the electronic configuration of silver atom? Simply, okay, what is the electronic configuration of silver atom? So here it is have 4d10 filled state, right? Okay, just need to do an electronic configuration of these, the exceptional electronic configuration also. Next we have the transition metal. Except for this is a very hard and have low. They are very hard, they are non-transition elements and they have very low what they have low? Very nice, everybody in the chat box. What they have now, this is a very important question. Okay, the transition elements except for this are very hard and they have very low volatility. Okay, they are very less volatile. The transition with this is a very hard and low volatility, exactly from your NCERT, picked exactly from your NCERT. These are, with the exception of this, are very hard and have low volatility. The melting and boiling point are high. Also note this, the melting and boiling point are high, depicts the melting point of transition. Okay, we'll see the melting point again. Okay, we will do question based on melting point itself. Okay, just remember their melting points are high. Okay, so now next we have the high melting point of transition are attributed to the individual involvement of greater number of dash. What is this? From n-1d in addition to the ns electron in the interatomic metallic bonding. Why they have very high melting and boiling point? What is the reason behind that? Very nice. What is the reason behind that, guys? What is the reason behind that? What is the reason behind that? They have very high boiling point, they have very high melting point because of d electrons, right? Because of greater number of electrons into this category. This is very simple. See, the higher melting of this melting attributed to the involvement of greater number of electrons from n-v in addition to ns electron in the interatomic metallic bonding in any row. Melting point of these metals rise to maximum at D5. They have maximum rise to, you will see the graph, maximum will be at half filled configuration for anomalous value of Mn, manganese and Tc and fall regularly as atomic number increases. As atomic number increases, they fall down, okay? As the atomic number will increase, they will fall. At D5 half filled, they will have maximum, okay? The maximum will be at D5, that is half filled. The filling of 4f before 5d results in series of decrease in atomic radii called, very important, very important. This one is very important. Why we have the filling of 4d before 5d? So now what happens here? There is change, there is difference in the atomic radii, right? Hofmann and zirconium have kind of almost similar radii. What is the reason? What is the reason? Everybody, very nice, very nice. Lengthenoid contraction is the right answer. Everybody who have not opened their NCERT book till now, please guys open that. That will really help you. This particular lecture will be, you know, you will be very fruitful for you if you open your NCERT also, because I have mentioned the pages also here. Page number 93. Everyone, page number 93 in new NCERT, open the page number 93. You will see these questions directly. Same as those, okay. So now these phenomena is associated with intervention of 4f orbitals must be before the 5d, and this leads to lengthenoid contraction. This is because of inert pair effect. 4f orbital do not have a very good screening effect, and that is why lengthenoid contraction happens. Okay, so the answer is lengthenoid contraction. Next we have the increase in atomic radii. Everybody in the chat box, very nice, very nice, very nice. Okay. Chapter, yes, I will take, don't worry, okay? But this is also very important for you, because I don't know, after physical chemistry only I will take inorganic chemistry. For inorganic chemistry you need to revise the chapter, okay? Okay, so now let us understand. The increase in atomic radii is greater between 3d and 4d metals than between this and this metals because of lengthenoid contraction. Again, as I told you, 3d and 4d. Then the dash and dash metals, what are they called? What are these metals? Very nice, everyone. I just told you this. I just uttered this. I just told you the answer to this, right? So the answer was 4d and wait, the increase in greater between 3d and this metals than between this is because of lengthenoid contraction. So you will directly write here Hofmann, okay, instead of this, write here this one, okay, write this one here. Because of the lengthenoid contraction, what you observe here, the net result of this is this second and third DCD series, similar to radii, zirconium and hafnium, okay, have very similar physical and chemical properties. These two belongs to different series. Hafnium and zirconium belongs to different series, yet they have similar radii because of these are the consequence of lengthenoid contraction, okay? These are the consequences of lengthenoid contractions, okay? So now let us understand next question. The element with the atomic radii 22, atomic radii 22 is, okay, this is very simple. Atomic radii 22, what is that? Very simple, bacha, very simple, very simple. So the answer here is, I want all of you to answer, very nice. What should be the answer? The element with atomic radii 22, that would be, yes, very nice, that is titanium. Okay, Saktiv Karman Fikanikajan. Next we have the first ionization enthalpy is highest for the element dash among the first series of the transition element. The first ionization enthalpy, we have jumped to ionization enthalpy. Everything, trust me on that. D and F block, if you do that from NCERT, you are going to get full marks, because NCERT is everything. NCERT is God for you. NCERT is everything for you when it comes to inorganic chemistry especially. Do not refer to any reference book. Just do the NCERT. Do the NCERT 3, 4, 5, 6 times, and this is the best method to do the NCERT. Let me tell you what students do. They read the NCERT, but they don't know how the question is going to come from NCERT. The best way to do the NCERT is do the questions from every line, and that is what we are doing here, okay? Our team has specially prepared these NCERT questions line by line for you, so that you can actually understand how the questions are going to come, so that you can recall that you have read NCERT and now you are recalling those NCERT questions, okay? So in this way you will be able to retain more than you retained before, okay? Guys, yes? Perfect. Just like bio NCERT, inorganic NCERT is God for you. Okay, always remember that. The first transition enthalpy is highest for dash element among the first series of transition elements. That is for zinc. So, guys, what I'm going to tell you. So, in NCERT, we usually ignore the tables, right? We see, okay, we don't want to do these tables. What is the benefit of doing these tables? So I am not asking you to learn the values of these tables. You need to do one thing, okay? In every table, you will observe every graph, every table of this chapter. You have to do that. In that, you will see the answer here. The first ionization shall be highest for first ionization shall be, that is this here telling, is highest for dash among the first series of transition. So this is they're saying highest, right? They're saying this is Sakti, Va, Kar, Man, Fi, Ko, Ni, Ku, Jan. Okay, so this is the highest, that is 906. Nobody is going to ask you the values of these. Nobody is going to ask you values, but they are going to ask you which is the highest, which is the minimum. These are the questions that are asked in inorganic chemistry. Highest, minimum, exceptional, all these things are asked. So here are the highest values of zinc. Okay, so zinc is the correct answer. Next, bacha, we have the transition metal, and their compounds are known for their catalytic activity. They use a catalyst also in organic as well as inorganic chemistry. You will see that the catalysts are actually the transition metal elements only. The activity is activated to their ability to adopt multiple dash and to form what? Complexes. So multiple, what they do? They have variety of oxidation states, isn't it? Right? So the answer is oxidation state. And also from this NCERT table, take this important NCERT table, very important NCERT table. Mark this, guys, mark this NCERT table. Here you will see, you will find, they will ask the question like, which have the maximum number of oxidation state. Manganese have the maximum number of oxidation state. So how they shows? These are the most stable states that are shown by a bold letter, a bold digit. Okay, these are the stable states, and here these are stable. Mn is very stable in +2 and +6. It is stable here, it is stable here, it is stable here. Okay, everyone, these kind of questions will be asked. Yes, very nice. Next we have the density tends to increase in 3D of transition metal from titanium to what? Here you have till 29. The density is tending to increase here. Okay, the density is going to increase here from titanium to copper. Okay, from titanium to copper, the density increases in this part. The density clearly increases as atomic number increases. Okay, guys? Yes. Now, next we have, wait, what is happening here? Okay, the density tends to increase. We have done this. Next, we have the highest density among the transition is for the element. Very important question. The highest density. What is the highest density to increase? Tends to increase in, wait. The highest density among the transition element is for the element. The highest density is of, very nice. Osmium is the correct answer. It has the highest density. Very important answer. Very important question. The highest density among this. Okay. Next, bacha. Next we have the maximum and minimum melting point. Maxima and minima of melting point. In physical properties, they will ask you highest, lowest, maxima, minima, exceptional. Everything is going to ask. Okay. So now the maximum and minimum melting point of first transition series, which is, just give me a minute. Just give me a minute. Okay. Otherwise, those notifications will be going to disturb us. So now, the maximum and minimum of melting point of first and second transition series are of this and this respectively. So, which is the maximum and which is the minimum? Everybody, here the maximum is chromium and the minimum is cadmium. How do we find this? Okay, how do we find this? So, you will see this melting point graph here in your NCERT. This graph is drawn. So in the minimum series, they are asking for the first and the second transition. This is the first and this is the second transition series. So here the maximum you will see here, the maximum for first transition series, okay, and minimum for second transition series. The maximum for first transition series, the minimum for second transition series. Guys, just give me a minute. What is happening here? What is happening here? Just give me a minute. Okay, I think now it is perfect, right? So guys, here you will see we have the maximum here, that is chromium, and we have the minimum here. This is the second transition series, this is the second transition series, and here it goes, the last element is cadmium, okay? So here the minimum will be cadmium for second transition series, maximum for first and minimum for second. What is the maximum? From the graph, do let me know what is the maximum for second transition series. What is the maximum? Is there, he's saying, is there something wrong? Okay. Something wrong, nothing. Actually, my WhatsApp was open there, so notifications were pumping up, so that's why I closed it. So don't worry, everything is right, okay? So now tell me the maximum in this second. This is the second series. In the second series, the maximum is molybdenum, right? So this is the maximum melting point here. In the third series, we have maximum of tungsten, right? So these questions can be asked directly from the graph. These questions are asked, right? What is the minimum? Here the minimum will be here, but slightly you will find a drop from molybdenum to TC, then to IU. There will be a drop here. There will be a drop at MN also. There is a drop not here. No drop in the third series. In the second and in the first and second series, you will see a drop at TC and here. Okay, there is a drop here. Increasing, then slightly decreasing, then again starts increasing. Because here you will find the half-filled stable configuration. That is why that is stable and the melting point is low there. Okay. Now next here we have transition elements exhibit higher enthalpies of atomization because of larger number of dash electrons in their atoms. They exhibit higher enthalpy of atomization. What is the reason? Because of large number of what electrons? What electrons? Very easy, very simple. Very important graph. Yes, this graph is very important. All the graphs of D, F and F block are very important, guys. So this is d electrons, unpaired electrons. Because of unpaired electrons, it exhibits that. Next we have in the series from SC to Zn, the enthalpy of atomization is lowest. Now there comes a question, what is the lowest? Which is the lowest enthalpy of atomization? In the first series, what is the lowest enthalpy of atomization? Okay, lowest enthalpy of atomization, this is the enthalpy of atomization. This particular table is in your NCERT. Okay, all the snips are from NCERT only. He will see SCTI Karman Fi Ko Ni Kujan. Now tell me which is the minimum in the series. The enthalpy for atomization is minimum for zinc here. Okay, it is the minimum for zinc here. Okay, which chapter? Bacha, this is DNF block chapter, right? Next we have the increase in ionization enthalpy along with the series of transition element is generally due to increase in. It is generally due to increase in the increase in ionization enthalpy. There is increase in ionization enthalpy along the series of transition element in generally is due to increase in what charge? What kind of charge is getting increased here? Everybody in the chat box. There is increase in nuclear charge, okay? There is increase in ionization enthalpy along each series of transition elements from left to right due to increase in nuclear charge which accomplishes the filling of inner d orbitals, right? Okay guys? Okay beta, everybody in the chat box, is this clear? Now, in the 25th question, the first ionization enthalpy generally, but the magnitude of the first ionization enthalpy they are talking about increase in the second and third enthalpies for the successive elements is much higher along a series. So, what about the first transition enthalpy? In general, the first transition enthalpy. The first transition enthalpy firstly increases, okay, the first ionization enthalpy in general increases but not magnitude of the increase in the second and third enthalpies for the successive elements is much higher as along the series. So what happens here? The first will be, okay, when you're going to firstly extract the electron, that will be a neutral atom, and after that, that will be a negative atom, okay? So sorry, that will be a positive atom, and that will be electron deficient. That is why it generally, but the magnitude of increase in second and the third ionization enthalpy of successive elements is much higher along the series. Along the series, that will be much higher because of the electrons there. Okay, electrons are getting added. So extracting the electron from second and third transition series will be tougher. Okay, yes. Next we have the dash ionization enthalpy of manganese is lower and the chromium than chromium, because manganese has this configuration and chromium has this configuration. Okay, so now they are saying the ionization enthalpy of what? The dash ionization enthalpy, first, second, third. Which ionization enthalpy of manganese is lower? Which first, second or third? Which ionization enthalpy will be lower? Everybody in the chat box, which ionization enthalpy of manganese will be lower than chromium, because manganese has this configuration and chromium has this configuration? Tell me, everybody. Yes, very nice, very nice. Second ionization enthalpy will be lower. Let us see the answer here. Okay, so guys, this is manganese has this configuration, I mean positive has this configuration, and chromium has D5 configuration. Therefore ionization enthalpy, here you can see we can easily extract one electron from here, okay, but for chromium we cannot extract. Already it is just 3d5 here, it is just 3d5 here. It will be 3d5 and 4s1 here. So here we can extract one electron easily, and here this will be very difficult because extracting the electron from a stable configuration is very difficult, right? From a stable configuration is very difficult. Okay, as you can see, I'm not able to handle the dupatta. I'm not able to handle the dupatta. Okay, I need to learn this. Yes, I really need to learn this. You can see in all the class, I'm just, setting my dupatta. Notice that, is it? So next we have lower common oxidation state of the transition metal. The lowest oxidation state, the lowest common oxidation state. Okay, the lowest common oxidation state. The lowest common oxidation state of these elements are +2. They have the lowest oxidation state, which is the most common oxidation state among them is +2 oxidation state, right? For this ions from gaseous atom, okay, right? Next we have the sum of first and second ionization enthalpy is required. The sum of first and second ionization is required in the addition of enthalpy of atomization. It's very important point that first and second ionization enthalpy are required here to form dash ions from the gaseous ions. From the gases, what kind of ions are formed here, right? What kind of ions are formed here? Very good, very good. Yes. Yes, everyone. Yes, I'll definitely come. Okay. So now you have M2 positive, right? M2 positive, obviously you will extract 2 electrons and you will form M2 positive here, right? Very simple. The second ionization enthalpy value for zinc is corresponding to dash, and the ionization causes the removal of 4s electron, which results in the formation of D10 configuration. So now what is saying, the second ionization enthalpy for Zn is correspondingly dash as the ionization, low, high, what? Tell me, firstly, what is the configuration? Then second configuration means extract 2 electrons, okay, 2 electrons from the zinc electronic configuration. Very nice. That will be low, right? How come that will be low? How come that will be low? Yes, very nice, very nice. So that will be low because already the configuration here will be, we will extract 2 electrons from there. Okay, that will become sorry, the second ionization enthalpy. Okay, so now I'll just draw the values here. Okay, I'll just draw the values here. I just draw the values here so that you can understand how we do these things. It's a very simple concept here. I'll just let you know what is the Sakti Kar. In all the question we will apply this concept. Okay, in all the question we are going to apply this Kar, Man, Fi, confusion. Okay, this is 21, 22, 23, 24, 25, 26, 27, 28, okay, where is V? Okay, this is T, 21, 22, 23, and this is 4, 5, 6, 7, 8, 9, and this is 30. Right, so what we are going to do here for the zinc configuration, right? Argon 18, then we have 4s, then we have 3d, okay, then we have 4s or we have 3d, or you can also write it as like this. So this is 3d, then we have 4s. For 3d, just here 10 electrons here, okay, 10 electrons here, we have 30, so it will be 28, and 2 electrons here. For Zn2 positive, for Zn1 positive, this is the first ionization enthalpy, right? So that will be argon, and this will be 3d 10, and this will be 4s1. So now why second ionization is very low? Because extracting the electrons from 4s1 is very easy, right? So that will be, so now second ionization enthalpy will be very low. So you don't need to remember this, remember the ionization enthalpies here, just simply draw the do the electronic configuration, and after that extract 1 electrons, 2 electrons, and see if it is stable. Now the third electronic third ionization enthalpy will be very high because of this stable electronic configuration, right? Okay, so now we have the third ionization is quite high for this and this due to stability of their half and fully filled d orbitals. So which we have third ionization enthalpy is very high. For what? We have Mn2 positive and Zn2 positive. What is the reason behind that? Mn means 25, so here we have argon 18. This we have argon 18, Mn means 25, that is argon 18, 4s. Let us write 3d 5, and this is 4s2, right? We have 25 here. So for Mn positive, that will be 3d 5 and 4s1. This is the first, okay, and second will also be very low because of 3d 5. Easily it can it can lose 1 electron. So now after the third ionization enthalpy, that means this is the third ionization enthalpy. Now extracting the electron from d, half filled d orbital, is very difficult, so that will be very high because of this and this. Okay, understood this? Yes, everyone understood this? Yes, now we have 3D transition metal exhibits largest number of oxidation states. Okay, so 3D transition exhibits largest number of oxidation state is that exhibits largest sizes. Did this question in front of you from that table? The answer here is manganese exhibit the largest number of oxidation state. As you can see, these are the largest number of oxidation state from +2 to +7, out of which +2 and +7 are the most stable oxidation states. Okay, right? Everybody, next we have in group 6, molybdenum and tungsten are found to be the most stable than chromium 6, and thus chromium 6 is in the form of dash is more stable. Okay, in the group 6 they are talking about molybdenum and tungsten are found to be more stable than chromium 6. Okay, chromium 6, they are more stable, is in the form of what is in the form? Okay, they are more stable, so that is why it is in the form of dichromate. Okay, is more stable. Let us see this, let us see. Okay, so let us see this question from this particular statement here. Okay, let us start this question from, okay. So in group 6, we have molybdenum and tungsten are found to be more stable than chromium. Thus, chromium is in the form of dichromate in acidic medium. Okay, here to write in acidic medium is a strong oxidizing agent, whereas are not. Okay, so now what they have written, a very important statement, that molybdenum and this 6, okay, this is MO and 6, that means +6 state, and this in +6 state. Okay, so I'll just split it down for you. We have molybdenum this, here the molybdenum +6 will be here, and here we will have tungsten +6. So now they are saying molybdenum and these are not stable. That is the reason we don't find these two elements. We don't find molybdenum O3, we don't find tungsten O3. WO3 and molybdenum O3 is not found because these are not stable. These are not the stable electronic configuration states, right? But chromium 6 is very stable, that is why CrO3 is found, okay, that is why it exists in the form of dichromate, okay, that is why it exists in the form of dichromate. Understood everyone? Why it can exist in the form of dichromate? Because of the oxidation states here. Low oxidation states are found when complex compounds are ligands capable of pi acceptor character in addition to sigma bonding, for example in dash and dash. Low oxidation states are found, let us see the answer here. Nickel and iron, low oxidation states are found when the complex has ligand capable of pi acceptance character in addition to sigma acceptance. For example, nickel compound and iron compound, oxidation state of this and this is 0. Okay, so low oxidation state compounds are more stable here, right? Okay, everyone in the chat box, I cannot see your energy. Where is everyone? What happened to you guys? What happened? Okay, so now, are you not enjoying the session? I feel that you are not enjoying the session. Is this the case? Is this the case? You're not enjoying the session? Everybody in the chat box, do let me know if you're not enjoying the session, why the energy is so low? What happened, guys? It's just 1 or 2 guys who are typing here. Where are the rest of students? I can see no energy here. Today is Republic Day, even now there is no energy. What happened to you guys? Okay? Enjoying, ma'am? Okay. So there's just few students who are typing it here. What happened to you? This decreases so easily. Oh my god, the chats is getting decreased here. Okay, so now let us see the 3D transition elements with greatest number of stable oxidation state exhibit all oxidation state from +2. The 3D transition with the greatest number of oxidation state are shown by what? They are shown by very nice. Yes, I'm suddenly lost energy. What happened? I don't know what happened to these people. What happened to you guys? What happened to you? Suddenly I see there is a drop of energy in you. Okay, what happened? So this is for manganese from +2 to +7. Okay, so here we have the oxidation state that is +2 to +7. That is for manganese. That shows highest number of oxidation state. Answer will be on the page number 97. Everybody open your page number 97 here. Next, guys, we have ionization enthalpy of Fe2 positive is lower than Mn2 positive because this has Fe2 positive has what kind of configuration? Fe2 positive has what kind of configuration? Everybody. Yes, everyone. Yes. Ionization enthalpy of this is lower than Mn2 positive. Again, just simply draw the electronic configuration. Then see the Fe2 positive, the third ionization energy here. Okay, and you will see this has dash configuration. What kind of configuration it will have? 3D6 configuration. So Tiv Karman Phi. Phi is 26. Okay, 26. Here the electronic configuration you can see here. The electronic configuration will be for 26 will be argon 18. Then we will have 3d6 and 4s2. Right, for third we will have, it will lose for 2 electrons. This is Fe2 positive, this is Fe2 positive, and for Fe2 positive it is going to lose an electron here. This is 3d6, and after losing 1 electron it will become 3d5. That is more stable. So that is why the enthalpy is very low because of 3d6 electronic configuration, where it can lose 1 electron and easily get converted to half filled d orbital configuration. Right, again we have the variety of oxidation state of transition elements is due to incomplete filling of orbital in such a way that their oxidation state differ from each other by unity. The variety of oxidation, why there is variety, you can see the manganese showing +2, +3, +4, +5, +6, +7. So +6, +7, there's just difference of 1 unity. What is the reason behind that? Because of the orbitals, okay, because of the filling of d orbitals. You will see in no other group, you will see no other block you will see. In S block you will not see, in P block you will not see. Here you will see there is only just one difference, that is plus 2 plus 3. Unity difference is there. While converting, there is plus 2, there is plus 3, there is plus 4, there is plus 5, plus 6, plus 7. By the difference of just one unity, right? Next we have very important, titanium is more stable than titanium. Very, 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 very important question. Titanium 4 is more stable than titanium 2 and titanium 3 because it has less electron involved in oxidation state. How many electrons involved in the oxidation state? Let us find this out. Okay, guys, everyone here. Okay, so here we have early in the series scandium is virtually unknown and titanium 4 is more stable. Titanium 4 is more stable than this and this. At the other hand, only oxidation state of zinc is plus 2. So all the oxidation states are, guys, here mentioned here. Okay, okay, all the oxidation states are mentioned here. All the oxidation states are mentioned here. So titanium 4 is more stable than titanium 2 or 3 because it has no d electrons involved in the oxidation state. So T is 22, right? T is 22. This is argon 18. Then we have 3d 0 4s1. This one, no d electrons here. That is why this one is more stable. That is why titanium 4 is more stable than titanium 2 or titanium 3. Okay, guys, understood this? Yes? Okay, perfect. This 20, wait, this will be 20, 18, this will be 2, and then there will be 2 electrons here also. This is 21, P, 22 only, and there will be this one. Okay, for titanium 2 positive, you will have 3d2, and for titanium 3 positive you will have 3d1, and for titanium 4 positive you will have 3d0, and that is why it is more stable. Okay, understood, guys? 0, no electrons or 5 electrons in d orbitals or 10 electrons in the d orbital, that are more stable. So you will have no orbitals, no electrons in the 3d orbitals here. Next we have transition metal exhibit higher enthalpy of atomization because of larger number of what electrons. Again, repeated question. What is the repeated question? No bacha, no birthday. Here is Happy Republic Day. It's not my birthday. It's the birthday of our constitution, right? Okay, so transition exhibit higher enthalpy of this because of unpaired electron here. The unique behavior of copper having positive, very, 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 very important. Why we copper have positive value of E0? What is the reason behind that? Accounts for instability of this to form acids. Instability of what? If it is negative, it has a negative E0, then it will react with acids to form, right? But now it has a positive E0, so it will not react with acid to liberate H2. Okay? Because with acid it will liberate H2, but the reason it is not reacting with acid is because it has positive E0. Okay, E0 is less than the hydrogen. Okay, it should be greater. So now here you will see copper. This is the copper. This is the E0 of copper. It is positive. Otherwise, every element here has a negative E0. Everybody here has negative. Only copper has positive E0 here. So now next is the E0 for manganese, nickel, zinc are more negative than expected from the trend. Stability or half-filled D shell is Mn2 positive. The completely filled D10 configuration in this are related to their values, where E0 for nickel is related to the highest negative. Again, a very important question. The value of E0 for this are more negative. They are more negative, right? As expected. Now the stability of half-filled, because of the stability of half-filled, right? D in the manganese to positive and the completely filled this configuration are related to the E0 values, where E0 for nickel is related to the highest negative. What is the reason? Highest negative. Very nice. What is the reason behind that? Why it is related to enthalpy of hydration. Okay, enthalpy of hydration. Again, take this important question, very, very important, enthalpy of hydration. We have 3 compounds, that is manganese, nickel, zinc. Half-filled, 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 completely filled, and this is enthalpy of hydration. Okay, understood? they have exceptional negative value. Copper has exceptional positive value, right? The low value of M for this for scandium reflects the instability of Sc3 positive, which has this configuration. So you will just write the configuration of Sc3 positive, right? Just draw the electronic configuration of Sc3 positive, right? So that is the reason the value is very low. Okay, the value is very low because it's a noble gas configuration. It requires a noble gas configuration. For scandium, it is 21. You have argon 18. Then we have 3D and we have 4s2 and this is 1, right? For Sc3 positive, you have just a argon 18, right? 2 electrons from here and 1 electron from here will go, right? You will have just this 3D will be 0 and this 4s will be 0. Now this is a argon electronic configuration, that means noble gas configuration. That is why it is very low value of Mn3 positive to Mn2 positive. Okay, very low value because it wants to attain that noble gas configuration. Everybody wants to be stable in this universe, right? So are they wants to be stable also. That is why they want to get into a Sc3 positive. Scandium wants to adapt to +3 electronic configuration. That is why the electron potential is very low, right? So the ion for Ti2 positive, titanium, vanadium and chromium are strong reducing agents will be liberate. This is this. Now this is very simple. What it will liberate? What is it going to liberate? What it is going to liberate, bacha? Everybody in the chat box, what it is going to liberate, because it's a very strong value, so it will react with acid and will liberate hydrogen gas here. Okay, it will liberate hydrogen gas. Perfect. Next we have according to spin only formula to calculate the dipole moment. The magnitude moment for this is determined number of dash electrons. Very simple question. Very simple question. Everybody in the chat box, everybody. What is attributed here for calculating spin only formula to calculating the dipole moment? What we see there? We see the unpaired electrons. Very nice. We see the unpaired electrons. Perfect. Very nice. Next we have a single unpaired electron has magnetic moment. What is the single unpaired electron? Just apply that formula. Under root n plus 2. What is the formula? By applying that formula, under root n plus 2, the formula is we have 1 electron, then 3. It will be under root 3, right? Okay, under root 3 is 1.7. Under root 3 is 1.7 bm. Okay? Perfect. Now, the copper 2 halides are known except the iodine as copper 2 positive oxidizes. Very important question. Bacha. Very important question. Now we are going to do the question based on reactions of DNF block, and these are very important. Trends are being asked and these reactions are also being asked. Okay, in NEET examination, especially they ask these questions. Okay, so now the copper 2 positive halides are known except iodine as this oxidizes what to what it oxidizes. Everybody in the chat box, it oxidizes I negative to I2. Okay, it oxidizes I negative to I2. So on the other hand, Cu halides are known except the iodides. In this case, copper 2 positive oxidizes I negative. Very important reaction. And also copper positive undergo disproportionation reaction, also very important to Cu2 positive and Cu. Okay guys, everybody. Very nice. Okay guys, now we have the stability of copper 2 positive rather than Cu positive is due to too much negative value of Cu2 positive than this, but are more components compensates for the second ionization. Just do this thing. Okay, for copper, what is the electronic configuration? By that you are going to know the answer here. I'm going to tie the dupatta now. Okay, I'm going to tie the dupatta and teach you. Okay, so now the stability of copper 2 positive rather than so let us understand this. For copper we have Saktiv, Kar, Man, Fi, Ko, Ni, Ku. Okay, so that is 28. Ni, Ku, Jan. That is 29. Okay, what I am writing it here. Okay, that is argon 18. Just draw the electronic, just write the electronic configuration here. This is 4s, this is 3d. For this 2 electrons here, and then you will have 18 plus 2, 20, and you will have 9 here. For the exception here, write it 10 here and 1 here. This is the electronic configuration for copper. The stability of this rather than this. Okay, so firstly, eliminate 1 electron from here. Here we'll have argon 18, 3d, 10. And for Cu2 positive, you will have, for Cu2 positive, argon 18, 3d, 9. Wait, the stability of copper 2 positive rather than this is due to the much more negative dash of copper than Cu, which is more compensates for the second ionization enthalpy. Okay, so now here you will see this exception here, very important, that in this case copper positive, when it lose 1 electron, it is going into the more stable D10 configuration. Then why this is not more stable? Why this is more stable? As you can see from the disproportionation reaction, that this Cu2 positive, this copper is unstable, okay? This is unstable. That is why it is disproportionating into Cu2 positive. That means Cu positive is more stable. The answer lies in the E naught values, okay? The answer lies in the E naught values of, that is the reason here you can see this, okay? So it disproportionate into this, and this, the stability of this rather than this is due to much more negative hydration values that leads to the positive value of E naught, right? Of copper to positive rather than this, which is more than compensates for the second ionization enthalpy. Here you will see converting Cu positive to Cu2 positive is difficult task, but the hydration enthalpy is very low, and that also makes the E naught value positive there. And that is the reason here you will see this exception here. This should be less stable and this should be more stable, but because of hydration enthalpy, this is more stable as compared to this, and that is why Cu2 positive disproportionate into Cu positive disproportionate into Cu2 positive and copper, right? Okay guys? Okay guys, everybody, very nice, very nice. Okay, so next we have the values for transition are related to ability of from divalent cations with higher values indicating a dash in density to do so. Okay, so let us see the answer here only, because the question is framed in a different way. So the E naught values for transition metal are related to ability to form divalent cations, right? With higher values indicating a dash in density to do so, lower tendency. What you will see, lower tendency to form, lower tendency to do so. So E naught, that is converting this M to M2 positive, converting this to this, losing 2 electrons, for this are related to the ability to form divalent cations. Okay, so with higher values, that means they don't want to getting convert into the more positive value, less is the tendency, okay? So that is what is written in this whole paragraph. As you will see, the E naught values of this indicate decreasing tendency to form divalent cations across the series. This general trend towards less negative E naught values is related to the increase in sum of first and second transition enthalpy. Okay, so everything here is written according to this question. Now next you have the E naught values of vanadium. This is related to the stability of half filled D level. Again, write the electronic configuration and then form that is this stable or not stable. What is the electronic configuration? Saktiva, that is 23, argon 18. After that argon 18, it will be 3D and this will be 4s, this will be 2, this is 1. Okay, then for 2, this will be having this 1 electron will be extracted from this one. This will be 3D 1 and then 4s 0 for 2 positive. So yeah, 3D positive is also possible. Okay? Vanadium 3 positive is also possible and is stable, right? Vanadium 3 positive will also be stable. The E naught value for this is related to the stability of the half filled D level. Okay, vanadium 2 positive, as you can see, vanadium 2 positive will have the value. Wait. This will have the value argon 18. So we'll have 4s and 3D. 2 here, 1 here. This will have the value, this one, right? Okay. I think something wrong is written here. Okay, just skip that question. Okay, just skip that question. Just skip that question. Next is the ability of fluorine. The ability of fluorine to stabilize the highest oxidation state is exemplified by the compounds such as. Okay, so fluorine ability to stabilize highest oxidation state. What are the compounds that are formed by fluorine? The compounds are VF5 and CrF6. These are the two more very important compounds of fluorine. Okay, so that exhibits to the higher oxidation state. So you will say the +7 oxidation state, how this is formed by higher oxidation state. This also shows higher oxidation state. Okay, this is +5, this is in +6 oxidation state. That means they are stable in the highest oxidation state, right? Okay, next the color observed in the transition element corresponds to dash color of the light absorbed. The color observed in the transition element, but what is the reason? Because of the DD transitions, right? Okay, so the answer is complementary color of the light absorbed. The light absorbed, the complementary color will be observed there. Okay. Okay guys, so next we have completed 50 questions here. We are left with the 50 questions. Okay, the next 50 questions are going to be very important because they are from dichromate, potassium dichromate, potassium permanganate. So these are going to be very important, and lanthanoid and actinoid contraction. Before that, I just want to let you know that we have launched mock test series, and these mock test series are totally free of cost. You will get full length 5 full length tests, 5 part syllabus test, and the total we will have 10 mock tests, and the schedule will be every Sunday 2 p.m. to 5:30. Okay, 2 p.m. to 5:30 p.m. Yes, 2 p.m. to 5:30 p.m. The schedule is 2 p.m. to 5:30 p.m. and they are based on the latest syllabus expected difficulty level. And bacha, how you will enroll to this? Just very simple step, very simple step. What you will do here? Just go to this and then just scroll here. Here you will see Victory Mock Test Series. Click on this series and you will see enroll now. How much rupees? Cut 99.999 is cut here, and with 100% off you have 0 rupees. For 0 rupees you just need to enroll here. Okay, just enroll here and fill your Google ID or mobile number here. You will get enrolled there. And if you find any difficulty in enrolling, this is valid till today 12 p.m. So after this class, just enroll here. If you find any difficulty, then just mail on the email. Mail is vcare@vedantu. Okay, I'll also send you the mail in the Telegram channel, right? Okay, so just mail there and enroll to the mock test session. Okay guys, very simple. Click on buy now, then email ID details and proceed to pay. You will not have to pay anything here. Just proceed to pay and click there and you will be enrolled there. Okay. Next we have, and this is valid today only. This is valid today. Today till 12 p.m. till 11:59 p.m. to be accurate, till 11:59 p.m. Transition metals such as vanadium oxide in the contact process. Now these are, we are talking about the catalytic properties, and nickel in the catalytic is known for their dash properties. I just answered this. Okay, I just answered this. Very nice. This is because of what? Because of the catalytic properties. Okay, because of the catalytic properties. All the catalysts shown here, all the catalysts shown in this here, vanadium, about the Haber's process, right? Hydrogenation, which catalysts are used where. All these things are important for you. Everything about the catalyst, which catalyst is used in which process, contact process, Haber's process, hydrogenation. Everything is important for you, right? Interstitial compounds formed by transition metals have high melting points and are very hard and sometimes approaching dash in the hardness. The interstitial compounds, about the, like you have a lattice, you are in the interstitial positions. You have this lattice. Okay, this is the lattice. So these are the interstitial positions. These voids are the interstitial positions. So interstitial compounds formed by transition metals have high melting points, very hard and sometimes approaching to almost diamond in the hardness. Diamond is the most hardest substance. So why interstitial compounds are formed by transition metal elements? Firstly, they are formed because to enhance the properties of such compounds. Okay, to enhance the properties. Next is alloys are blends of, guys, don't spam here. Don't spam here. Okay, don't spam here. Okay guys, yes, don't spam here because they are what's the benefit of spamming? No, if you're asking some question 10-20 times, I'm going to answer this. Don't worry, when I'll see the chat, I'm not seeing the chat right now. I'm just concerned about the answers that you are giving right now. Just give the answers, don't spam here. Okay, alloys are blends of metals in which the components are mixed at atomic level. Okay, the components are mixed at atomic level by melting, right, often resulting in materials that are hard and will have dash melting point. Why alloys are formed? Very simple. Why alloys are formed? Because of, do we want to make it a high melting point? The melting point of alloys are very high. The properties of individual elements are in that alloys, and that is very beneficial, right? So you'll see all the different alloys of transition states here, right? Okay. Next, the disproportionation of oxidation state when it becomes less stable relative to the other oxidation state, as in case of manganese. You will see that in case of copper also becomes becomes manganese 4 and manganese 7. This is 5, 6, 7 and this is 4, right, in the solution. Okay, so now they are saying where the reaction where manganese 6, this is plus 6. Okay, so they are saying the plus 6 oxidation state, this is very unstable, so it will get converted into plus 7 and plus 4 oxidation state, as these two oxidation states are more stable. Okay, so now this is the question from your NCERT itself. You will see what do you mean by disproportionation of oxidation state. Give an example. So this is a disproportionation. You will see this is manganese plus 4. No, this is plus 6. Okay, this is manganese plus 6. It gets disproportionate in the acidic medium. 2, this is plus 7. This is plus 7 oxidation state, and this is plus 4 oxidation state. Why? Because this is unstable. This is more stable. That is why it gets disproportionated. Right? Okay. Oxides and oxygen ions, very important, of transition are typically formed by the reaction of metals dash with at high temperature. Okay, so how they are formed, how the oxo acids or oxides are formed by transition metal element, by simply reacting it with oxygen. Okay, by simply reacting it with oxygen, you will have the topic name is 4.41 oxides and oxygen ions of metals. Okay, direct question are being asked from these topics. Direct, they will ask the reaction here, or they will simply ask the compound formation here. Okay, every single line I'm telling you, you can't skip even a single line of DNF block. Okay, oxides beyond group 7 like those of iron above this are not known because why they are saying oxides beyond group 7 like those of FeO3 are not known because the oxidation states of these elements exceeds their group number. So why these oxides beyond group 7 like those of Fe, why they are not seen? Why? What is the reason behind that? Everybody in the chat box, what is the reason? What is the reason oxides beyond group 7 are not seen? The reason here is because the highest oxidation state of these elements exceeds their group number as well. As you can see, group 7, the highest oxide number are known beside this and this oxide. I'm just let me tell you the examples here with the examples. The oxocation stabilizes, this is vanadium, right? And the oxide formation here is this. And for vanadium 4, we have the oxide formation VO 2 positive, and for titanium 4 we have the oxide here, this one. Okay, okay guys. Next we have sodium dichromate is more soluble than potassium dichromate and is used in volumetric analysis as a primary standard due to the strong dash properties. What are the properties? Why it is? Okay, ma'am, I mailed you at your mail ID. Guys, you don't need to mail me. If you find any difficulty in this, in enrolling to the test, mail at Vedantu's official ID. That is bcare@vedantu.com. Okay. Okay. So sodium dichromate is more soluble than potassium dichromate and is used in volumetric analysis as primary standard due to its strong oxidizing properties. So this is sodium dichromate, it oxidizes and get converted into, it oxidizes this into this, right? So it oxidizes into potassium dichromate. Is more soluble than potassium dichromate. The latter is therefore prepared by treating solution of sodium dichromate with potassium chloride. Okay. Understood? In the acidic solution, again, these are reaction based question. Potassium and dichromate represented as this and is known for oxidizing agent that can represent the half reaction. So this is basically the oxidation of CrO3 in acidic medium. These you also do these kind of reactions in redox reactions as well. Okay, in redox reaction as well, we do these kind of questions. Okay, yes, so what will be the answer? Acidic medium, they are saying potassium dichromate represented by this is known for oxidizing action that can be represented by half reaction. What is this called? What is the reaction? What will be formed here? Okay, what will be formed here? Will form here Cr3 positive. Just see the reaction here. Just see the reaction. Also note down the E0 value is 1.33 here. Okay, understood? That means the reaction can easily occur. Next, we have potassium permanganate is prepared by fusion of MnO2 with alkali metal hydroxide and oxidizing agents like what? What the formation of, they are saying the preparation of potassium permanganate. For that you need to the preparation reactions of potassium permanganate, right? The potassium permanganate reactions, let us see that. The potassium permanganate reaction, you have MnO2 with KOH, that is alkali metal hydroxide with O2, it gives K2. Still now there is no potassium permanganate, K2MnO4, right? After that, reacting in acidic medium, it gives potassium permanganate. After that, okay, potassium permanganate is prepared by fusion of MnO2 with alkali, this oxidizing agent like this, right, which is giving the oxygen here, that produces the dark green color. Okay, this can also be asked, which is the color of K2MnO4, right, which disproportionate into neutral and acidic solution to give permanganate solution here. Very, very important reaction, very, very important reaction for the preparation of potassium permanganate, for preparation of potassium dichromate. The oxidizing properties of these two, the reaction involved in these two, the basic medium, acidic medium, neutral medium, all the reactions are very important, right? The chromate ion is tetrahedral, where the dichromate ion is this, consists of two tetrahedrals sharing one corner with this bond angle of, bond angle you need to do. Okay, so simply these are the two structures, the dichromate ion and this is the chromate ion. Here the angle is 126 degree, so I have written it 126 degree. Okay, simply these are the structures only. In the presence of sulfuric acid, orange crystals of potassium dichromate can be crystallized from the solutions of potassium we have potassium dichromate. The presence of sulfuric acid, what happens to these orange crystals? In the acidic medium, what happens to these crystals? What happens, guys? What happens? So these in the so we have acidic medium here. Wait. This is the acidic medium. Okay, so in acidic medium, the yellow solution of sodium dichromate is filtered and acidified with sulfuric acid to give solution to form orange. So, okay, let us start the reaction. Okay, we are talking about the potassium dichromate, right? So, firstly, the potassium dichromate will get converted into sodium dichromate. After that, there will be reaction here. Okay, after that. So, now in the presence of this, this is this. Okay. Just simple, this reaction, the potassium dichromate, this is not mentioned here. Here we have not written that reaction. These are the further reactions. That put sodium dichromate, what happens to sodium dichromate, right? But this, in the presence of sulfuric acid, the crystals of potassium dichromate get converted into sodium dichromate, and after that also the reaction is occurring. Okay, after that this sodium dichromates get converted into, this is Na2. This is dichromate, yellow solution of this. So these reactions, no. These are not the reactions that we are going to cover here. Okay, these are not the reactions. So just, these are not the reactions that are related to this one. Okay, these reactions are different and this is different. Though this is also important for you, but these are not related. This is the before step of these reactions. Okay. Next we have, when discussing the oxidation state of transition, it is noted that manganese exhibit all the oxidation state from +2 to, while the lower number of oxidation states seen in the element slide. Okay, the lower oxidation state, manganese exhibit all the oxidation state, the lower oxidation state will be seen in the elements like scandium. Okay, lower oxidation state that are more stable in that case, that are more stable. In this manner, just simply do the tabular form of the oxidation states mentioned in your NCERT. The transition metals from large number of complex compounds is due to comparatively sizes of metal ions, their ionic charges and availability of d orbitals for bond formation. Everybody, the transition metal form a large number of complex compounds. Okay, this is due to comparatively what sizes? Comparatively, everybody, yes, very nice. This is due to very comparatively smaller sizes of metal. Smaller sizes of metal, that is why they form large number of complexes, and their dash charges and the availability of d electron for bond formation. By they form so because of their higher charges. Okay, because of their higher charges. And this is important that because of their smaller sizes, right, they get fit into the complex formation. The transition and the compounds are known for the catalytic activity. Why they are known for their catalytic property? What is the reason behind that? Everybody, what is the reason behind that? What is the reason? Because of the variable oxidation state. They show complex form, they show catalytic properties. So everything, why they are alloys, why they show interstitial compounds, why they show catalytic property, why they show different oxidation state. You need to find the reason behind everything. What is the lowest, what is the highest, which shows the maximum number of oxidation state. Everything here. Okay, done. So now the most stable oxidation state of lanthanoids is the +3, which arises from extra stability of empty, half-filled or filled subshells. Now, bacha, everybody, ma'am, large surface area is also reason for catalytic properties, right? Yes, bacha, yes. So, large surface area is also another reason, right? All the reason you need to know. Okay, if you have options there, don't focus on surface area then. Okay, according to the option, you have to give the answer. The most stable oxidation state of all the lanthanoids in +3, which arises from extra stability of empty, half-filled or filled F subshells. Okay, next we have the decrease in atomic or ionic radii for lanthanum to lutetium is known as. There is decrease. What is the reason behind that decrease? Everybody, why ma'am you are not responding to question? Where are your questions, bacha? Where are your questions? Right? Able to see after ma'am and live. Yes, exactly, Gopika ma'am. Right. So I am currently teaching, no? So that is why it's very difficult to see your answer only. It's very far away. So I'm just saying who all are answering here. So I'm just seeing that. So do answer. After that, after the completion of this, I'll ask you if there is any doubt. You can just you can talk to me after that. Okay, what is the reason? The reason here is lanthanoid contraction, consequence of lanthanoid contraction. Due to lanthanoid contraction, the radii of members of third transition series tend to be very similar to those of corresponding members of the dash series. Third to which series? The consequences of lanthanoid contractions are here. Okay, the consequences of lanthanoid contraction. So here that will be the third to the first to the second series. Okay, that is 3D and 4D and another series. In the they can also ask you why you have similar radii of hafnium, zirconium, all the elements there. In the lanthanoid from La to Ln, this is actually not a part of lanthanoid series. That is why they have written like this. Are predominant. However, occasionally +2 and +4 ions in the solution or solid compounds are also obtained due to extra stability of. Now everyone in the chat box, with electrons adding to F shell, very nice. Yes, we are ruled. They forget that, okay, I have also specs. I can't see from this much distance. What are you typing? Only thing I can see, we're typing lanthanoid contraction. And ma'am, you're looking very good. Thank you so much. Right? So, you need to answer me for me to answer you. So, we have in the lanthanoids, so this is the table. This is a table for lanthanoid contraction, for the lanthanoids electronic configuration. Just see this table from here. You just need to do few things. That is, for cerium, you will see for cerium 4 positive. This is 4 positive. This is 3 positive. This is 2 positive. For cerium in 4 positive state, you have 0 electrons in F. That means this is very stable. So cerium in 4 will be very stable. Then we have, this is 1, this is 2. Then we have this terbium. Terbium in +4 state will also be very stable. Okay, terbium in +4 state, terbium and cerium will be very stable. So let us find out in +2 states which will be stable. So here stability will be, okay, here europium will be very stable, right, because of this. And then you have, these are very important question. You don't need to remember all the electronic configuration. Just remember the stable electronic configuration in +2 and +4 state. And plus is the most common oxidation state here, right? So here ytterbium is the compound that is having fully filled electronic configuration in this case. So for +2, these two elements will have very stable +2 oxidation state, and these two elements will have very stable +4 oxidation state. Cerium and terbium will have +2, and europium and ytterbium will have +2 oxidation state. That will be very, very stable. And the question are being asked from these two things. What about the stability of +2 and +4 oxidation states? Okay. So now next we have cerium. Cerium can exhibit +4. Again, see that question is here. Cerium can exhibit +4 oxidation state like this by, so what is the reason? Because it attains stable electronic configuration. Okay, so it attains noble state or stable electronic configuration in this. Okay guys, now next we have the earlier member of lanthanoid series are quite reactive, similar to calcium, but with increase in atomic number they behave more like what they behave like. Everybody in the chat box, what they behave like, the higher members, what the increase in atomic number, they more behave like, which is the element? This element is from P block. This is the element. Yes, everyone. Element is aluminium. In the chemical behavior in general, they behave like calcium, but with increasing this, they more behave like aluminium. Okay, so that is why they show 3 positive oxidation state as a increase in atomic number. Many trivalent lanthanoids ion are colored but with solid state in aqueous solution due to presence of what electrons. There we had DD transitions. Here we have what kind of transitions? The transitions here we have F transitions, right? Okay. Next we have the best single use of lanthanoids is for production of alloy steels for dash and dash, for pipes and what? For pipes and plates, right? A well-known alloy is very important. A well-known alloy, mixture metal, which is used in magnesium main alloys, carbon electrodes consist of about 95% of what? Very important question. A very, very important question. Answer this. A very important question. Here it contains lanthanoid metal. Okay, it contains lanthanoid metal. This is the alloy. You need to remember the name of that alloy. Also the percentage of metals, right? The percentage and the name of that alloy. Next we have mixed oxides of lanthanoids are employed as catalysts in petroleum cracking, and some individual lanthanoid oxides are being used as dash in the television screens. What they are being used, these are under the application of lanthanoids. Okay, under the applications, under the very nice. Yes, very nice. So here is phosphorus in television, right? Okay, perfect. Then we have next that we have lanthanoids react dash to form LNX3. So this is the chart of NCERT that you need to remember. Most of the answers will be from this chart, like from with acid it's liberate H2, with halogen it has LNX3 because it has +3, this is +2. With this it has OH and it has -1, this has +3, so it will just cross valency will be here, right? Again, this is important, this is little bit different, right? This is also different, right? and then this is also different. This is actually the same. This is actually the same. With sulfur, it has Ln2s3. With this is at Ln2O3. With the nitrogen, it has Ln, and with carbon, it has Ln this. These two are very important. With carbon and with nitrogen. Okay, with carbon and with nitrogen. Let us do with halogens. It will react to form Lnx3, where X is halogen. Okay. The lanthanoid metal combines with hydrogen when gently heated in the gas. Okay, so what they are saying, the lanthanoid metal combined with hydrogen when gently heated in the gas, the carbides, these are formed when the metals are heated with this. They liberate dash to form dilute acids. With dilute acids, what they form? We just did the chart here. With dilute acid, it gives hydrogen, and this with carbon, it liberates this. Okay, with carbon, it liberates the LnC2, Ln2C3. Okay, all these compounds, and with acid, it liberates H2. Okay. Now, next we have the reaction of lanthanoids with water at room temperature form dash and liberates. Okay, again the same answer. The reaction with lanthanoids with water, what they form with water, they form hydroxide, that is LnOH. This is thrice. These kind of hydroxide they form, and with hydrogen gas evolved, right? Just do the cross valency. With water, they have OH negative, H positive, so the cross valency, it will have lanthanoid hydroxides, right? The oxidation of lanthanoid with sulfur leads to the formation of sulfides. With sulfides, what kind of sulfides? LnS3, right? What kind of sulfides? Ln2S3, right? Sulfide has S-2, this has Ln3 positive. So cross valency, it will have Ln2S3, right? Next we have lanthanoids also react with nitrogen to form nitrides. What kind of nitrides are formed here? Everybody in the chat box, what were the nitrides that were formed? That was Ln, N was the nitrides that were formed, right? Okay, now we have just 30 questions left. Okay, 30 questions left. So there are around 115 questions that we are going to do today. Okay, let me drink some water here. You answer this question. Let me drink some water here. Okay, perfect. Actinoids are believed to have electronic configuration of dash and variable occupancy of 5f6d subshell. So we are going to talk about actinoids to believe to have the electronic configuration. What is the electronic configuration that they have? That is 7s2 and the variable occupancy of this and this. Okay, this is fixed, and the variable occupancy of 5f and 6d orbitals, right, according to the element here. The irregularities in the electronic configuration are due to the stability of this. Okay, similar to stability in this what series? Similar to stability in the lanthanoid series. Okay, similar to that, f orbitals should be 0, 14 or half filled, right? The actinoid contraction, because of this, what are the consequences? And the greater from element to element than the lanthanoid due to the poor shielding. Very important question. Very important question, and very general question from D and F block. And now we are doing F block, right? So why it is so? Because of the poor shielding effect of what? F orbitals, 5f electrons, right? That is because that is the reason actinoid contraction is greater. Okay, the oxidation state of actinoids generally start from +3 and can increase up to +7 as shown in elements. So now they have like the variety of oxidation states in actinoids is like too much. Okay, that is why the questions are too complicated, and they don't usually ask like direct oxidation states. Okay, they don't usually ask oxidation states. The oxidation states of the particular elements are asked from D block. Okay, so now here there will be general questions like the oxidation states of actinoids generally start from +3 and can increase up to +7 as in the elements like protactinum and neodymium. So they will not ask these kind of difficult questions in your NEET examination or board examinations. Okay, So actinoid with actinoids, the question are very less. They focus on D block more. They focus on dichromate, potassium dichromate, potassium permanganate, its oxidizing properties, right? But still they ask few questions that are sure shot that they are going to ask. Okay, I'll tell you what are the questions they ask. Actinoids have dash which are comparable to lanthanoids, have similar properties and gradual variation in the properties. The variation in the properties. What happened? Where are the students going? It was like, did I see something wrong here? Did I see something wrong here? So actinoids had dash which are comparable to actin. So what is the what they have? The contraction effects which are comparable to lanthanoids, showing similar property and greater variation in properties. Okay. Actinoids, especially when finally divided, are highly reactive and combine with most non-metals. Why they combine with most non-metals? What is the reason behind that? Yes, everyone. Yeah, the topics that have been removed, you can just skip that topics, okay? You can skip those topics. Actinoids, especially when finally divided, but the potassium dichromate and all these things are in your syllabus. So actinoids, especially when finally divided, highly reactive and can combine with most non-metals at what temperature? At moderate temperature even they can react there. In the photographic industry, the compound relying on the special light sensitive properties of silver is? Important question. Again, this is important question. In the photographic industry, the compound relying on the specific light sensitive property of silver is? Important question. No, at moderate temperature, not at high temperature. The temperature will be moderate. The compound here is AgBr. Okay. This is photosensitive. The compound Ti, this is important. This is very important, very important, very important. So the compound TiC4 with this compound forms a basis of dash catalyst used to manufacture polyethylene. Now this is very important question. Mark this important. Mark this question important. Okay. Mark this question as important. This can be asked. High probability. Okay. So yes, very nice everyone in the comment section. What will the answer? Ziegler-Natta catalyst. Okay, Ziegler-Natta catalyst. You have to remember all the combinations here. What is the TaCl4, Al2C2H5? What is the formation? Why it is used? Though polymers are not in your syllabus, but this can be asked. This polymer can be asked to you. Okay, this can be asked. Though polymers are not in your syllabus, but this can be asked because of Ziegler-Natta catalyst. Okay, guys. Okay, perfect. Now let us do next question, that is this complexes are useful in polymerization of alkyne. Very important. Why? Because polymerization have been removed from your syllabus, but they can ask question from this one. Okay, alkynes and other organic compounds such as benzene. Dash complexes used in polymerization. What complexes are useful in polymerization? Nickel complexes. We use nickel complexes in polymerization. If you know the polymer chapter, the catalyst that is used is a nickel-based catalyst, okay? Right? Next, we have reduction of this to this is an example of redox reaction involving transfer of how many electrons? How many electrons from this to this? From this to this. How many electrons are being transferred? Just calculate the oxidation state and see the difference in the electrons here. Okay, just calculate the oxidation state. What is the oxidation state here? This is -8 is equals to -1. This is +7. Okay, and this is x is equals to +2 only. So you will see from +7, is this +7? 4 to 8. Yes, this is +7. Example of redox reaction. No. +7 +2. 4 2 positive. Just skip this question for now, okay? Yes. So now one of the most important uses of D block elements, specifically iron and steel in the construction of, okay, this is an example, simple example here. So building and bridges. Next we have in comparing acid base character of chromium oxides, CrO3 is an example, CrO3 is an acid while CrO2 is. Now this is important. This is an acid and what is this? What is this? What is this? What is this, bacha? Everyone, what is 87? What is 87? The compound of the, but this is a Ziegler-Natta catalyst. They are just showing that they are asking these components are this is a Ziegler-Natta catalyst used in polymerization process. Okay, so these are the different catalysts like V2O5 vanadium oxide. Then you have nickel, where nickel is used. Then you have V2O5 in the oxidation of SO2, that is contact process, right? Then you have Ziegler-Natta catalyst. This is the Ziegler-Natta catalyst that is used in the formation of polyethylene. Okay, different catalysts of iron that are used in hydrogenation. And then you have photographic industry relies on the special light sensitive properties like AGBR. So these are all the applications. These are the application part. Okay, the question are directly asked from here. Okay guys, now you have, next you have, okay, so this is amphoteric in nature and this is acidic in nature. Next we have potassium dichromate is prepared. Again the preparation by solution of sodium dichromate with what? With potassium chloride. Okay, then potassium dichromate solution is prepared. There are 2-3 steps involved in here. You have to remember all the 2-3 steps of preparation of dichromate, potassium dichromate, as well as the preparation of potassium permanganate. The 2-3 steps you have to remember all the steps. Okay. Next we have the oxidation state of this. Okay, what is the oxidation state? Just calculate the oxidation state, put -2 in oxygen. Calculate the oxidation state here. Okay, oxidation state here, 2x minus 14 is equals to -2, 12 by 2, 6. Okay, again this is +6, right? Okay, oxidation state is +6. The greenish compound, very important, we have done this before also, is commercially prepared by the alkaline oxidative fusion of MnO2 followed by electrolytic oxidation of manganate 6. We have done 2 things here. Okay, we have done 2 things. The greenish compound, what is that greenish compound? What is that greenish compound? We just also remember the color, where the color is orange, yellow, greenish, every compound color. Okay, color of every compound here. So the color is KMNO4. Okay, the color is KMNO4. So chromium 4 compounds like this are known to be strong oxidizing agents. Why they are called strong oxidizing agents? What is the reason? Chromium 4 compounds like what are strong? Potassium dichromate are strong oxidizing agents, right? The dichromate ion, this is the dichromate ion, can undergo reduction in acidic medium to form dash ion. It is a very good oxidizing agent, reduces itself, and every case, how does it get reduced to? Where does it get reduced to? It get reduced to Cr3 positive. We have done this before also, okay? In acidic medium, in the form of a reaction, we did this, okay? In the form of reaction in acidic medium, what is the conversion? Where does it get converted to? Cr3 positive. Then in acidic medium, dichromate ion reduces iron 2 positive, which are turned oxidized. Now this is also important. All the reactions or potassium permanganate and potassium dichromate, it oxidizes I negative to I2 in acidic medium, in basic medium, what happens in neutral medium, everything, okay? There are 5-6 reactions based on this. All the reactions are important for you, okay? All the reactions are asked in the PYQs. So this is iron 3, it gets converted to this iron 2 positive to ferric ions. The preparation of potassium dichromate involves crystallization from a solution of sodium dichromate and potassium chloride. Okay, we have done this, resulting in the formation of dash crystals. What is the color of that crystal? Everybody, what is the color of that crystal? What is the color? Everybody in the chat box. Yes, bacha. The color is purple. What? We have done something wrong. What? We have something wrong here. Like the question, this compound like this are known to be strong oxidizing agents. Where have we done this? The greenish compound. Here it will be K2, right? Okay. Here it will be K2. Yes, KMNO4 is purple color. Okay. Next we have in acidic solution dichromate. Okay, we have done this. Then this also. Okay, so here the crystals is of the preparation of potassium dichromate. The crystals are of orange color, right? Next, we have a preparation standard in volumetric analysis. So when we do the titrations that are also in your syllabus of practical chemistry. So for volumetric analysis for titration is dash due to the high purity and stable oxidizing power of solutions. Okay, so titration is potassium dichromate, the primary standard. This is taken, right? KMNO4 or K2Cr2O7 both are taken. In volumetric for the titration is this due to high this and this. Okay, both are taken for titrations. For titration we take KMNO4, K2Cr2O7 both. In laboratory, manganese 2 iron salt is oxidized by dash 2 permanganate. We oxidize this manganese 2 positive to what? We increase the oxidation state. Okay, we increase the oxidation state. Yes, very nice. We increase the oxidation state to peroxodisulfate. Okay, from +2 to +7. Okay. Okay, so it is oxidized by peroxodisulfate to the permanganate ion, to manganese 2 positive to permanganate ion, that is +7 oxidation state. Okay. Next we have the permanganate ion. Again the questions are repeatedly asked here. The permanganate ion is dash and its intense color and dimagnetism can be explained by the molecular MOT, molecular orbital theory. So permanganate ion is dash and its intense color. What is the color of permanganate ion? The color, okay, it is tetrahedral. Sorry, we are talking about the MOT, that is the shape. The shape here will be, we'll do this in chemical bonding. Okay, how the shapes are defined. Acidic permanganate solution oxidizes, oxalates to carbon dioxide and dash to free iodine. Very important question, very important question. We have done this. We have done this before also. We have done this. So guys, we will take the organic chemistry first. Okay, we'll complete the organic chemistry. One day, one chapter. And after that, we'll start with inorganic chemistry. And after that, physical chemistry. Okay. So now we have acidified permanganate solution oxidizes, oxalate to carbon dioxide and to this, that is iodides to iodine. Okay, the neutral faintly and alkaline solution. Again the same question is being asked here, I negative to I2, right? I negative to I, okay, so this is neutral or faintly alkaline. Okay, so sorry. So this is the acidified. As I told you, in acidic medium, different reactions happen. In basic medium, different reactions happen. So in this case, this iodide is getting converted into iodine free ions. And here the iodine, very important. Okay. Acidic medium, what happens? Basic medium, what happens? Especially in case of iodide ions. Okay, so now here the iodide ions are getting converted into IO3 negative. A very important. This is in basic or neutral solution. Next is in the presence of hydrochloric acid, permanganate titrations are unsaturated since HCl is oxidized too. So you're saying in presence of HCl, what happens? What happens in presence of HCl? Have the formation of what thing? What thing is formed here? In the titrations, why H2SO4 is used? Why HCl is not used? Because it leads to the formation of chlorine and itself is a very good oxidizing agent. That is why HNO3 is not used, chlorine is not used, because HCl it forms oxidizing agent. In HNO3 itself is a very good oxidizing agent. So that is why H2SO4 is used in titrations. Potassium permanganate forms dark purple color, almost black crystals, which is isostructure with those of. Potassium permanganate has a very dark purplish color, right? Very dark purplish color. This is due to the presence of those of KClO4, right? Okay. Similar to that. Besides its use in analytical chemistry, potassium permanganate is used in decolorization of what? This is also for test for what? Everybody. We have done it so many times. Though I have not taught you this chapter, but we have done this so many times. What is this? This is for the unsaturation. You directly write it as for testing the unsaturation. testing the unsaturation or the oils. Okay. Next we have in a redox reaction the permanganate ion, this is reduced to this in acidic medium. In a redox reaction, what happens in a redox reaction? The permanganate ion MnO4 negative is reduced to which in acidic medium. What happens here? Very important, very simple. This is reduced to which state? Yes, bromine water is also unsaturation test, but here we are not talking about bromine. Here we are talking about the the potassium permanganate chemistry. Okay, this is also under the unsaturation only. In redox reaction, okay, we have done this. This is Mn2 positive reduced to +7 to +2 state. It gets reduced to +7 to +2 state, right? Then we have, this is using favorite oxidant in the preparative organic chemistry and for bleaching of textiles, which is used, which is the favorite oxidant, guys. We have done just this before, because potassium permanganate, right? We have done this, right? It is also used in bleaching industries, bleaching of textiles. Potassium permanganate is acidic solution oxidizing this to this, very nice, which is indicating the chain of color from this to this. Which color change is observed here? +2 to +3, which color change is observed here? Everyone in the chat box, which color change is observed here? From green to yellow color change is observed here. In the presence of acid, potassium permanganate can oxidize. Now this is another question. All the oxidations here are important. All the reactions are important. Okay, all the reactions in this case. You will see actinoids are not very important for you in this chapter. The exceptional properties, the trends, not even the trends, the maximum and the minimum melting point, ionization enthalpy, electrode potential, oxidation states, and after that these two compounds. These are very important for you, right? Okay, in the presence of acid, permanganate can oxidize NO2 negative to nitrates, that is NO3 negative. Okay, guys. Done, everybody. We have completed 110 questions today. So now what is your task? Do one thing. So what are the important things from this chapter? First is the trends, exceptionals. Okay, exceptions, maxima, minima, and tables. Okay, graphs, maxima, minima, unusual trends. Okay, unusual trends. Okay, then we have KMNO4 and K2Cr2O7. These are important for you. Its oxidizing properties, its preparation properties, acidic medium, neutral medium, alkaline medium, everything. So do these things from this chapter. Okay, the question that are going to come from this chapter are from these topics only. Okay, guys? Yes. Okay, guys, everyone, will you do the chapter? You just need to read the chapter. Okay, read the chapter. You will understand every single line from this chapter is important. Every single line. When I'm stressing you about it, all the lines are important. Just make the questions yourself. And then I am sending you the PPT here. Okay, open your book and underline the lines from where the questions have been taken. Okay, because this is the result of so much hard work. Right, so much hard work. So that is why I'm saying PPT will be provided to you. After that, just open your textbook and I have snips also. Underline the questions that are asked from every single line, and all the snips that I have provided here about the tables, the graphs, underline everything. Okay, guys? Yes, perfect. Don't worry, Sharath, we will do that. Firstly, in the structure of atom, we will understand what is spectrum only, what is absorption and emission spectrum. After that, we will do what is charge spectrum, okay? We'll do this in detail, don't worry. This is just your revision. This is just for your revision to make you understand what are the questions that are going to come for your practice. Okay, guys? Yes. Okay, guys, so my name is Diksha, okay? Okay, guys, and bye-bye. Take care. See you all. My class will be on Tuesday. And on Tuesday, I am going to teach you. haloalkanes, and haloarenes. Okay, I'm going to teach you haloalkanes and haloarenes in detail with conversions, with PYQs, with all the questions that can be asked. Nothing is going to come beyond that. Okay, always do attend this lecture. We are going to finish the whole lecture here, including what is SN1, SN2. Usually the question are being asked from which will follow SN1, which will follow SN2. So we are going to cover all the expected questions in the session. Tuesday sharp 5 p.m. Okay guys? Yes. Okay then. See you all the very best, and keep learning, keep smiling. Always have this energy in you. Always keep working hard for your dreams, because if your dreams are big, you need to work hard. If your dreams are smaller, then okay, things are easy for you. But your dreams are to become a doctor, and becoming a doctor is not an easy task. Saving someone's life is not an easy task. Being a doctor is equivalent to being a god, because you are giving life to someone, you are saving someone's life. So you need to work hard, not now, but even after 5, 6, 7 years, because this tag of a doctor is not that easy. Even when you get, the journey is not till now, okay? It's just beginning of that journey. You have just started here. You work for your NEET examination, clear that NEET examination, get to the best medical college out there, and after that study for your MBBS. There you will make friends, you will make new friends. There will be fun also, because you are in college then, but also you will be responsible for so many lives, so you have to study even after that. But that will be very interesting, because you are studying for your dreams, and when you are studying for your dreams, anyway you have to do the hard work. Even if you're not a doctor, even then you will do the hard work. You will have to earn financially, right? You will have to do the hard work. Then why not do the hard work where your heart is? Your heart belongs to doctor. Your heart belongs to the line of doctors. Okay, you want to be a doctor, then why not? Then why not firstly get admission to MBBS college, and after that do that hard work, right? Yes. So one is asking important chapters for 120. So you can check the shorts. Just go to this channel, NEET English channel. Okay. Here you will see in the short section, you will see here what I have mentioned here. But okay. Top 40 topics. Here you will see top 40 topics of 160 plus in NEET. Just all the topics, take the screenshot of this and prepare all the topics well. Okay, prepare all these topics. These are very, very important topics, okay, for your NEET chemistry. Okay, guys. Perfect. Okay, guys, all the very best. I'm so happy you studied for 5.5 hours. Very nice. I'm so proud of you. Always keep smiling and be happy. Good night. Take care. See you all on Tuesday. Bye-bye. Take care.